Okay, welcome to the second day of AMT2025. It's really wonderful to have all of you here with us again for the concluding day of the conference. Just as a kind of a recap, we began on Thursday evening with a keynote lecture by Marlon Blackwell, as well as the workshop openers. And those workshops are concurrently happening with the bamboo build and some other wonderful things happening. And then yesterday we had some really engaging conversations. I believe that one of the participants said that the conversations that are happening here are world-class and that they're very important conversations that just need to be happening. So happy that that's the case and that this venue is providing that opportunity. Today we have another great opportunity for dialogue, and I think that's going to be really engaging. And we've had great audience participation and thoughtful conversation. So we're hoping that will continue. Please feel free to engage. And we're beginning today with a real heavy hitter, Dora Epstein Jones. She's definitely a force to be reckoned with. She'll take on the likes of Jeff Kipnis or Hernandez Alonso or anyone else that tries to cross her path. And so please be ready for some very thoughtful, thought-provoking ideas and provocations. And with that, I'll turn it over to Dora. So this is the secondary mic that's connected to our live stream.
So both of these are in play. Yeah. All right. Cool. So like the Houston's outfield. And after both of these are in play. Both the wall and the flagpole. I'm sorry, sports fan. Hi, and welcome to the session, Material Theory, Innovation, and Circularity. I want to note before we start that, and I want to commend Spencer, that I think that in our fields, we don't have a lot of opportunity for peer review and for conferences. Most of our conferences are all kind of under one umbrella or two. I can think of ACSA and Acadia come to mind. And I think that we need more venues for peer review and for publication, which is what this will become, and more opportunities to discuss and have discourse about what we're discovering. And I want to commend Spencer on pulling together and creating an entirely new platform for peer review and for a conference and for a publication. And I'm going to charge all of you with helping making sure that there is an AMT 2027. But before I do that, I want to congratulate Spencer on this remarkable achievement and thank you for taking the initiative for doing. So, you know, I no longer like the crutch. That being said, it's a really strange language crutch we're using these days. It used to be the word amazing. Everything was amazing. Now it's that being said. But that being said, I am going to be chairing the session, Material Theory, Innovation, and Circularity, or what do you do with all of the stray papers that don't fit neatly into the other categories, and hope to either get some co-parents or maybe enjoy the range and the breadth of thought. We only have 3 presentations this morning. I'm going to kind of make sure that they're running on time, but this should give us plenty of time for conversation. And so after each presenter presents, I'll be opening up to Q&A and then I'll talk for a little bit about things that are kind of meta and to this discussion. And then I hope that we'll just sit down and have the panel because we do have enough time. But to my presenters, you know, I'll be checking the time a little bit. So they don't know who's going first. So this is kind of fun. Chris Humphrey is going first. And Chris Humphrey is the director of fabrication at Rice University. He is part of the NSF Innovation Corps and awarded an NSF funding for his cladding research. And today he's going to talk with us about acid mine drainage, which just sounds amazing. So that being said, I'm going to hand this over. Now, pardon the technical, if you need a musical interlude or something while we deal with technical stuff, I'm happy to provide it. Come on, come plug in. I can fill the awkward space of time while you're plugging in if you want. Yeah. Bam, bam, bam.
Great. Are you able to hear me already without the microphone?
No, you should use the microphone for the stream.
Okay.
Yeah.
Yeah, thank you so much for the introduction and for the opportunity to speak with you all today. I'll be sharing some work that's a bit personal. I come from the Appalachian region, which I'll be talking about today, in Ohio. And so the work that I'm presenting is called REFD. Looking at from environmental pollutants to building products. The work is situated in the Appalachian region of the United States.
Can you get that microphone up a little bit
closer?
There you go.
Okay. In the Appalachian region is one that has long been exploited for its natural resources. In particular, I'm looking at the Mid-Ohio Valley region, which contains a swath of counties that border the Pittsburgh, or the Pennsylvania and West Virginia area along the Ohio River. Most notably, this region was one of the largest producers of bituminous coal in the United States, and also was credited for the steel production, bituminous coal being one of the most important elements to produce steel. And so Appalachia doesn't get much credit when it comes to architectural discourse, but in reality, the resources that were extracted from this location went on to fuel the Industrial Revolution and the expansion of steel construction in the United States. Interestingly enough, coal and clay have similar hypotheses, meaning the way in which organic matter settles out when the marshes that formed initial coal beds formed. Clay was also formed in that same way, where the heavier sediments, the silicas, the alumina, those materials settled out beneath. And so often when you find coal veins, you frequently find clay as well, which led to the production of a lot of clay and clay products in Appalachia as well. So coal came first, clay came second. At one point in time, Appalachia was home to over 2,000 of the national 5,000 clay and brick paper production facilities. And so the railroads that were used to transport coal became a secondary transporter of all the clay and terracotta products. After coal and clay, the bricks that were produced went on to create kilns that were used in the production of pig iron and other materials. And then we started to see the immigration from Germany into the United States, where production of architectural terracotta, things such as roof tiles or early ideas like the mathematical tile for facade cladding were beginning to be produced in this region. Most notably, the two materials are mixed in a firing process called a tunnel of love, in which terracotta tile are packed interspersed with coal. The kiln is sealed, the coal is lit, and when everything burns out, you have completely vitrified terracotta products. Notable to the world of architecture and design, At the 1904 St. Louis World's Fair, a series of bricks won first place in the design category, and these bricks were raised and sized as means for giving additional traction to horse hooves and later early rubber tires. Notable to our location here in Indiana, the brick plant, it was in my hometown, received an order for 3.2 million pavers to lay the initial base of the Indianapolis Motor Speedway. And so, interestingly, if you look at the core of the Speedway, you can still see a lot of those early bricks located at the bottom of this track. A once super prolific region has faced what was a post-extractivist economy in the sense that most of the mines are gone, a lot of the production has left, and what you see are traces of abandoned coal infrastructure, kilns that were once fired, some never being unpacked, so you can actually go and hike to some of these kilns and see traces of its previous production. Blast furnace that once produced iron are now empty, and most notably, the rivers run orange with something called acid mine drainage. And so acid mine drainage comes from a process where sulfur-bearing rock is exposed during mining. That rock mixes with the groundwater, producing sulfuric acid. The sulfuric acid then goes to leach iron oxides out of the rock that were once used to produce iron ore. Currently, there are 6,650 stream miles of polluted river in Appalachia. And one of the seeps, the seep that I'm working with, produces 988 gallons of acid mine drainage per minute, precipitating around 2.2 million pounds of iron oxide and manganese dioxide acid mine drainage annually. People are trying to work with it. And so one notable startup is a group that is looking at taking this acid mine drainage and producing harvest paints. But being in the AEC industry, we have a luxury of scale. And I think we have a responsibility to use that scale. So of interest, a lot of my work deals with cladding and building enclosures. And so taking a look at the numbers, we currently stand in a market where there's a 1.8 billion valuation for terracotta cladding, but it's expected to grow exponentially over the next 10 years. Following an invitation to participate in the Boston Valley Terracotta Ceramics Assemblies Workshop, I had to develop some kind of project. And so this is where the work really begins. Taking acid mine drainage and trying to develop early studies in how this could be applied in the terracotta glaze resulted in things that are really brown. And so it led to some early alchemy, I guess you could say, in taking common artist glazes and trying to work with this well-known pigment of iron oxide. Early tests on standardized clay bodies from a local ceramic shop yielded results that extended a little bit beyond the early dark brown color palette to start to play with some of the idiosyncrasies of the pigment. Interestingly, moving that series of glazes to a shell body that was local to where the acid mine drainage was being mined or reclaimed led to a series of really strange changes. Notably, things that were once matte and flat became quite glossy, things that were bright, vibrant and blue became very beige and dull, and things that were simple and black began to reveal speckles and a variety of other colors. And so when you're working with standardized ceramic materials purchased from a ceramic store, it's all unified to be the exact same formula time after time. However, working with a really unrefined local material means there's always going to be slight variables in to make sure that you're receiving from the earth. And so this led to an exercise in trying to source as locally as possible. So working with the Ludowici roof tile, they were one of the earliest roof tile producers in Appalachia. They are now the only remaining. Working with them to source clay and clay product, as well as true pigment to be able to source reclaimed iron oxide, in silica, in kind of a crude form, as well as spent foundry sand. Further refinement of the glazes led to a set that had a little bit of variety. So darker oranges, greens, glossy grays, speckled blues, and then a series of black. So maybe not the most exciting colorways that you would find at a local ceramic shop, but the impact doesn't come from the color. Thinking about the company that exists and the craft of artisans and the processes that they use, trying to scale the glazes into a system of digitally reinterpreted facade pieces, looked at utilizing a 3-axis zoom knife cutter to study, can we begin to augment the manufacturing process to be able to work with kind of a crude clay body. So early tests created custom modules for the zoom that took common tools of clay craft, such as ribbon tools and other carving tools, and sought to translate the original motifs of brick production into a digital version that would have some relationship to the glazes. So the materials are being mined from this location, but also the design and clay motifs are being mined as well. And so in working with this process, it allowed to also think about the way in which glazes are placed on products. And so typically you apply a glaze at the final step before entering the kiln, but in working this way, you could think about pre-glazing tiles and then removing that material to reveal the raw earth beneath, leading to a series of really small coaster scale tests, just to see the glazes and how they interact with one another. Thinking through those motifs further, and how things like linear patterns or starboard patterns will be transformed into tool paths for the zoom. With each of their color line here representing a different depth or cutting operation that can be conducted with the machine. So those early tests were done to produce a series of 24-inch facade tiles, still with the goal of the work, to produce something for this exhibition of Boston Valley. And trying to think through how I could augment, a standard clay production process in the manufacturing setting. Additional motifs are translated into a variety of things. So thinking about how the clay can be carved to increase apertures or openings in the clay that is typically difficult to do with standard clay production processes, or think about how these could begin to tile in a way that makes sense with digital production. So not every piece is the same repetition, but you can start to produce variability in the tile as it's being produced. Or how these could tile together in a way that you don't typically see flat terracotta products. The second way of thinking through the material was trying to look at kind of more simplified processes of craft. And so a technique that's utilized in factories is something called hand slushing, where sand and clay is mixed together and placed on the surface of a tile to produce a variable texture. In thinking through quick interventions and trying to, again, play with those motifs, simple acrylic and polycarbonate screens were produced, in which mimicked the screen printing techniques of graphic production, where the screen could be placed on the tile and the hand slush over top, remove the screen and reveal a series of patterns using that same hand slushing technique. One of the issues that we quickly ran into is a lot of pneumatic spraying and industry-based glaze application processes rely on super clean glazes. And so, again, going back to the standardized materials that you would typically purchase at a ceramic store, those are all sieved to a really fine grain. We quickly learned that after clogging a couple of pneumatic spray guns, that the level in which this raw clay body was sieved was insufficient. So leading to rethinking how the glazes are processed, and trying to negotiate the fact that there are tiny bits of rock and gravel and sand located within the clay itself. But a small production run of these led to rethinking kind of standardized 10-inch by 16-inch roof tile that now bears the motifs and the materials of the region in which the clay was produced. From that point, I've been working with the Beesley Roof Company to further refine all of these mixtures to begin a production run. And so these were 3 that have been identified as being promising. And at the scale of the test tile, they're quite minuscule in what they're able to sequester. But at the scale of a 10,000 foot facade, we're able to sequester 200 pounds of the iron glaze, 160 pounds of iron, and 55 pounds of manganese dioxide with the RB1 glaze, and 230 pounds of iron oxide with the RI1 glaze. And so a 10,000 square foot facade is nothing when the company produces millions of square feet of terracotta tile annually. So these glazes have been further tested for their ability to respond to varying textures and fabrication techniques. And the next steps of the work are going to be working with the UEC to further refine, and hopefully we'll start production on here in the next couple of months. That's going to lead into a series of customer discovery interviews to determine the actual value of the product in their market. And then the final step is working to expand the palette of materials available. So iron oxide and manganese dioxide are readily available, but there are tons of other additional forms of mineral waste that can be utilized in this process. Thanks.
Time for some Q&A. Does anybody have a question right off the bat? Yes, Joe.
Yeah, can you talk a little bit about, I'm curious, like, it seems like there's an emphasis on the digital craft. I find it interesting, but I wonder whether it's important or not and why you chose that element.
Yeah, I would say ultimately the digital craft is not important. The digital craft came about as trying to produce something interesting for a conference that was rather digitally focused. And so I will say that in working in tandem with producing the glaze and then trying to think about its digital applications, it did lead to a lot of questions of, you know, the glazes need to have a certain formulation so they don't run all over the place when they're being placed on a carved surface as opposed to a flat surface. And so that did kind of prompt some ingredients being swept out of the formula and others being introduced to try and, you know, keep the glazes from crawling or from crazing or doing other types of things that would allow them to respond to the geometry. So essentially the most important bit of the work is the glaze itself. But the digital did provide a little bit of feedback as to how they're operating that probably would not have been observed otherwise.
Kelly?
Yeah, just to maybe piggyback on that, I would imagine though that the digital fabrication part, as it scales up or as it goes into kind of production mode at larger scales, that there's some efficiency, there's quite a bit of efficiency that tooling affords over what I would imagine at scale is a very labor intensive, you know, kind of craftsman type thing. So I don't know, I feel like what's really nice about the project, thanks for the presentation, by the way, it's amazing. But what's really nice about the project is you can imagine the kind of human labor and machine labor maybe flip-flopping, but that the two in tandem would be always part of the kind of narrative of the project.
Another kind of market comment would be, I wonder if, you know, these American industries that have effectively almost vanished, it really is in part labor. And in order to have kind of bespoke or custom nature for the American supplier to be competitive, then maybe the digital does have a role to play. I would wonder if the CNC tangential knife is the right technology or if water jet and 3D printing are. But again, I think it's interesting just as a starting point. So how do we, what are the elements that would create more viable, you know, industry designer collaboration. If you look at, you know, any of the more contemporary companies like Zaner, for example, they're highly digital. So, you know, this, it's like you're actually, what you're maybe redesigning is the industry, right? And it's interesting whether or not the partner is really elastic enough to change the way it is rather than disruptive to the current practice.
Yeah, there is kind of an ongoing conversation around working to digitize the practices of the Ludovici company. These are all tested on 3D printed ceramic. And so, you know, they do have a kind of a vested interest in some of those areas, but digitization always comes back to craft with their processes. And so it's really, how do you kind of produce a new labor model in the factory right now? You start off as a tier 1 craftsman where you're basically just stamping tile, but you can work your way up to kind of the top tier craftsman where you are an expert at decorative carving. So there's a thought of like, how do we introduce a more contemporary tier where it's like, you're not only going to walk away with this industry knowledge of clay production, but also of digital manufacturing. And so there are those kind of conversations happening in the background, particularly around cobotics and how you can begin to augment craft with cobotics. But we're still in the early phases of that work.
Yeah, I think you kind of answered part of my question, which was about the state of the art of like current tile manufacturing. But I'm also wondering, like, you're calling them like coaster scale, but they're also like kitchen tile scale. I guess I'm wondering why you need to like scale up, or why the focus on the facade rather than like an interior tile finishing or exterior tile finishing.
Yeah, so these pieces are all at the scale of like a 10 by 16. A lot of the early tests were done at kind of the 4 by 4 scale, just because they were more economically efficient for me to produce. But the issue comes down to the temperatures in which kind of interior ceramics are fired. A lot of home porcelains are fired to a cone 10, which at that temperature, it's really difficult to render any variability or variety in the color of a material in a standard production. So I was really working with the materials and also the fact that the company that I'm working with only fires to cone 5. They have a very specific cone 5 firing schedule in which it has an 18-hour cycle, very different than like artist production in ceramic or other types of ceramic production. And so in theory, some of the browns or other colors that maybe are not as exciting could be made more vibrant if we were to fire in reduction instead of oxidation, but really limited by the current infrastructure the company is working with.
I had a question kind of about the scaling and refinement of the material. I was with such like a kind of craft-led material like clay and ceramics. I was wondering if you considered whether like refining the material is more important than developing like tacit knowledge amongst the folks using the material, and whether that's another route in terms of managing the material and using it at a greater scale, whether like understanding the nuances of the material on like very like tacit level would be another way, as opposed to like further refining it to avoid some of those problems, whereas maybe they could just know how to avoid those problems in the process. I don't know if that makes sense.
Yeah, totally. I think a lot of it comes down to trying, introducing essentially a new product into the market is what the goal of the work is. And in order to do that, they basically want as little resistance in their manufacturing process as possible. And so I think hopefully down the line, as we continue conversations around issues of craft and how materials are manipulated and worked with, that can be brought into those conversations. I think at this early stage, to get them to buy in, it's just like we need to be able to plug and play into what they're already doing in this like minimally invasive process as possible. But there's certainly hope that, there is nuances of this type of unrefined material that don't always work in kind of a refined manufacturing process. And so there should be a way to negotiate that.
You don't like, sorry, is it, I'm gonna like kind of ask, but kind of also observe for a second. This one that has the switch strip
Yes.
right there. Sorry. That drip is fascinating to me, and I think along the same lines of Avery's question, which is really insightful. Can you go back to the 1910 whatever winter? I think that's what the slide is literally called, the winter. Oh, 1904, award-winning grip. We just love award-winning. But so what's interesting about this, and maybe goes back also to Jonas's question about digital craft, is that in 1904, these are offered as a kind of proof that industrialized manufacture will not eclipse the decoration of building. And the beauty of them is what gives them their award, because what that demonstration of beautiful brick does is that it makes the industrialization of brick more comfortable to popular audiences that expect things to be made out of masonry and classicist decoration and so forth. And it seems to me that, but that's based on a super industrialized, efficient process. Whereas the work you're doing, I don't know if it's kind of proof of beauty, things like those drips and, and stuff like that are about that same kind of sense of mass manufacture and, but instead of a much more digital process, one that is inflected by craft, say, because I think that the fear of the digital is similar to the fear of the industrial in 1904. It's the sense, oh my God, digital is going to take, right? The fear of robots, right? The fear of end-arm production, and so forth. And I think that this question about digital craft is interesting because I think that that's been there in many ways to make people feel like, don't worry, the robots aren't gonna do. They're just gonna put some pretty glazes on that tile, and and so forth. And then furthermore, these drips and blobs and stuff like that may actually be what the manufacturer you're working with is fighting against. Yeah, that's been the case that the drips and blobs are not fun for them.
I think similarly.
It is fun. There you go.
Yeah.
Or I put it in.
I think to that point, the manufacturing processes they're looking to try and produce variability in a system that for the last 30 years has not produced variability, because people are investing more in kind of handcraft narrative a bit more, which comes out in things like the irregularities, the drips, that the process has been so refined to work against.
Right.
And so,
So they're welcoming that
they are
variability,
welcoming, yeah.
right? Yeah.
Within
Which
a series
is so
of,
different from the 1904 scene, because like the arts and crafts people split off from the industrialization people because of that. Yeah. So like, what were you going to say? I'm sorry.
so but it's interesting because even within that variability, you have to have refined control of what those variables are. So sure, dripping is great, but it has to be able to only drip a certain amount. It can't drip onto other things, so it's like, it's interesting that in artist production, there's a lot of room for mistakes in this particular process. You can make the variation, but it has to be in a really controlled setting.
Interesting. Well, any other questions? Yes, Jonas.
Just, I think, like, on the one hand, like, being more bespoke is interesting. The other hand, the impact you're talking about really is about removing these things from the water. And for that to have consequence, the product has to be massive in its application. Right? And so that I also find interesting is like, you know, those things are definitely intentional. Right? Like as makers, designers, we want to like virtually or digitally or physically craft the environment to make our own mark, to make life better for others, but also one of the ways you're operating is at a scale that requires lots of tiles and lots of ways to have an impact. And I would also wonder if it's one thing that for what it might do to the water. I do also wonder, have you looked at how it is tile making the best way to make a sustainable facade? I don't know at all. I do wonder like how you're asking this question.
Yeah.
Yeah, I mean, I think it's a good question. Embodied carbon is the thing that everyone discusses when we talk about terracotta, right? It's fired. It's there's a lot of energy that's put into that, and there's a really great diagram by Michael Green that shows one of his buildings, and it shows the embodied carbon of all the materials at the opening, right? Terracotta is through the roof. It shows the embodied carbon of the building as deconstruction. Terracotta is by far the most minimal amount of embodied carbon in the project. And so the enduring factor of these products and the fact that one of the things we're also looking at is how do you make the installation and removal of these more circular? Because right now, you know, like they'll last for, they have a 100-year warranty. They'll last for centuries. The way in which they're currently installed and they're constructed doesn't allow them to be reused very well. So that's a great question. I think that part of it comes down to the way in which we are working with them. And I think that there are better options for how they're installed, different assemblies that can be, you know, explored, because the material itself will last. Yeah, it's just the assembly that currently doesn't allow it to last as long as it could.
And so from a pedagogical point of view, I think that really exposing the trials, successes, the failures, and the messiness of what you can't do it all at once. Whether you start at the bottom or the top, the questions have to be asked in many ways, and exposing the holes and whether it really will work or not. So, you know, it's a reaction to a problem. To find the right reaction is going to take lots of experimenting and reflecting.
Next question to the brilliant Phillip Beesley.
Christopher, that was really, really beautiful and important presentation, and that I'm very tantalized by the comment that just emerged between Dora and you, talking about the reception of this 100 years ago, this kind of work, and the resonance with the project today of translation and perhaps into new digital enabling craft, where the agenda a century ago was not necessarily to qualify this material for efficient production, but rather but also at least to offer an acutely expressive humanism in the face of the dread of soullessness sweeping over the world. As another chapter of the Industrial Revolution, perhaps in a much older story, but the kind of anxiety or deep ambivalence about the enactment of this work, I think is a very interesting quality that perhaps asks for some new language to be developed today in exploring resonance. And just a couple of quick comments then. It strikes me that the almost relentless pattern, underlying periodicity that you're evoking is just as effective in revealing degeneracy as it is in achieving harmonization and qualification and the excellent and the good and the true.
Mm-hmm.
And because the material agency of this material is, if I can use a popular term, is profound. And by making it thin and by working right at the very threshold where pigmentation emerges, it's like a spectrograph somehow in terms of spreading out its radical localism and its difference. And I don't think that we have very happy examples of how to achieve diversity. In the last 30 years, diversity has been enacted and produced just relentless new equilibriums, like the arbitrary kind of apparently stochastic patterns on buildings. We know them. We know the static kind of randomness, which becomes just a new canon and becomes an automatism rather than a virtue. It loses its cool so very quickly. And yet, with this material itself, it seems so extraordinarily expressive. So I just want two more phrases then. One would be an older one, which is entarta, that dreadful word, meaning degenerate, coupled with sakrik, the pure essence of the Neue Sachlichkeit. I wonder whether that could be captured somehow as a source into primal existence, which gives me the language, I think, of raku in pottery, rather more than bone porcelain in the attempt to qualify the European traditions for the excellence of the Chinese and Asian crafts. Because in Korean pottery, at least, raku is the most extraordinarily valuable thing, just like the tradition of scholars' rocks as well. The access into truth itself and artlessness, most in Korean. And I wonder whether that kind of language might, in this kind of practice that you're showing, be a kind of a profoundly strong new ornament.
Yeah, I think maybe a little bit of so there's a lot to digest there. One maybe comparison to the raku process to this that I think deals with a similar issue of craft is the raku works because at a certain moment, at a certain temperature, you expose it to other things oxidizing the surface. And this particular process of salt firing, which is really kind of unique to this region, at that precise moment, a handful of sodium is tossed into the kiln. As the sodium bound with molecules in the air, produced this kind of gloss surface. So I think that there's just like in industrial production, yeah, there's a question of like how do you open a kiln at the right moment? And I don't mean that just as like literally, but also metaphorically.
Yeah.
And so that's one thing that we're trying to hopefully think through. Also is, what are those moments just make us start thinking about how do we augment this rather rigid process to allow for more moments of tossing the sodium in or exposing additional materials to have the value of the right looking with them.
Thank you, Phillip, for blowing my mind. And I will free you now. But I want to say that, to fill up the time, as Eric, go ahead and set yourself up here, and I'll fill up the time a little bit. But I'm really intrigued by this because I think there may be, and I'm looking at the work that like students were doing in Kelly Bair's presentation or the geomimetic properties in Neil's presentation. I think that there were a couple more, obviously Jonas and the work with the bamboo well, definitely like why these kind of like, understanding of the material as having behavioral properties. It may be that the post-Anthropocene work might be the most human of
That's great.
all of them. It might be. It might be in that sense of this one-to-one, almost primordial relationship to being.
Love it.
Yeah. I think that's it. But I'm just totally surfing off your comment. So, you tee it up. All right.
And now it's my pleasure to introduce Eric Harris as he sets up here. And then after Eric's talk, we'll have a little coffee break and then we'll come back for the third presentation. Eric is soon to be Dr. Harris. His mother has insisted that I refer to him as Dr. Harris. And so from this point forward, I will do that. He is an adjunct professor at the University of District Columbia, or UDC, and his doctorate is under the umbrella of urban leadership and entrepreneurship, which a doctorate in that is intriguing to me in the first place. And then soon to be Dr. Harris. It is focused on urban sustainability and resilience. Today, he's going to be talking with us about value inclusive design. Welcome, soon to be Dr. Harris.
Thank you. So feel free to get up. Normally, when I'm presenting, I usually do it as a conversation dialogue, but based on kind of like the flow of the paper, I'm going to do it kind of more as narrative. So I try to kind of complement it with some visualization. The paper itself only has like a few images within it, but I wanted to just make sure that I could convey some of the qualitative things for this particular paper. So if you get overstimulated, you can close your eyes and just listen to my soothing voice. Right. So again, thank you, Dora, for the introduction. So yes, I'm an adjunct at the University of District Columbia, and in the Department of Architecture and Urban Sustainability, I teach undergraduate level history and theory of architecture, CAD documentation, specification, estimating, and at the graduate level, I teach urban and community design. So a lot of things that I do is kind of interdisciplinary, a fusion of a lot of various things. So today, I am presenting the value inclusive design model, a pathway to sustainable, culturally responsive, and community-driven material commons. A very long title. Actually, I shortened it from what it was previously, so just bear with me. Since is the presentation clicker actually on right now? Oh, that's fine. That's fine. I can just advance. Okay, so here's my presentation contents. We'll just kind of go past that. So pretty much the paper explores the pivotal role of value inclusive design model, or VID for short, and fostering a robust material commons through its emphasis on community engagement and cultural relevance in material selection. The VID model advocates for the incorporation of diverse stakeholder voices, particularly marginalized communities, in the design process. By prioritizing communal input, designers are encouraged to consider materials that are locally sourced, culturally significant, and regenerative. This approach not only strengthens the community identity, but also promotes sustainable material practices that align with the principles of radical material responsibility. The influence of the VID model on material selection is profound, facilitating the use of resources that encourage environmental stewardship and social equity. For instance, utilizing locally sourced materials reduces carbon footprints while preserving regional identities and traditions. Regenerative materials such as bamboo or reclaimed wood support ecological health and resource replenishment. Furthermore, materials that resonate culturally foster a deeper connection to history and shared heritage within the community. In the context of shared resources, the VID model enhances collaborative practices by recognizing the importance of material common resources held collectively by the community. And this recognition can lead to the innovative practices such as material banks and cooperative workshops, allowing for efficient use of resources while minimizing waste. And by aligning design practices with the values and needs of the community, the VID model not only promotes equitable access to materials, but also cultivates a shared sense of responsibility among stakeholders. Ultimately, this paper argues that embracing the principles of VID is essential for creating sustainable, culturally responsive, and community-driven material commons, fostering a future that honors both people and the planet. So that was a lot of trying to make sure it wasn't word salad, but you guys should hopefully get the gist. So in the face of growing environmental challenges and social inequities, there's an urgent need for design practices that prioritize sustainability, cultural relevance, and community involvement. The VID model emerges as a transformative approach to material selection and use, promoting the integration of diverse community voices, particularly those of marginalized groups in the design process. This paper explores the profound impact of VID on the creation of robust material commons, emphasizing the importance of locally sourced, culturally significant, and regenerative materials. And so this first slide just kind of, again, we're kind of at a point where it's a little taboo to say DEI. However, I usually discuss it as JEDI, so justice, equity, diversity, inclusion, and just, tied to Star Wars references, and it's always good after that. Second. Yeah. So by fostering community engagement and prioritizing environmental stewardship, the idea not only contributes sustainable material practices, but also strengthens social equity. So just really showing it in the context in which we use materials in many different ways, many different facets. And so we want to continue to design more sustainable, as well as design for resilience. And so when we really think about that, we think about the inhabitants, the people that are engaging within those particular spaces, how they're utilizing that space, and what materials can really do for that. And so one of the things first I kind of just wanted to set the stage was talking about value inclusive design, like what it is for those who have not heard of it. So I'm just going to do just a little quick breakdown. So here it shows on this slide, there's 4 dimensions of social equity. The first being recognitional equity, procedure equity, and distributional equity. And so in terms as well as judicial equity, which is on the next slide, but pretty much each of these particular dimensions really helps to kind of determine whether or not communities or just even within a design process, if those things are actually being met. And so when we think about just particular communities, neighborhoods, et cetera, just making sure that they are celebrated, but also designing in a way, for example, in my urban community design course, we talk a lot about gentrification, redlining, displacement, and what that really means, even in the context of Washington, D.C., as well as other communities. And so being able to recognize those particular needs, and in my case, a lot of times I talk about kind of the theory side of it and translating that into practice or professional practice and what that really looks like. So just, kind of taking a lot of stuff that seems boring, necessarily boring, but really streamlining it in such a way that adds value and adds culture and adds depth that is very meaningful and transformative for particular communities. And so one of the things that I did, particularly in my research, was evaluate the dimensions of social equity, but in addition, I added a 4th dimension, judicial equity, to the research that I was doing. And so this particular slide here kind of talks about this particular dimension in the process for it. And one of the things I also then did was create indicators where I can, from a design standpoint, evaluate design processes. And prior, I actually did I have another presentation, which is like my first paper, and that kind of talks more about the built environment and how do you address food insecurity, how do you, kind of combat food apartheid, and utilizing that through a case study with a global design competition. And this, in addition, just, continues on with that research, just kind of looking at the materiality of things and speaking towards those particular communities. So here, the value inclusive design model, it expands on Sarah Miro's model for social equity, but also too, alongside that is social value constructs. And those social value constructs, identity, placement, accessibility for all, and empathy. And then I actually added a fifth transformation to that for my model. And so in addition with that is a design canvas for inclusion and judicial equity. And so across here, you see the various dimensions, but then you see kind of like how it's broken down into theory, but then translated into actual practice. And you know, this model can be used in many forms, but I kind of used it just in terms of, you know, how to address specific needs for a particular community, and you know, with the indicators allowing you to come up with design solutions or at least something creative that is impactful to the end users or that community. And so in terms of the materials themselves, I'm going to just be quick with this, but in terms of like definitions, this is in my paper, but just talking about communal materials. So material resources that are sourced from the community or symbolizes the community's identity. The VID model encourages designers to prioritize materials that reflect local craftsmanship or traditions. So for example, using locally sourced wood from community managed forests strengthens local economies and fosters a sense of ownership and pride within the community. But there's also two regenerative materials that are used to replenish and restore ecosystems, contributing to environmental health. And this model pushes innovation in materials that are sustainable and restorative. So for example, we actually had workshop on bamboo. So I'm really glad that someone actually extensively went through that. But again, while some of these materials may seem like fundamental, it also does speak to like the character and the heart in which we're building. Every city is very different. I've never been to this. This is the first time I've been to Columbus in Indiana, and it's very different than Washington, D.C. or Baltimore. And so in terms of what the community actually needs and how to speak to that, you know, we use critical thinking, we use different models, we use different design strategies to hopefully come up with something that is sustainable and improve the quality of life for us and those around us. And so we also have the culturally significant materials that carry historical or cultural meaning and resonate with the community's heritage. And that's very important because in many ways that is really talking about cultural expression and storytelling. So everything from incorporating textiles, pottery, stone, relevant to the community's heritage can strengthen cultural ties and ensure that design honors local narratives. One of the organizations that I'm part of is the Society of the Study of Architecture in Canada. And one of the things they actually do is an acknowledgement of the indigenous people at the beginning, like of their conference, to ensure that we are being respectful of those who live there, and being able to engage in a way that is very helpful and continues to uplift and build that community. And so similarly with shared resources community practices that encourages the creation of collective material banks where community members can share resources. And it also involves it allows societies to facilitate innovations that reflect collective needs and values. And actually my first paper kind of does talk about social values and the social values and constructs. And so, really just talking about this is, I'm trying to think of like the question I posed, but like, in terms of value, you know, what do each individual or communities value, and how does design speak to that? And so does design create value, or does value create design? And thinking of it like in that process. And so, as I mentioned before, I've utilized for value inclusive design indicators for design process. And so, in this case, the model itself supports transactions that convert into social equity. And the VID approach has an transformational stands where social equity is distributed equally through design, context, and interaction in inclusive design practices and thought processes. And the design considers the scale of the community by integrating heritage social values and transformative elements in order to promote economic investment, ease infrastructure preservation, revive neighborhoods, and ease the acquisition and advancements of jobs. These circumstances lead to transformation for sustainability and resilience when paired with social equity and inclusion. And this also applies to materiality and resources for community development and growth. And so I'll actually go through this hopefully pretty quickly, but in terms of community-driven material commons, there is a paradigm shift. And so the paradigm shift is in how materials are sourced, shared, and managed within communities. And it's rooted in the ideas of collective ownership, sustainability, and equity. Material commons challenge traditional approaches that treat resources as privately owned commodities. And instead, they promote a more collaborative, shared responsibility over materials, over material resources, fundamentally, shifting the relationship between society, environment, and design. And so there are key elements of community-driven material commons that increase significance and potential benefits in fostering more sustainability, as I mentioned before. And architecture is supposed to be the most material of all the arts, and therefore it requires a sustainable approach. And so at its core, the material commons refer to resources such as raw materials, finished products, tools, and techniques that are shared and managed collectively by the community. And so the VID model fundamentally is about relocalizing material resources, ensuring that the community has control over the material it uses and benefits from, while simultaneously ensuring that these materials are used in ways that honor ecological sustainability and social equity. So I was just showing projects just kind of around the world where the usage of materials is just used in just very creative and unique ways to answer the needs of their local communities. And so, I can just, yeah. So the role of community engagement in the value inclusive design model is an active involvement of diverse stakeholders, especially marginalized communities in the design process. And historically, design practices have often excluded these voices, leading to solutions that fail to address the unique needs and values of these communities. The value inclusive design model challenges this exclusion by advocating for the incorporation of community input into every stage of the design process, from concept development to material selection. And the inclusion of diverse perspectives ensure that design solutions resonate with the community's values, traditions, and cultural identities. Furthermore, engaging marginalized groups helps to correct power imbalances in the design process, giving them a seat at the table and empowering them to shape the materials that will be used in their communities. This shift fosters greater social cohesion as the design process becomes a collective effort that strengthens the bond within a community. And so for culturally relevant and locally sourced materials, one of the core tenets of the VID model is the emphasis on materials that are locally sourced and culturally relevant. This approach offers numerous advantages, both in terms of environmental sustainability and community well-being. Locally sourced materials such as stone, timber, or clay not only reduce the carbon footprint associated with transportation, but also supports regional economies. By using materials from local resources, designers can preserve the traditions and knowledge of local craftspeople, ensuring that design solutions are embedded in the community's historical and cultural context. Additionally, culturally relevant materials foster a deeper sense of connection and pride within the community. For example, using materials that hold cultural significance, whether it's a particular type of wood used in local construction or a textile with historical importance, helps to preserve and celebrate the heritage of the community. Hence our first presentation for today with the material that was shared. This practice reinforces a sense of belonging in community, ensuring that design solutions are not only functional, but also reflective of the community's identity. And so for regenerative materials, environmental stewardship, the VID model also encourages the use of these materials, those that contribute to the replenishment of resources and support ecological health. And again, materials like bamboo, hemp, reclaimed wood are renewable and require less energy to produce compared to conventional building materials like concrete or steel. However, there are sustainable materials that are used like bioconcrete, et cetera. One of the things I actually talk about in my CAD doc specification class is the use of sustainable materials and technology. And so my students are tasked with doing that as one of their projects. And so these materials have a much lower environmental impact as they are grown, harvested, and collected in a way that promotes ecological restoration, reduce waste. So for example, bamboo is rapidly renewable resource that grows quickly and requires minimal processing, making it a sustainable alternative to traditional timber. Similarly, reclaimed wood sourced from old buildings or discarded furniture not only reduces the need for new materials, but also reuses valuable resources that would otherwise end up in landfills. By prioritizing regenerative materials, value-inclusive design helps to mitigate the harmful effects of resource extraction, promotes biodiversity, and fosters long-term ecological health. And so this was actually moving graphics, but this is the PDF, so it's okay. But you guys kind of just get the gist with the images. So for the material commons and collaborative practices, the concept of material plays a crucial role in the VID model. Material commons refer to shared resources such as the raw materials, things that I mentioned prior. And so ultimately they're to reduce waste and ensure more equitable uses of those materials. Here. Also, the value-inclusive design aligns with the principles of radical material responsibility, which calls for a fundamental shift in how we perceive and use materials, rather than view materials as disposable commodities. VID encourages designers and communities to take responsibility for the entire life cycle of materials from sourcing to end of life disposal. This mindset shift promotes more sustainable practices such as upcycle, reuse, and recycling, while also considering the social impact of material choices. For example, by prioritizing fair labor practices and material source or selecting materials that are produced with minimal environmental harm, VID promotes social equity alongside environmental sustainability. Designers are encouraged to think beyond the immediate needs of their projects and consider how their material choices will impact future generations, both in terms of environmental health and social justice. Citizens need to be a part of the design process to co-create their neighborhoods, wards, and districts. This includes orchestrating inclusive planning and design processes that acknowledge human needs and dignity, foster participation and shared decision-making, and resulting in healthy environments.
So if you
Okay.
just that 20 minutes.
Okay.
Yeah.
Okay, I'm at the 20-minute mark.
Yeah.
Okay, so I'll just move it along faster. So one of the things just kind of proposed, one of the most effective tools in that is material banks. And so they function as shared storage spaces with access like wood, metal, fabric, et cetera. I'll go through this really quick. So again, as mentioned before, just materials, bamboo, corded steel, plain wood, hempcrete. And so in terms of impact or challenges, materiality plays a crucial role in the manifestation of architectural concepts into tangible experiential spaces. While the concept of community-driven material commons hold immense potential, there are also several challenges to consider. And so I won't go to that. Just move along. Okay, so one of the things I also wanted to just kind of show was just practically when I'm thinking about the value-inclusive design model, how you actually applied that to the design process. And so these were just like several projects that was from the global design competition that I was a part of. It was a partnership between UDC and Boston University and Research. And so just wanted to kind of just show various projects and how they applied those solutions for to hopefully mitigate food apartheid or food insecurity, but then also to using architecture as that tool to build a urban farm or reimagine that site. So I thought this was like a really good practical examples of that. And so in conclusion, the value-inclusive design significantly influences material selection by prioritizing communal engagement, fostering regenerative practices, and honoring cultural significance. And I wanted to show these because, or actually, possible. Yeah. So in terms of environmental stewardship as well as social equity, I wanted to show these individuals because these are like designers, architects that work in spaces. So of course we're all able-bodied, but then this also too speaks to people with disabilities and how you also use materiality and design process to think about whether you're deaf, blind, have autism, and what that means in the design process. So we do think about and talk about a lot about universal design, human-centered design, and how we, which was great actually for Chris Downey. He actually, I was able to be on a conference where he was just kind of sharing, just like with using materials, you can prevent people from like going into the street and getting injured. Yeah, so I'll just conclude with that because I'm actually out of time. This is my dissertation committee. Thank you guys for listening to my presentation.
Questions for Dr. Harris?
I have a question. I'm not sure how to formulate my question. So kind of bear with me. So I'm a professor in Washington University in St. Louis. And I mean, so first of all, thank you for this topic. That was a lot of information. I look forward to reading the paper and kind of going over it in more detail. It's a topic that I think there's a lot of need for right now because particularly in what I'm teaching, there's a lot of interest in this topic, in a particular place like St. Louis, where there's huge social inequities and a great need to try to understand the concept of how to use design and urban thinking to address these social inequalities in addition to the sustainability. And we're constantly struggling as architects. We're kind of like in an amateur way trying to dabble in this, and you formulated this in a very systematic way that I really would like to take the time to parse out. But the question I have is in a place like St. Louis, and I would project this probably to Detroit and some other cities, but I know particularly St. Louis, there really isn't like a local craft tradition anymore. I mean, it's like it got industrialized, and even the brick industry has kind of fallen apart, and there isn't necessarily a sense of local craft, local culture. I mean, there are pieces of it, but this is where engaging in particular communities that have been divested and marginalized for decades, maybe even centuries. There's not even, when I've done projects where we go into work, they're basically asking for things. And when you try to parse out like what are the key narratives, you do get some narratives, but it's really hard to translate that into materiality when you're talking about using local materials and local craft, because a lot of the local materials are actually materials that they would say are materials of oppression or of marginalization. And so there becomes this need to kind of bring in new materials. That's where actually, I mean, bamboo is something that I've been bringing into St. Louis, but it's not a local material. It's thinking about trying to actually recreate craft traditions or craft traditions that are actually coming in from outside. And I'm wondering how you would react to that. It's this. I'm not sure how I'm formulating the question. It's like the idea of it being in place. There's not necessarily something there to attract to, and it's kind of growing it back. You know what I mean?
Right. So two things that I usually discuss that stifles any community is resources and accessibility. You cut either one of those off or both, which usually is the case for certain communities. You can't have this at all. There's really no conversation to be had, but at least if there is accessibility or resource available. I mean, if you cut one off, still there's a possibility that you can work on the other. But in many cases, both of those are usually cut off from communities. And so that's usually kind of the conversation that you really want to start with, because in this case, it talks about the community engagement and them themselves managing it. And by them having the control over it, they control their narrative. So like, for example, this is a little bit of a, not off, but one of the things that UDC, we actually have an anchor partnership with DC Public Schools. We work with Anacostia High School, as well as our feeder partner schools, Pranger Middle School, Ida B. Wells, and Sousa. We work extensively with them with hydroponic systems, aquaponic systems. So them learning about agricultural technology, but then also too at the high school, they have civil engineering, architecture, public service leadership, and then the agri-tech component. One of the things we kind of discussed is them changing the narrative of that particular community, because there are resources there and accessibility, but and more is coming, but there's a narrative that this is a bad neighborhood, this is no good, no one wants to go there, it's unsafe. But that's a false narrative. And so my encouragement is like the youth, starting with youth as well, changing that narrative. And they have been, especially the high school students, been very involved within that process. In fact, a group of 9th and 10th graders on Monday, I'm doing a campus tour with them so that they can see various components and also to be inspired to then be a part of the UDC, family community, because UDC can tap into those things and bring it, and we actually do. We bring it to Anacostia and to those students. So that's kind of one way in which practically I'm very much involved with that process. And so hopefully that answered your question, but the other side, I guess, of that coin, the craftsmanship too. Yeah, we just have to have people that, and I know people are out there, but they just, if they're not inspired, if they're not motivated, then, not sure if too much is going to happen within that process. But accessibility and resources.
Yeah, I think that's an interesting way to address the question. It's funny, in the north cities, there has been kind of a suppression of tradition, such that tradition is now ending up in museums as kind of museum artifacts, but coming from the South, right, where I'm coming from, you see, traditional craft much more proliferative, and present, and not so much sequestered to that. And I really see a lot of when I'm watching your presentation, and you do, right, lay out this amazing kind of, like the full dinner, right, of that, I see readily the applications in the global South, right? In places that already are already tuned in to that sense of craft, and they just need the resources and the accessibility to, explode it, right? Yeah, for sure. One more question, and then we'll go to Humphrey.
You mentioned Baltimore in Mid-Atlantic, and I'm curious, with the dual library, the huge investment in makerspace, some of these other efforts, have you seen in Baltimore some of this being easier to begin with all those investments, or are the challenges that Lila talks about, present, because there's not necessarily very grassroots, right? The architecture high school, there are several projects. I don't know where they're at today, but they didn't all seem to be working.
Yeah, I think Baltimore and even Washington, D.C. are very viable cities that are kind of, not kind of, but are, everything is kind of a movement, but, you need kind of one or few cities that are successfully doing it to then kind of carbon copy or replicate it. But then also, and in this case, value inclusive design model kind of talks about how you can scale up, scale down. So depending on the need of the community, you can do that. So from a design process, and just even DC, like art wise, we have like the commission, there's a lot of artwork. And so there's kind of even that blend between architecture and art. That whole art world and creatives is a whole different space. It's so unique. I've had the pleasure of being in some of those spaces and knowing some artists, and just, but that's like a good example where, you'll get funding, and you can make those type of things happen realistically. But then I guess for the communities, neighborhoods that aren't, we just got to do better. We just have to keep working and keep trying. There's no quick fix for this.
Well, thank you for your efforts. And also, I just want to say really quickly, thank you for recognizing people with invisible disabilities. That's a topic near and dear to my heart. And not many people in architecture recognize that's actually a potential for growth and development and exciting possibilities. And so thank you for that insight. We're going to break for coffee. As a Jew, I invite you to enjoy the bread of my peoples, and then we'll reconvene in just a few minutes.
So literally, yeah, so he actually, and then literally, I just went well, he was having dinner, and then I went to get a drink, and I walked past him, and he just walked by and said, he's like, oh yeah, it was like, okay, I gotta whip something. So he was like, he was very happy with what he saw this morning. So, yeah, that's fantastic. Because it is a real issue that we're treating, like I said, a lot of our students. Enforcing this and all these issues. Yeah, it's trying to translate, some of the social issues into, for into design. And we have no room. All this analysis of it. If I had more time, actually, I can't think of the actual project, but there is a project like in Southeast DC that has been built now, and it's like literally a communal hub. Yeah. For various stakeholders, community members, and it really embodies this, but like it's like made out of like think like timber, like just like a natural material, and just really creating an aesthetic that is like for event space, for events, for music, different entertainment, but then also to eat. So again, it has like just really feels more grassroots because of the stakeholders and community members that live there, that are part of there, and therefore they can do it because they also have the resources and connections too. Making calls and having people help. But I think your answer is great. The accessibility of resources. It's really, I mean, in some sense, for a place like San Luis, there isn't necessarily a locally established. I mean, that's where looking at the global south and the areas locally established tradition, bamboo or timber, you can attach to that. But it is that I think your answer was really good about like going into high schools and working with the youth. And it is kind of maybe bringing things from the outside, but it's for them to grow it into something new that's from them, but maybe the materials aren't present there, but they start bringing the materials out. That's what it's just like confuses. What would be the local material? And if you use brick, which you can, which is a lot of brick, but this is I find in marginalized communities that those are the materials that are kind of like or fencing and things are like, oh no, don't use those. That feels like oppression. And this is why I got a great reception when I brought in the bamboo to Williams. Oh, this feels more like like something growing up from the new, but it is an outside material. I mean, bringing it from Colombia, And so it's like a little bit contradictory to that. So well, still thinking the idea we could grow it. Grow a new craft community, but it's not using their established crafts. It's trying to bring in craft knowledge and grow it maybe at the high school level. Yeah, and so it comes out as something. Yeah, like if it's that's contradictory. No. So if the material is not sustainable, then you have to bring something in to start with. To your point. And so actually in my CAD doc spec class, one of the assignments for their specifications, assignment, like they'll identify the materials for that. So for the semester, they have to select the famous architect's house and research the architect in the house. And so they'll do the drawing documentation, they'll do specification and an cost estimation, like assignments and presentations. So for their midterm, they had specifications where they identified the materials, but then in addition, they had to identify a sustainable material or technology that could actually work. And I mean, I think that's very applicable where like we think, I mean,
we're thinking about the design process and how to design more sustainably. I mean, like, of course, these are beautiful homes, and how dare you like touch them, but I mean, but look, I was saying, but look, articles about falling water has just been like, I've been sending the little aid to my students, and so just for them to think of, and I say, guys, you're only specifying one material, or you just imagine working on a project in there, dozens, yeah. So it's not. It's no easy solution, but I think, but I think first having that conversation, and also too, when in my urban food design class, it's like, well, look, you know how many developers like come in and just say like, okay, we're gonna do what we're gonna do, and they don't acknowledge, they don't recognize, you're welcome, right? You're welcome. The value of this community has now gone up. Housing costs have gone up. You know, we made this better for you. But it's not really having them in mind. So
no, not at all. It's just it's
money. Yeah,
money. And that's where I mean, there's some real interest in, you know, the heart's in the right place. Interesting. That's what this like. That's why I want to read. That was a lot. Just take it in 20 minutes. Yeah, but like see how that plays out and understand it. Continue that conversation.
I think actually what might be helpful too is probably well, hopefully it does get published. Fingers crossed, hopefully, because it's expensive review. He said it's peer review. I mean, I was like, okay, I don't know how good this is, but he let me present. So if it was trash, he'd probably be like, yeah, just fall back. Yeah. But like, what was I gonna say? Yeah, my first paper actually goes into the model really in depth.
Okay.
And so if you just literally just type like value inclusive design Eric Harris, that paper comes up, and people are like citing that paper. People have recommended the paper. It's getting really like good traction. And so again, as I preface, I use a design competition to like evaluate how and why the team, like the top winning 3 teams, and just like that process. But again, you can apply it to the model, you can apply it to just various things. That's how, I guess, evolving and organic that, so the model itself can grow and change too.
But it's
to
a framework to like start to really work in a way that maybe does move forward.
Yeah,
and not just because we're just kind of like, I feel like I'm shooting in the dark, like going in and talking to committees and trying to do something, but like the way you formulate it, it's like now I can actually consider.
And you can focus on one dimension, like recognition or distribute, just based on what it is you're trying to do. I mean, I added the judicial part because like a lot of times things have been done that's just not just like you just like whoa, like look, we're the architects and designers, but also too, we got to be very empathetic and have an empathetic lens in terms of what their needs are, not what we think. And so so again, telling their story and trying to incorporate a design process in it. But you know, this was a very unique topic. I didn't feel like necessarily I was like, I don't want to say I'm not a specialist in it, but I thought I could use my model to as a broadly to talk about this subject. So I felt like it's a good start, but also too, like I have other papers I want to write about and continue to build, but like use value inclusive design and just continue like to build on that. But I definitely would say like my first published paper, it is pretty extensive, but it's definitely a good read. And so then by the time you get to this, and okay, because I had to quickly frame what people like, what the hell is that? I've never heard of that.
Is it a money thing or what's value?
And I didn't want to assume or presume that people knew what that is.
I don't think anybody did.
So that
okay, so that's not your specific concept. That's a bigger concept that you're working within, or you create, that's your creative concept, right?
Well, it's my model, but basically, I mean, I quickly mentioned that like I was building upon Sarah Miro, who's a researcher, and she talked about the dimensions of social equity and inclusion, and so those 3 is kind of like where her research started, but then I included the 4th dimension, and then coinciding with that is the social, which is like a newer piece, is the social value constructs. It's also it's also a book called Symbiotic Cities by Dr. Marion Stover. So there's a chapter 12 is urban architecture for well-being. So myself, my committee chair, Dr. Stover, and then one of her students, we wrote that chapter. And so that was kind of the genesis before I started doing the value inclusive design model. So we first talked about the different principles of design and specifically those social value constructs, identity, placemaking or placement, empathy, accessibility for all. And then once I then worked on the model to expand it, I was like, well, doing all these things will create transformation. That's the nexus or center of all of that.
Yeah.
And so it addresses many different issues that per se maybe not even empathy alone could do. You know, so so I know like it's very like theoretical, but like I actually try to make it palatable and break it down.
Yeah.
So it's kind of like, okay, I understand. Like it's not over my head, you know. So that was kind of the mindset. Even this paper, it's not as technical as like some of the other folks that's presented, but that's okay. Because I know I'm using more of a theory-based model to then explain design and that process and practically what you can do on the ground with it.
That's the translation for it. So hard. How do you go through it?
And there's a lot of cool materials too, you know, that definitely can be. In fact, like one of my so for my CAD class, my students, you know, some of them are really creative, like in terms of like the material that they, you know, mentioned or presented, and I thought that was like good, just so they can get a handle of like thinking about materials. Because I say you're doing a project, and sometimes, let's say if something's discontinued, which can happen. Or like, look, post-COVID, oh my gosh, the lead times and everything, that went to and so and then you're like, well, I have to then select an alternative, you know.
I decided to address that today.
Yeah.
Well, no, I'll give some remarks. All right. Let's get started. And not incidentally, next to hear from is Max Fertik. He is a lecturer here in both comprehensive design and runs the materials studio, as I understand it. Max came into architecture by way of art, and is also an artist who uses biomaterials in art and design practices that help us. And I think that we can renew then this conversation a little bit about, you know, craft and so forth in relationship to his work. But the work that he's presenting today is using invasive plants as biochar. And so please welcome Max Fertik.
You guys, do I need the mic or?
Yeah,
okay.
just the strings.
Got this nice little pocket for it. Hi, everyone. How's everybody doing today? Good, good. Thank you to a handful of my students for coming and my partner, Erica. Thank you, Spencer, for having me as well in this amazing building. I don't see Spencer, but oh, there he is. So yeah, my name is Maxwell Fertik. I teach in comprehensive design over in Bloomington. I also have some materials to pass around as well as we talk. Somebody in the front row with all that. But start passing these around. They'll make a little more sense as I start talking a bit more. But yeah, we could circulate these. Yes.
Sorry.
Yeah, so the title of my paper is Rich Residue, Case for Invasive Plant Biochar as a Post-Industrial Resource. Basically, I've been really obsessed with invasive plant material for the last 2.5, 3 years, I guess, at this point. I'm sort of going to go through a bit of a context of charcoal biochar, what it is, how I understand it, and then go into a little bit of how I got into it, how I learned about biochar, how I'm still sort of learning as somewhat of an amateur in the biochar sphere. I'm not necessarily a farmer, which is sort of its main use. I'm an artist. I'm a multidisciplinary artist and faculty member. But the overview of my paper, if you get the time to read it over at some point, I try to explore the political, ecological, and material potential of invasive plants as biochar, which I'll go into what that means to me as well in a minute. But I'm positioning it as both a symbol of ecological disruption and a tool for resisting the extractive logics of industrial development, and through the creation of objects made from specifically knotweed biochar, but I'm also experimenting with some other more local, non-native species as well, ranging from architectural elements like a brick to functional artifacts like a spoon, as well as incense, which I've been working on with my partner, Erica. This paper also explores how these materials can embody ecological repair, which is ultimately the goal for me. So let's get into it. So as I've been reading and watching tons of YouTube videos about charcoal, like sort of deciphering what is the difference between biochar and charcoal, I understood that biochar is something that is not necessarily man-made. Biochar and charcoal can be naturally produced through forest fires. This may be obvious for some folks, but I wanted to just sort of start that off. It's not just about human intervention. It can also just be something that happens in nature. But the first sort of human discovery of making biochar for its agricultural usage was about 2,500 years ago in South America in the Amazon basin. This is the Amazon basin today. Terra preta, which means black earth, kind of heavy metal, was quote, I put discovered in quotes because this is sort of discovered by a white Dutch guy who went to the Amazon rainforest. So sort of discovered in quotes, meaning it was brought to the West in the 1950s by Wim Sombro. In the Amazon rainforest, he learned how it had been used to foster these super carbon-rich soils that could sequester carbon. But ultimately, he learned that the high porosity of biochar made it a great insulator, it retained moisture, and it kept the soil resilient annually. So they didn't have to sort of rip up the crops every year. It retained the nutrients of the soil annually. It also captures toxins, which is really interesting to me when it comes to repair. It can be used as, I mean, I'll get into this a little bit, but charcoal is an adsorbent, not an absorbent. So you notice the D and the B. Adsorbent means that it pulls material on, or pulls toxins onto its surface. and then it could be discarded. So absorbent means it like takes it inside like a sponge. Adsorbent means it sits on the surface. New word for everyone. And it also can be used as a smokeless biofuel, which is also pretty interesting. So just a little bit of differentiating. From what I understand, it's still, I was talking to Erica in the car today about how it's still a little bit confusing to me, the differences between biochar and charcoal. But from what I understand, charcoal is traditionally made out of wood. It is used for fuel, for cooking food primarily. It is made through a low heat pyrolysis, which is basically just a low oxygen or oxygenless fire. The pH levels are between 9 and 11, so on the higher side of the pH scale. Biochar, on the other hand, is made of any biomass. It could be made of wood, primarily used for soil remediation, and it's made through a high heat pyrolysis, and it's more on the lower side of the pH scale. The summary of that is the main difference is how it's used. So biochar is mainly used for agricultural uses. Charcoal is mainly used for cooking and heating things. Couple really great images that I found through my research as well. Here's some charcoal production happening in the Black Forest around the 1890s in Germany. It was used as a forage to create tools in subsistence farming cultures. High smoke release on these, but some really interesting process photos, very early photographs too, like 1890s, sort of the beginning of modern photography. But wood is basically piled in a mound so that it falls back into the heat source. But creation of charcoal, though it was used for survival, was a huge contributor of deforestation in Central Europe around this period. And then it is covered in soil to create sort of low oxygen fire, which is also pyrolysis, but this is done on a massive scale. I've also been really interested in Inshotan, which is a type of charcoal made in Wakayama Prefecture, Japan, specifically the Kishu region. There's some amazing videos of people making this on YouTube that I recommend you check out. They basically have to use the specific type of ubame oak, but it's mainly used for cooking and making oolong tea. So there's some really great documentation on that. But I guess I'm saying I think about biochar in congruence with thinking about charcoal because they are sort of from the same family. And I'm also really interested in the processes that go into what they do. So yeah, they cook it in a kiln and then they cover it with soil to sort of quench the flame. This is what the Inshotan looks like at the end. It's often called white charcoal as well. It creates these white charcoal logs that supposedly when they're perfectly made, they sound like metal hitting against each other when they're hit against each other. I also, when you look up charcoal online, you find these sort of eerie cosmetics images as well, and I've been sort of fascinated with this as well, and it has this cleansing quality to it as well, and often you find a lot of content through researching charcoal centered around charcoal as this sort of miracle black carbon, dark matter, return to the earth, cleansing carbon, which I think is kind of interesting, both in the cosmetics but also in food infiltration. There's also a huge amount of videos of men trying to return to some quote unquote primitive state by creating charcoal pits and videotaping the whole process. Like there's an insane amount of videos of people doing this with crazy titles like this that really set the scene. So that's enough of like sort of the context of where I've been coming from in terms of thinking about charcoal. I've been really interested in invasive plants, as I mentioned. This sort of started with my graduate thesis, which was all about figured out ways to utilize invasive plant material, specifically Japanese knotweed. I'm not going to go too deeply into my exploration of that because that's a whole other presentation. This is sort of my chapter 2 in many ways, or like book 2 of that story. So coming off of this thesis project, which was a 2.5 year, well, I guess a 1.5 year project, I did a residency in Ithaca, New York at the soil factory and began playing with knotweed in a different way. Ultimately, my goal was to create a knotweed particle board, which I've been passing around, sort of the final product of that. It's pretty, also could be an architectural material possibly. But my sort of, and this was kind of my exhibition at the end of or my installation at the end of that residency of the particle board. But one of the sort of unintended successes of that residency was learning how to make biochar. So I had the pleasure of working with Rebecca Nelson, who is a MacArthur Fellow awarded kind of genius person who has done, she works at the Cornell Ag School and she has studied corn primarily to put it very simply, in Peru. But she also does a lot of experimental planting and gardening at the soil factory. And she taught me how to make biochar using this kind of low oxygen burning. So this is us making it using a ton of corn cobs that she had left over from research. These began to sort of symbolize the shift in the way that I had viewed invasive plants. So not just as a plywood material, but also as this kind of dark matter that was rich with nutrients and sort of pulling all the water, pulling all the lignin out of it and just giving you the pure carbon in the end. So sort of thinking about invasive plants again, but through a different lens. And they sort of, when you do this, it creates this really ghostly, I mean, the corn especially, like it's, it looks like corn, but then you put it in your hand and it just turns to dust. And this was knotweed, which we did a ton of as well. And that, yeah, it sort of made me think about invasive plants in a different way. So since then, I've been doing a series of experiments. I'm very new to the Midwest as well. My fiance and I moved here from Providence, Rhode Island in August. So a lot of this stuff is East Coast based, but I do consider most of my work to be pretty localized. But this early experimentation that I did with Erica was experimenting with making incense out of it. We were thinking about objects for the home, thinking about multi-sensory experiences. It took a while to sort of make it not smell like cigarettes. It initially sort of, it was a lot of experimentation with essential oils and different burning techniques, but it creates a smokeless incense, which is really interesting. We also cast these aluminum bases for them as well, because I was working at a metal shop at the time and we had a ton of spare material. So that was sort of the initial experimentation with that, sort of using this cookie cutter method that Eric coined. We also tried making paint with it as well. There's a sample going around of the biochar paint on the knotweed particle board. But jumping to where we are now, I've been experimenting with making biochar at home. So using knotweed that's around the Bryant Park area, but also using some of the invasive honeysuckle, mulberry, and not being as exclusive to one particular invasive plant. And I also want to say that I'm not promoting farming invasive plants. That also should go without saying, but I'm sort of promoting a more decentralized model of resource use. So considering what is already around us, considering what is already abundant, instead of extracting virgin material when it comes to architecture, but when it comes to product and object design as well. So after lots of research, I figured out that the pit method is sort of the way to make the most material at once. So I dug this pit in our backyard with permission from the landlord, and began sort of collecting local invasive plant material. burning them, dousing them with water to sort of stop that burning process. So with biochar, it's okay to have the white ash, but once you douse it, that white ash sort of disappears, and it just becomes this black rock kind of coal material, like this. So once we create this char material, it can then be crushed, molded, and then casted into different forms, which is sort of what I'm interested with in this project. So a couple examples just to sort of wrap us up. The first experiment with this was earlier in this year. I called it the mild scoliosis chair because I have mild scoliosis, and it kind of leans a little bit, but it was sort of leaning into the sort of imperfection of how biomaterials often, they're often a little bit, it's never as flat as you might want it to be or as straight. But I like leaning into that because it sort of emphasizes the imperfection, and also that it's not this manufactured thing. It's often made by hand. And this was in an exhibition up in Indianapolis, all about furniture. I think it was the only one that wasn't made out of wood or metal. And then the second one was also for that show. It was a collaboration with my colleague at IU Bloomington, Kara Rasher, which we just called Char, and it was a kinetic sculpture where I created this mask out of knotweed biochar, and it was connected to this kinetic piece that made it spin. And you could check out my Instagram for the video of it. And this other thing that I have passing around was my carbon spoon. So as an industrial designer, I am also interested in, when we're creating a biomaterial, not just creating like a material sample, but creating something that we can recognize and understand. I don't know if I would necessarily use it, but it does represent something that we understand and can wrap our head around. And then lastly, this carbon brick. I'm still sort of in the experimentation phase of actually considering this as an architectural material. A little bit tough to see, I guess. It is tough to photograph something like charcoal because it is such deep, dark black. But I do want to emphasize that it could potentially be this, this way of, whether it's mixed with concrete or plaster, it could potentially be something that we engage the built environment with. So I'm just going to wrap up here. So the conclusions of the paper and also sort of conversation starters are that invasive plants are abundant, primarily, like really everywhere. And my goal is that this doesn't have to be just knotweed, it doesn't have to be just mulberry, it could be, this methodology could be sort of copy pasted to a variety of different places and scaled in that way. But I feel like with invasive plants, the conversation often ends at removal. And I want the conversation to continue as we use the biomass in a new way. And I think biochar is another way that we can utilize it. Also, second, biochar is an increasingly important resource, especially in post-industrial environments, in restoring toxic soils. Also in bodies of water. I haven't really experimented with that yet, but it has been used in that way as well. Again, as was said in Chris's presentation, like carbon sequestration should be ingrained in the built environment, whether it's in the deconstruction of the buildings, whether it's in the material itself, and also just in the system that the building is designed in. But this goes into the furniture scale as well. And also creating decentralized networks of ecological restoration. This is something I have a mini essay in the paper about as well, but creating a system between collecting invasive plant material from people's backyards as sort of this post-industrial network of collection and DIY production. And then lastly, that material-driven design should transcend the logic of extraction and rather respond with regenerative processes, respond with regenerative processes and responses. So with that, thank you so much. Any questions?
I
What are you binding the biochar with to make these things?
Great question. Yeah, I should have said that. I sort of go back and forth between cornstarch and xanthan gum. This is like the binding agent with biomaterials is often like it's the glue that makes these things happen. Like if it's with something with coffee grounds, I guess mycelium is maybe an exception of that, but the binding agent that really makes it happen. But recently I've been playing around with xanthan gum, but cornstarch is a little bit cheaper. It is a processed material, so I'm kind of trying to figure out more, like, I guess, less industrial binding agents to use, but cornstarch and xanthan gum at the moment. Yeah, cool.
Have you done experiments with like structural like integrity and like longevity of material? Do you know how long it like lasts for? Or that, like, I don't know. I probably but like.
Yeah, it's a good question. I still need to do some stress testing, especially with the brick. It's pretty new. When I was doing knotweed material research for my thesis, we did get to like go to the Brown design workshop and use some of their universal testing machines to sort of break the material, which is always fun to see. But I haven't done that with this stuff yet. In terms of structural integrity of these, it's still to be seen, I think. But and I think if it were to be like a more industrialized brick or cinder block or something, I would probably want to engage some kind of rock in it, like like plaster or I don't like to use sand because that's another depleting resource. But I may consider doing something like that. But I still need to do some stress testing on that type of thing. Yeah.
I have one last question, which is, have you tried it as a joint, like more like mortar? Does it have adhesive properties, or adherent properties of one part to another possibly?
Yeah, I haven't. I've been wanting to try that. I was thinking about that exact thing because when I was sort of casting the brick, it has this, and it's maybe because of the xanthan gum, but it has this really pasty quality to it, and I think that could be really interesting as a patching mechanism.
But also, in terms of a lot of new material that we're looking at, I think we have to rethink the joint, right? This is not masonry, and it's not, necessarily the post and beam kind of joint. But Greg Lynn is building like boats now. Enough that I'm building boats. And one of the reasons that he likes to focus on boats is because they're held together, especially given carbon, sort of composites and stuff that he's working with. They're held best together with adhesives, with kind of glues and so forth. And I think it really opens a new tectonic territory for us if we could be thinking about the smooth application of one piece to another using something like adhesive and layers rather than always having to have a particular joint.
That is really interesting because especially with like plywood and stuff, it's the adhesive that's kind of the toxic evil thing.
Right.
Yeah, it'd be interesting. Yeah.
It's also,
What? Sorry, Jonas. Thank you.
Yeah.
it's not, you can also think about it like a gasket. So it's not just whether it sticks, but because it's moldable. Sometimes you take two organic materials, two sticks, for example, and they don't have any bearing surface between them, right? But if you can create a gasket as a kind of, it's almost like a wet set joint. This is even common in traditional bamboo construction with fish mouths. They need to bear on each other exactly and don't really transfer the forces correctly. And sometimes they'll actually fill the joint. It's almost like a weld, but it really is just part of the joint. Also pull it though, but that resists the kind of collapsing the way that the rupture.
Yeah, almost like grout or between tiles or something.
Yeah.
Very much so.
Kelly, did you have a comment? And then this will be the last one.
Yeah, just to the adhesive point, it's the toxins associated with the adhesive, but it's also the kind of inability to then undo it later from a kind of reconstruction versus demolition standpoint. So it seems like your, if it were to be used in that way, there is potential to kind of undo it, you know, unbuild it later.
Yeah.
Through, you know, burning or some other type of method.
Thank you.
Thank you.
A few remarks, and then I'd like to kind of regather and have a little bit of a panel discussion. And so hopefully we just go to 12:30 like we did yesterday, and then eat. But if the food looks to have arrived, so if you're starving to death and you didn't get enough bread of my people, then please just, you know, grab something and sit back down. We actually have a lot. Let's thank you, Matt. Set my situation up here real fast. Where's the microphone?
Oh. Microphone.
Man, I hate holding this. All right. So thank you to the people who have, thank you to the people who have spoken in this session. I'm learning a lot, and I've learned a lot yesterday as well. All of that needs to be taken with a grain of salt that I'm not a material theorist. I'm not an innovator. I'm not an analyzer of circularity. I'm the worst of all, I'm just a theorist. And is on the discipline of architecture. And specifically, I research columns. That's the majority of my research this day. And that's because columns are kind of at the heart of these disciplinary questions, or at least they have been for the last, say, 500 years. So I'm honored that you trust me with your scholarship. And it's with that trust that I'm about to go kind of meta on you all. But that might be a good thing. So that while the experts gathered here are super focused on innovation and testing materials within constructional models, you're the ones out there, you know, hustling the grants and making your work happen. I think we're kind of all stuck at the same point, and this is a broader collective sense, not just we here, but I think architecture in general is a little bit stuck at the same point. And that is that we all recognize the extraordinary need for ethical materials worldwide, but we're having a difficult time bridging social acceptability, bridging policy, getting widespread adoption. How do we move from the exception to the rule? How do we stop proposing and instead move toward just it being the norm? Of course you use biochar, right? You know, for this application. How do you effect that? How do you affect that? Moreover, we need to affect that. So I have some big thoughts, and they might be a little ambitious. But first, I need to make a standing plan.
and one that I hope will sustain us for at least the next few minutes of my bloviation. My claim is that we participate in an architectural discipline. And it's kind of more or less the discipline that has been present in the Western tradition for the last 500 years. And so, despite a few straggling leftover postmodernists who want to kind of claim there is no discipline, I see many trappings of a clear and present architectural discipline. We have formal training and examination. We have institutions dedicated to the dissemination of architectural knowledge. We ascribe value to what we produce, including monetary value for what we produce. We usually have clients, and I'd offer here that sometimes a bird can be a client. We have shared materials and methods of design, shared tooling, shared platforms, and shared forms of what we might call acceptable representation. And if you take a kind of glance over the stock image collection of architects, we wear hard hats and we point. We do a lot of pointing. So in other words, if it looks like a discipline and acts like a discipline, then it's probably a discipline. And we are in it. And I know that sounds kind of awful, but I'm here to share with you all some very, very good news and hopefully inspiring news. And that is that both the name of my talk today and its main argument is that the architectural discipline, as we've inherited it, needs to be understood from this point forward as the plastic fantastic discipline. So I came to the plastic fantastic discipline during my doctoral work on travel trailers and mobile homes. I did my doctoral work on travel trailers and mobile homes, which were emphatically declared, quote, not architecture by my committee, much in the same way as you've probably experienced dismay that often meets your research agency and aims, despite you trying to prove their goodness in every way and show, and it's like, yeah, that's good, right? We can accept it as moral good, ethical good, planetary good, right? You know, and you're like, why am I still at the fringes? So being a speculative thinker, I answered my committee's objections at that time by referring to the discipline as possessing a kind of agility, sort of ability to admit new knowledges and accept change and still be a discipline. Since that time, I've really fallen in love with this discipline. And I believe that the discipline actually is, it's not a static thing to be protected and gate kept. The discipline of architecture, the one that we've inherited, don't let them tell you different. Don't let them tell you different. It is alive, it is dynamic, it is floppy, it is weird, and it's wonderful. Canons are laid, rules are made, and when it's propitious to move, just like the wiggly organism it is, the discipline moves. Once upon a time, we all read Siegfried Gideon. Now we hardly think of, I'm like the last person who thinks about Siegfried Gideon. Sometimes trends take over. Remember learning Maya? Yeah. More rarely though, and I think this is important us here in this room, there are serious political, social, and technical reckonings, new epochs, a new architecture of our times. And what I'm here to say is, don't worry. The plastic fantastic discipline can handle it. So I'm going to go through, these are new thoughts of mine, but my work has revealed this kind of long history of the discipline's dynamism. And I'm going to go through just a couple of these kind of historic gems, if you will, or sort of pearls, if you were in medicine, stacked pearls. So take, for example, first, a text written by a leading Renaissance architect, Dillon, literally called the Rules or Canon. The Italian is regola. of the 5 orders of architecture, right? You can't get any disciplinary hardcore than somebody in the 16th century talking about the 5 orders, I think. And this text is considered kind of central to this sort of core humanist and disciplinary orthodoxy. And so he says, he's writing about these 5 orders, and he says, I understood this task many years ago, namely to reduce the said 5 orders of architecture. Meaning he's aware that he needs to reduce the 5 orders of architecture to a concise and quick rule, which was easy to use. So if some minor member did not entirely obey the numerical proportions, I accommodated it to my own rule, not by altering anything of importance, so it says, but by harmonizing this slight, and he uses the word license. That's why it's in, right? This kind of, this interesting sort of wiggle room that he's allowed himself. And he says, but don't worry, it's on the authority of other examples of the Doric, which are also considered beautiful. Like I've taken this license, but you know, no problem. And then he has to put a paragraph later, he has to back that up. And he says, and look, it's neither my wish nor my intent to respond here to the objections. He knows there's going to be objections to this that I know will be made by some. And instead, he says, I leave this task to the work itself. And then he also kind of rounds in the cardinal that he's writing for. And I'm sure also he'll defend me, will lead them to take up my defense, right? Like in my own defense, I'm doing this. And so, you know, Vignola, and to follow up again, and I think that this is really great in your presentation, Eric, that theory to practice channel, right? Where we see Vignola practicing. Here are his 5 orders. And then it's kind of interesting in the canon that he produces, he then produces this Doric order, which is like unlike any Doric order, which, you know, it has been admitted into that canon. It's a very festive Doric, if you will. And then his own architecture at the Scala Regia. And look at these poor little triglyphs kind of racing around to keep on top of those Doric orders. And then that kind of square column at the end. Did he not believe his own canon? Or were these regole meant to be broken in the first place? Aren't the rules meant to be broken in the first place? Either way, these little tiny Vignola morsels begin to reveal that the column orders, which is a central tenet of the discipline, may not have been as self-evident, as truthful, as universal as they've been presented, well, for centuries, right? I mean, even in our own education, it's like, these are the 5. So now you're going to skip ahead to, of course, a real wrinkle, which is Claude Perrault. And I'm a huge Perrault fan. So here we have his theory of beauty. And it's the theory that, if you recall from your history classes, that in which he separates positive beauty, meaning beauty that can be seen and is evident in nature, say, from what he calls arbitrary beauty. But then in this passage, he turns from using the word arbitrary to the word customary. And he starts to use the word custom rather than arbitrary. And Paris Gomez has done some amazing translation work of Claude Perrault, where he says maybe arbitrary wasn't quite the right word, and that maybe custom is the better word. And so what he says of the column orders is not that they're like truthful, forever found in nature, you know, the angels descended from on high and went, oh, here's the columns, you know, and they're just like etched into that. But rather he's like, hence neither imitation of nature nor reason nor good sense in any way constitutes the basis for the beauty people claim to see in proportion and in the orderly disposition of parts of a poem. Indeed, it's impossible to find any source other than custom for the pleasure that they. And he defines this custom. He says, this is the custom of us in architecture. We decide it's interesting, we have juries, we have lots of discourse and discussion. We're constantly producing judgment. And for Perot to be aware of this in the 17th century and to then use that as the reasoning for why the 5 orders are the 5 orders, I think is fascinating. He understands that his rules of the ordinance, those are his over there, are the orders that have been manufactured. They've been regulated by himself and others, and through the power of geometry and the way in which, as Timothy Hyde points out, he uses, say, the grid and the plane to conform them. That's where they get their sense of beauty. That's where they get their sense of proportion. That's where they get their sense of appropriateness. So Blondel is claiming, no, they're from nature. They're not really the subject of design. But what Perot is suggesting is instead, no, these 5 orders are just the 5 of many possible orders. And that ordering the orders is also an act of custom, also an act of this kind of judgment that we practice. And these are Piranesi and Lavadere. They're 100 years apart, but it just shows too that once one starts wandering, as they did, the more it's apparent that 5 orders were indeed 5 of many, even in the Grecian orders, as Piranesi pointed out in this sheet. And so, if I could bore you intensely, I would show you my work, which has been a mission to kind of examine all of these drawings, folios, etchings, and so forth, and look at all of the eris lines and the way in which the circle is inscribed and the way in which the proportions are laid out. And what you find the more you look is that the orders are just a mess. They're just an absolute mess. How they got to 5, I don't know. So we know this comparative slide is used by every architectural historian in the Western Hemisphere. And we also know that Perot's really, and I'm going to use Phillip Beesley's word that he's brought a couple of times to the table, tantalizing proposition is it loses. It kind of loses the fight, but that doesn't mean that it's not present, because the thought that he entertains here seems to hit more and more differently as time passes. And that is this idea of the hut tuned to its environment, invented through the shared and collected knowledges of its people, instead of this kind of ever-present universal origin myth of a hut. And that's exciting to us. And it's more acceptable maybe to us now than it was in the 17th century. And it's exciting to us now because I think that that's what's on the table for us to explore. All of your material sciences bring me to this notion that it's Perot's hut that is more relevant for us. And the answer, therefore, in this plastic fantastic discipline is this. The systems don't, quote, tolerate deviation. Behavior tolerates a system for one. It's the kind of fundamental chaos tolerates a system for a while. And every system that gets tolerated is really based on custom, a kind of consensus, a conscious or subconscious level of agreement, such as my talking to you today. I can say the word dog, you know what I'm talking about. Magic. It's a magic kind of consensus. And the short-term durational system holding, like our discipline, is the basis for that plastic, for the plastic part and the fantastic part of the discipline. I mean, I wonder how the world would appear to us if Perot had won the Carrel and this hut, or the whole hyper-local contextual hut, made from locally sourced renewable materials, if that formed the basis of architectural knowledge. And there's nothing wrong with reaching back into the discipline and saying, that one. So now let me throw another example. This is Viollet-le-Duc. And offering it, you know, Viollet-le-Duc could have been seen as a 19th century madman who thought like Gothic cathedrals needed more light. Gothic cathedrals had a light problem. I don't think they have a light problem, but that's an interesting theory. Or we could see him as what I think he is really the first architectural modernist. And I prefer that because it's a sentiment that's often used to substantiate a shift to modernism. And that is this. He says iron, right? He's gravitated toward the material iron, is destined to play a more important part in our buildings. And I'm hearing the sentiment throughout this week. It should certainly furnish very strong and slender supports, but it should also enable us to adopt vaulting at once novel in plan, light, strong, and elastic, and bold constructions forbidden to the mason. It somewhat contravenes the principles of Greek and even Roman architecture. But if we would invent that, and here are the pink, architecture of our times that is so loudly called for, then we must certainly seek it no longer by mingling the styles of the past, but by relying on novel principles of structure. And you know, here it's like the material becomes the instigator. And look, okay, this cast iron material for him is liberation. It's also the end of my column studies, right? You know, because it's, you know, but that's okay. Because it's making masonry, it's not only advocating for iron as a material, but it's also making masonry obsolete. It pushes the cladding, the decoration to the surface. And once someone like Louis Sullivan reads Viollet-le-Duc, which he certainly did, the slender iron and then steel member form the basis for floor plates and high rises and, you know, kind of a little bit of the end of all of this truth matter that classicism had held. And so it's material technology that carries with it this sense of new. But we also have to recognize that it's a sense of new that wins on its proposition that we are in new times. We are in a new epoch. And so these concepts cohabitate in the minds of the early modernists. Here, Le Corbusier's Maison Domino, and here a page from his Vers in Architecture, in which he's saying, look, don't do columns, do cars. Don't do temples, do a delage, right? It's really interesting. It's a new standard for our times. It's a new epoch. And he says, it's a fight. He says, once the standard is established, it's a fight. In order to win, you must do better than your rival in every minute point. And that's progress for Le Corbusier. And so do it with me. The slender pilotis frees the plan and the facade. The repetition of the structural unit forms the basis of an industrial model. The industrial model provides the light and air that becomes the kind of socialist destiny of modernism, whether that turns out or not. And so yesterday, Wiley Brown asked us, why are we still building buildings as we did 100 years ago? I'm going to bring the same question. I'm bringing the same question. And I think Le Corbusier would as well. Modernism, so think of this. We're in a little bit of a time of great change. And we don't have long to make that change. So modernism, it went from avant-gardist fantasy to the normative way of building in what, 40 years? And it did so out of the crisis for change, of world war, of mass industrialization and intellectual migration. The discipline survived. The discipline changed. Vitruvius, still relevant, but now also Le Corbusier is on the table. The modernists were audacious and demanding, and they used every resource, public, to exhibit, to gain acceptance. They used every resource they could. And they formed a kind of neat ball of destiny, if you will, between the materials, the constructional methods, the forms, and the social aims of the modern program. And no matter what you think of that architectural modernism that does become the de facto or normative way of building in cities, it's a remarkable success. These images on this, and I purposefully chose images from Nairobi, from Brazil, from all of the places where this modernism it's exported. They did it. We can too. Today, as evinced by this conference, academies and research units are brimming with great intellectual innovations. Sound modes of construction and structure, such as thermo-responsive concrete, reusable material, additive and subtractive and celluloid fibers and liquids. And with these advances come the shape tectonics necessary to make new forms, to make Perot huts. And with that, a very human need for fitness to the environment, a very human need for new kinds of artifice and beauty, a very human need for planetary awareness, a very human need for the Jedi. We are here. We are 3D printing, we're using AI, we have robots, we have scripting, we have all kinds of CAD. We may not all descend from the grand Western tradition and its narratives, but we don't need to in order to be admitted into this, plastic, fantastic discipline. We can progress new canons. We can make materials that obsolete the former versions. We can progress vernacular canons, community canons, non-human canons. Look, if those floofy 17th century theorists, right, could make space for disagreement, then we can plunge right into the next version, the architecture of our times of this plastic, fantastic discipline. And I think that if we have any hope of any future, we need to do this now. Thank you for listening. So that's a bit of an exhortation, a bit of a call. But now let's take a few minutes to bring the panelists back up and we can continue some conversation for a while. And I welcome questions too. But I don't know that my question, what I'm talking about is absolutely relevant to the expertise that our speakers brought. So let's have a seat. phone question. Would anybody like to start the question to her? If not, I'll moderate. Let's, so I've already talked about adhesives and coating and so forth. Typically, we think of the ambitions of working with progressive, sustainable, resilient materials in terms of scaling, right? You know, like, well, eventually we could do a whole building like this. I'm going to ask you, why is that the limits of your ambition? Anybody want to take that?
Well, but just to add on to the question, because I had a similar question, but maybe not the best one to start with.
No, go for it.
It isn't the limits of the ambition.
That right
wasn't necessarily presented that way. Of course, it could be, but
yeah.
Yeah, I mean, I don't know. I mean, as a more of an artist than an architect, I think it's more the modules that I'm interested in, that sort of break down that limit of the building or the built environment as the limit. I don't know. I'm always very careful when I talk about scaling, because it implies it implies a certain I don't know, capitalizing or mass manufacturing of something. So I'm always a little bit careful when I talk about scaling, especially when it comes to sustainable materials or regenerative architecture, regenerative product design or materials. So I guess in terms of the limits being the space or the built environment, I think for me, the scaling is, I don't know, it's a little bit more interesting for me on the smaller scale where you have something like a brick or a column or a chair that maybe isn't mass produced, but it has influence in a different way. I think it has influence both, and like with Chris's tiles as well. Like, you know, I think there's a different form of scaling and influence that goes beyond just the building or the house, that could be seen through something like a brick or a tile or a piece of furniture. So yeah, I don't know. I don't think of the house or the building as like the limit, but maybe sort of starting point.
Eric, you have to have something to say about this, because I know that like your work, like you can imagine the deploying of this kind of process across multiple communities and multiple places where they own and have access to their own materials, and it becomes global practice, right?
Yeah. It's a loaded
No
question.
pressure.
No, it's a loaded question. I mean, from a practice standpoint, there is limitations, obviously. Like, a building has to be built. There's parameters, budgets, time frame. But I think when we try to at least transcend that, you know, one of the things I talked about yesterday was about the American utopia. And so how there are many architects that we herald or, you know, we revere, but at the same time, there's architects, Black architects in particular, who has designed and developed this country, but have not been recognized. And how do you speak to that? There was no, and in fact, they had less to work with. They had restrictions, they had limitations, but they broke those barriers. We have everything. The only limitation is ourselves, you know, and I mean, I'm trying to be careful with that
Because, you know, like when I talk about architecture, especially like with students, I just say, well, look, with an architecture degree, you can do anything under the sun, anything. And so, yes, we ourselves limit ourselves potentially with a built structure, but at the same time, just look at all the incredible workshops and sessions like this over these past couple of days. I don't see that limiting in any way, but you know, and our imaginations can really run wild. But I think from a practical standpoint, yes, we have to also to really be engulfed and very much in the thick of that storytelling of communities, like seeing ourselves not as outsiders, but insiders within that story too. I express that to my students, especially in the makeup of being at HBCU, have a lot of different faces, makeup, you know, like you speak Spanish, French, whatever, Polish, wherever you want to go in the world, you can implement things and make, you know, a lot of radical and social change. But you just have to first and foremost believe it, because we have the tools, we have the knowledge. I mean, you know, and we're still, you know, we're still learning from the greats, you know. I mean, that's the crazy part. But at the same time, we actually have tangible heroes and people. I mean, I never met Marlon Blackwell, you know, until, you know, like yesterday, you know. And so it just speaks to the fact that we have folks that are trying to move ahead the threshold of architecture and design in a not just a sustainable way, but a resilient way, because we beat this earth up, beat it up, tore it up. And now in 2025, we're like, oh, sustainability, oh, resilience, oh, you know, we're cool now, oh, we're green, you know. Where before, those were people were radical. Oh, you're talking about green infrastructure? What is that? But now we see the results of it. And so we have a responsibility to respond to it as architects, as design, I mean, wherever you fit in.
Yeah, keep the momentum going and also pass that down as legacy to the succeeding generations. I also think though that we need a SIAM, you know, in this sense, right? A kind of meeting that sets new rules that, you know, like first reuse, right? You know, kind of, you know, first do no harm, you know, and ethical responsibilities and, you know, and so forth. But that's my own sense of keeping that momentum going. But you're absolutely right.
I was just to follow up on that. I think the question is always posed, right? And especially in a kind of material conference, the question of scaling up, but it's always posed as a technical question, right? Like, how do you go from the 4x4 tile to the, I don't know, bigger scale facade, and how does this become structure? So I love that we can answer this question and think about it not as the scaling up is not a technical thing, but it's a social thing, but it has other impacts. That's why I loved your presentation, Eric. And I think maybe for you,
Do we actually give you the microphone? Sorry, so it comes on the screen.
Yeah, I was just saying that, that coming at it, not answering the question from a technical standpoint, which is where the question is usually posed or where the kind of lob is usually thrown, but being able to answer it through kind of larger scale social impacts, I think is what was wonderful about your presentation. And maybe in a similar note, I think Chris and I were talking earlier about the difficulty of photographing these things, not just because they're small, but because of their kind of characteristics and their attributes and their weird traits. I've also come up against that as a kind of difficulty, and you mentioned it as well, Maxwell, which, you know, I wonder if that's also a way to answer the question. Like, it's not the technical scaling up, but are there, like, I don't know, explorations in the larger implications of these things, their perceptions or their kind of affects at the building scale, not technically, but their aesthetic merits, which is always, or not always, but often kind of forbidden to talk about. It seems maybe more on the table here.
Yeah, I'm especially intrigued by that because I think that sometimes when we get really into a single material, we forget how it like connects, or how we're gonna make the envelope to that. We can come up with bricks, so to speak, but we don't necessarily have the other stuff. And we tend to resort to conventional thinking pretty quickly along that line. And I think that, that's why I keep asking about, like, could that be an adhesive? Could that be right? How well would this type of glazing actually work with an adhesive? And I think the answer is pretty darn well, right? Because it's probably pretty sticky. You're dealing with it, or at least you fire it at first. And so to me, that's exciting because that also introduces formal possibilities that we don't even know yet. We haven't exhausted the library of formal possibilities, right? And how we just came to like, oh, box, fine. Is I think not acceptable to the history of human occupation on this work. Yeah. Do you have anything to add?
I might slightly counter that comment.
Right.
From the lens of digital fabrication and production, to say that I think we're a really exciting moment currently where we have, to a certain extent, exhausted the formal exercises that have come from like the early 2000s advent of digital fabrication being part of the dialogue of the discipline, to now where, yes, the robot can do that thing. Why? And so I think we're at a point in research where its impact and scalability become ways of answering the why. Hopefully we're at a point where we can begin to exhaust that need as well, so that we can begin to engage in larger scale conversations about like the scale isn't material. The scale is much greater in terms of like economic revitalization or environmental recognition. Right. I think that we've seen a lot of conversations around that. But to a certain extent, yeah, the scale was important to know that you could do the little thing to get to the point we are now.
Right. Yeah.
Yeah. Go.
Yeah, I think that's really important to note. Like I think there's a bit of like a disillusionment maybe around just like, I mean, kind of what you were saying as well, Eric. Like there's so much that we can do with like CNC and 3D printing and everything. I think it's important to sort of return to the basics and like what and the practices that you could do by hand. I don't know, maybe that's cliche in a way, but I think it's important to have an understanding of those things. Like in my teaching, I really value like teaching casting and mold making and understanding how something is made before jumping to CNC or 3D printing. Because as you said, like anything is possible. Like we have all those things, we have all the capabilities to do that, but these are still like high energy machines, that do things that are incredible and, could really advance our practice and do things quickly. But I think for me, I'm more interested in like doing things a little bit slower, and like taking interest in that slowness and actually touching the material, actually like feeling what like this charcoal paste feels like in your hand. I think that's really important for me, like especially if you're going to be building a building. I think it's important to, and I think this program here is doing a lot of that too by having like architects learn how to paint or improve their painting skills. I think that's really important to me, just to know it at the hands-on scale.
So in terms of fabrication, I mean, we can fabricate homes now, 3D print them. So, I mean, the technology is and materials moving in that direction. But at the same time, one thing I actually didn't get to talk about in, I guess, length due to timing was that the 3 projects that I showed at the end of my presentation was a response to social impact, specifically food, as I mentioned, food security, food apartheid, and what that looks like for communities that are a quote unquote food desert. and how architecture can speak to that and respond to that. And so the teams were, some of them had to, were challenged because they first and foremost had to understand the community and the impact of that first and foremost before they came up with any design concept. And some of them struggled because, they're like, well, how do we design for a predominantly African-American community? Most importantly, we're designing an urban farm. We're using architecture to speak to that. And what would that look like? What crops would they yield? What scale do we have to design? I mean, like, is it a big scale or small scale? And I think Lettuce Design did a really great, that was the winning team. They did a really great job because out of the 3 teams, my model, Value Inclusive Design, examined or analyzed how and why they won the competition. And specifically for that winning team, the third winning team was more local, the second winning team was more regional, and then Lettuce Design, the winning team, was global. So you can scale it up, scale it down based on the needs of the community. And so you can then use specific materials, maybe in a modular way, but in this case, they were just kind of showing just like their design concept was kind of like thinking about Minecraft and then just kind of placing the pieces on the site. And so then one of the graphics they show is like inserting these pieces where they need to go, but they still came up with a whole program that was very sustainable, but also creating jobs for the community as well, which then would really invite more people to be a part of that process. And that's where we talk about the community engagement, the management of that, because you not just have shareholders, stakeholders, but you have those community members that are really helping it to thrive. But then using the architecture to make that happen and make it a reality. And for folks that are in Ward 7 in Washington, D.C., that's a huge, big deal because they don't necessarily always get those opportunities. And in fact, Walmart was supposed to, where the site is, was supposed to build there, and they pulled out. So just the ramifications of that and being 3.3 miles away from your nearest supermarket, fresh food. I'm not talking about dollar stores or carry out or getting fried chicken. I'm just talking about buying fresh vegetables, fruit, etc. And that's just, some of the challenges that we have to address when we're designing. So.
Yeah, and incorporate into our own versions of circularity too, right? It'd be interesting that going from the Amazon fulfillment center thing, okay, but now you can reuse, once Amazon pulls out, relocates, you can reuse that material at the community level. I love this material bank idea, that it's almost like a public library. Go out, what do we have? What do we have in the closet? Oh, we've got all of this stuff, What other questions? What time is it? Oh, yeah, got one more. I'm going to, go ahead.
First of all, I really thank you for your mind-opening presentation. Your storyline was so seamless and it and the end was so intriguing. I just have a quick question to actually Maxwell. So, almost every year there was a massive fire in the LA area in Canada. Then I'm how sure that some of them were turned into complete ash, but many of them he stays as a biochar. So kind of I don't know. So your presentation started with the creation of biochar, but is there any way that we can take advantage of your idea, recycling the already naturally every year produced in massive amount of biochar into something, into larger product or interior or architectural product?
Yeah, that's super interesting. It's
sorry.
Yeah. The talking stick. We're in very apocalyptic times, needless to say. But I think that's a really interesting point. If there's a possibility, and I don't know, maybe my little spoon is an example of that maybe, but I could see that being a possibility maybe. I don't know what
that would maybe look like. But going back to this like mortar idea, or using it as some kind of adhesive, like this ash material could be this sort of like, I don't know, like phoenix, or for lack of a better word, like rising out of the ashes in some way, whether it's in the form of brick, in the form of some kind of mortar, or a way to create products in some form, or some kind of. I mean, I have a couple students in my material studio class who are working with charcoal as filtration system. So it's like there's this impending doom of clean air, but there's also like a functional usage of charcoal as well as a filtration system. So it's like there's certain ash that we don't want to breathe, but then there's certain ash or the other byproduct of burning material that actually cleans the air. So I think there could be a really interesting feedback loop between like the reparative char and then also the somewhat the destructive. But I think that's a really interesting idea.
I like the idea of you two working together. Also because, it strikes me that what's glazing is also possibly a sealant, which is another discussion in architecture of incredible wasteful material and toxic material that we use. Did you follow up, Kelly? Or
Just really quick.
Yeah.
I think that what's really interesting about that too is I think now with the kind of tragedy of the Los Angeles fires, for example, the advantage of it maybe is the opening of doors of policy. So now LA is reconsidering all of the kind of building types that they never considered before were never kind of allowable. So there seems to be an in with that. It's like really.
And that's a good point too, in terms of like how the modernists did this in 40 years is, there was war to consider, right? And so they were willing to entertain quick building and and modular construction. I want to end on Phillip Beesley because I know that it's just going to be we're going to have a kind of instant upgrade. So here's not with you.
I'm gonna downgrade it. No, we're definitely. Well, actually, no, I am doing kind of. It's in the a board of NCAR, which is the National Architecture Registration Board. It's actually licensing architects. And of course, the definition of an architect currently, if there's a slightly longer one, is the protector of the public or for the health, safety, and welfare of the public in the built environment. So the role of the architect is to protect the public. Health, safety, and welfare is the key thing in the built environment. And of course, that traditionally or currently is defined as like buildings don't fall down. The health and safety are very clear. Okay, it has good air, it doesn't fall down, there's not egress, there's fire, and it's very clear. But I sit on a board that's really looking at like what's the role of the architect in 20, 30, 40 years, and in light of AI, in light of all these changing consultants. And one of the things that we're considering is the welfare component. That's not very well defined, and whether actually architects the definition should pull a little bit away from the technical and go more into the ethical, in that we need to actually be aware of social inequities that design can create. Mental health being a major element. Of course, environmental sustainability and resilience. If these are actually the roles the architect should be carrying legally and be responsible for, in order to kind of push back against the fact that like developers often, can the person paying the bills kind of makes a decision with contractors but if there's an ethical component that in order to get the permit, which is kind of the thing that the architect has control over, they have to have very similar to doctors that someone mentioned that do no harm kind of attitude, at least be aware of a history of certain types of designs that cause, whether it's environmental, social, or material problems. And so it's an interesting idea of going from technical to ethical, but still with a basis in the technical. And whether we pass off the technical then to consultants and to builders, but where, let's say conducting ethical side. So it's an interesting thought. I mean, it's down the road and it's but it is something that's being discussed at the national level.
That's really fascinating because I think of the way in which as well, I think the ethical viewpoint gives us one where we're going to invent more that we've never even thought of in architecture. I mean, I can't wait till the grannies get together and, you know, think about the, you guys have anything to add about the ethical dimension? I mean, Eric really summed it up.
Yeah. So just really quick, I'm gonna make a plug in it, and I was talking to you earlier about it. So there's a book called Symbiotic Cities by Dr. Marion Stolberg. And in that book, in chapter 12, myself and a few other people, in chapter 12, we write about urban architecture for well-being. And we're discussing those type of things in that particular chapter. So it is accessible. So you could just like Google that and just read that chapter. It's a really popular chapter, and I know Marion is so excited.
What's the name of that?
Dr. Marion Stolberg. So she's in the Netherlands. Yeah, so the book is called Symbiotic Cities, but then particularly chapter 12, I was one of the authors in that. And so we're out of time. So I was just making a quick plug to read more about that.
Yeah, we should, you know, we should have a book table up there by each other's books, for sure. Okay, so Phillip, last but definitely not least.
I hope you don't mind if I make a comment, an analogy, and then a rather solemn question. To comment, I thought that these 4 presentations were exquisitely important and really were an essay about ethics in the end, in disposition. Eric, you're speaking truth to redlining. Yeah, so quietly, firmly, and then offering the matrix of responses. Max, the revelation of this new material, which can be embodied with all of its risks as well, the new ornament that you're offering, Christopher, extraordinarily important, and the deeply interesting quality of the license of Vignola as a way of speaking about the chorus and the cadence that might give us confidence in a profession today, Dora. I thought that those were 4 deeply practical and very, very important examples. An analogy, quickly, is about the license, perhaps, because I think that you're offering another version of the Turing test in which we have confidence in the density and the chorusing of our human artifice itself, making its own canons. Would be, I recently learned about the recording techniques of Queen, which is before auto-tuning. It's an analog process with Freddie Mercury and his colleagues, in which trios would sing in harmony, find each other's unison, and then those would be radically stacked and stacked again and stacked again. And there would be 27 or 54 or even more tracks all combined. And so rather than the kind of the blurring of moving out of tune, we have the sheer agency of each voice seeking not so much the transcendental abstract quantum, but rather the agreement between. And that intensity is what creates an extraordinary cadence, which is a kind of conviviality, I think, that we might draw some encouragement. Let me darken that tone.
Oh, it's gorgeous. Okay, yeah.
Darken tone in the sense that when I am less optimistic than I'm feeling right now after being in your presence, I worry about a license, and more than worry, I approach the unspeakable in the sense of the brittleness that I respond to, and I think others very naturally do, in the face of external strain. The external forces are so severe. How can we even give them a name? Past catastrophe. War. How then can you maintain beautiful dispositions that you've offered us in a time. Please forgive me for the serious tone, but perhaps it honors the beauty of what you offer.
Thank you, Philip. I appreciate both hope and a little despair in together. They go together like chocolate and vanilla or something like that, right? You know. My quick answer is a couple days ago I had the pleasure of taking my son to see Hamilton. And Hamilton is a story of war and not knowing where we're going and not having a road map. And the message that Lin-Manuel Miranda has put together here is just this: rise up. Keep rising. Do not lose that. Don't let that despair. Just keep rising. I know it's hard, but keep rising. Well, anything that anybody want to add to that? Yeah.
Yeah, I was raised in Appalachia, so a lot of the thinking, right, and making comes from ideas that were kind of commonplace to my childhood, even though I don't live there now. So I think a lot of the things that I'm trying to think about are a rejection of, you know, for example, the current administration's ideas that the Appalachian people are lazy and they don't have, you know, the desire to work and that they're uneducated. And while some of those things, you know, you can make a case for education and there's a larger factor at play. And so to the comment of war, like, you know, there's always a war being waged on something. And it's an opportunity to react to it in my mind. And so I think that gives a little bit of heft to the work, or like drive, at least for me personally. And that's one way that I try and think through it, is there's always, you know, something that varies at play potentially, but how do you seek those moments of reframing it potentially?
Yeah. Go ahead.
Yeah, I think also, yeah, I think that's really beautiful, Chris. And it's also sort of the starting point. Like, I think the despair and maybe the doom of like any kind of post-industrial design or post-industrial architecture, in that sense, like, I think maybe that darkness is like the starting point. And I always go back to Anna Singh's Mushroom at the End of the World, where like she discusses the first plants or fungi that come up after an atomic bomb hits. You know, the things that grow within the most dark and horrific events are the, you know, possibly the most hopeful, if that's even the right word for it, or, you know, optimistic symbols. But I also look to Donna Haraway's like Staying with the Trouble as well, and even just in the title, it's like this staying with it and not pulling away, being conscious of it, and existing within that and being able to grow out of that. Like for me, it's within these sort of post-industrial spaces where nothing else can grow but these sort of displaced, possibly underappreciated maybe plants that I think symbolize and are demonized in a similar way to displaced and other people. And I think the language also around them mimics, mirrors even the way that we talk about folks who have been othered in this society. So I think within those spaces, within that darkness and within that doom, there are things like, you know, maybe that can rise from the ashes, whether it's through these symbols of mushrooms, of, you know, of fungi, or of the ashes themselves, perhaps.
Last comment, Eric, you got. You're gonna close us.
Yeah, just following up on the health, safety, and welfare. I mean, as architects, we abide by the standard of care, and so that really starts with which another plug for the book, talks about just as designers, architects, just having an empathetic lens, really to understand not just ourselves, but other people, so that, and it starts by listening so that we can respond in such a way that is to do no harm. And when we do that, we can come up with some solutions that, whether working with materials or using a theory to translate that into practice. However, we're all working towards that same goal, that same destination. Just, but yeah, but empathy is the hope that we have in the devastation and the gloom, the doom, all of those things, so that we can not necessarily design a beautiful, pretty world, but design a world that is for not just human life, but all life form, and valuing that, and valuing everyone that comes to the table, and bringing them, and those that are not at the table, bringing them to the table, because their voices have been unheard. So, yeah, I'll just end with that.
Thank you. That's awesome. All right, go have lunch. Eat some sandwiches. Yes, eat sandwiches. Those are not my
Oh, yeah. Got a lot of sandwich at the red.
Oh, okay.
Yeah. Oh, yeah. So we got the brick. This is like the
problems with files coming out of that one.
If they don't work,
Like I think it's just exporting the thumbnails and not the big files.
so we're not gonna get files.
I got the videos are still good,
Ah.
but the thumbnails are super grainy. Like they work at like on a phone they'd be fine, but you can't blow them up to put them in the presentation because they're like 1 megabyte JPEGs instead of like 15 to 30 megabyte.
Instead of raw.
Yeah.
That's a camera setting, I guess.
I wanted to make sure.
I think so. It also uses a non-standard SD card, so I'm wondering maybe if I can get my hands on a SD card reader for that instead of running it through the camera on USB. But I have done this the same way before without issue.
Yeah.
So I wouldn't be too worried. We'll figure it out.
Oh, yeah.
Don't you guys remember that?
Oh, yeah.
This is good.
Yeah. So
I'm gonna go look at the.
it has an interesting, like when I was making that like chair, the paper pulp that I mixed it with sort of like sat out for a little bit too long, and it gained this like really bizarre smell. So I like added some essential oils to it, and then the weird smell sort of mixed with the essential oils, and we're in like a new kind of eucalyptus, but also like mold maybe smell, and I wonder. But this actually wasn't near that, so. But
It's a new, much a new Finland.
are you presenting this week?
No, just attending. Yeah, starting this year at this coffee.
No.
12 hours.
No, that's okay. I thought I was just there until like 10 o'clock.
Right.
And you get the- He's like, hey. I was like, I am, okay.
Wow, yeah, I'd love to get your email if that's okay. I want to make cities edible, so I just
Edible?
Yeah, I really like edible landscaping. It sounds like you're really kind of something maybe, but. Are you?
No.
I could teach you that.
Is that the school? Or is that like,
Let's go back to the future.
We're just gonna follow that.
But you do amazing work yourself, you know, so you always give yourself credit.
I get.
No way. Like you typed in like material conference.
I was like, I want to go to architectural conferences. And so I was like, can you tell me like architecture conferences, sustainability, regenerative design.
I'm glad you mentioned that.
That's awesome.
You're right. I mean, we're exploring a lot of things, but for that, we are a little stuck, and so how do we bring that? How do we push?
So it's like an AI conference last month.
Or just there, you know, that's. Right, because as soon as you say, I'm going to you with a better word.
No.
It's like this, you
Yeah,
know.
we were driving it from Pollutants today. You know, we're offering the ride, but like Saturday morning for college.
I was at the ACSA.
Oh,
Were you there?
No, I went.
I was just in I just came from that.
Yeah.
Yeah. Oh, like when you come back tomorrow, you get to see the thing, and in my head, none of my students are coming. I hope I get to see it this quarter. Maybe. But they have boxes
And
of course.
it has a sort of material perspective. So they do all kinds of construction projects on
Yeah.
right now. And they're that's
I'm just really happy that robotics is gonna do it now because
Yeah.
it's a great material,
and then she
but
just gets into
I think it's hard to convince people to go back to that sort of labor, especially in the West, like.
Is that like render?
Yeah.
Yeah.
possible.
I know, I was surprised to hear that they were, but.
The guy, did you meet the guy?
Yeah, I had a student,
Pink cowboy.
Yeah.
And the little dog with the hat, yeah. Covered in dirt. Like, I mean, like, if you're gonna be a red earth guy, like, I would expect that. You want it. Yeah, I didn't get to see his, I was at the court blood, but it seems like he's doing really interesting stuff.
Nice, well, I think that we're gonna start playing more to do some quick mock-ups or live. Really put around there.
Yeah, I'd love to check it out. Yeah, my responsibilities are.
Nice. It was a good presentation. I slept way longer than I thought. So I think that's a lot.
Yeah, it's good. Oh, so much variety in the topics today.
Totally, yeah. Yeah, Chris was talking about like post-industrial tile.
Yeah, they specifically thinking places out of.
Other ways. Talk about charcoal and as a biomaterial, as a material experiment, and Eric was talking about like community center design.
With the charcoal, like, you guys doing like walls or were you doing like temporary stuff?
Sort of just, we're kind of at the very beginning of the experimentation process. This conference was a great excuse for me to like get going on it. But I'm more at the smaller scale at the moment. But you mean like in terms of getting material or
Applications, I guess, like forcing business.
oh yeah. Like for radiation. You need to target more people. Yeah. I did. In Providence, I was working with this collective where we were making floating wetlands on like polluted small bodies of water, making just the tiniest bit of impact. And not like you would really need like 100 of them to really make a huge impact. But
people don't know that exists. I just never, like,
whoa. But we made the pontoons out of Japanese knotweed bundles, which were like super, like just as flotational as like plastic or yeah, I mean like it wouldn't last as long, I guess, as like a
Do they need to last long?
They could just be replaced, like, I mean, it's like if it rots away, the one that we currently have up is like, it just barely survived the winter because it froze under the ice.
Oh.
So it's sort of like rotting, but it was still floating, it was just like a little lower, so they're actually going in this week and replacing some of the pontoons, but that was sort of the only remediation stuff that I've done, but with the charcoal, that's sort of what it's all about. So I don't know, maybe some kind of module that could be placed on brownfields or something. I mean, Indiana's full of super fun sites. Like if Indiana has like
Oh, okay.
Yeah,
It's fun.
super fun.
Oh, sorry.
Like
Okay.
I don't actually know what it means necessarily. I feel like
you meant fun in like an ironic way.
yeah, super fun site.
That's what I heard too.
Yeah, sorry. Super fun, which I think means that they were like uninhabitable or like unusable because like RCA, they had like radios and TVs was based in Bloomington and they dumped all kinds of crazy shit into the bodies of water and then made like large parts of Bloomington like the water was super contaminated and full of PCBs. So there's a lot of like remediation work that has to happen to make like these areas still like, you know, the water drinkable and the land plantable. Like I think you need like raised beds, you know, to plant stuff in Bloomington. I think so. I mean, that was Providence too, by the way.
Oh, yeah.
The city I live in, there's like this landfill. It was just like a infill dumpster. On a good old dumpster.
So just like one hill.
Yeah, they covered it.
That's so funny.
Put a T-bar on it.
Wow.
Where? You said California?
In Saskatchewan.
Oh, Saskatchewan, Canada.
People think
Is it in California, Canada? No, no one's ever said that. That's really interesting. That reminds me of in Copenhagen. There's a trash incinerator. That's like a mountain, and they made it into a ski area. Big garbage.
I love that. So I actually like burning trash. I'm like so pro burning trash.
Like as an energy source, or just like just for fun.
But well, no, I can't really do it for fun because air that you can contain it and then for it's like thank God like there's much in the world. Like,
yeah. Yeah. That's what like doing biochar feels like a little bit. It's like you can use yard waste, compost, like any kind of biomass really. You could just pack it in like a pretty like low oxygen environment and burn it. But I mean yeah, like I think the best way of doing it is to like really have it covered like in a Dutch oven or something, but you can also just do it in a pit and you lose it's a little bit more smoky, but yeah, it's supposed to be sort of like closed loop system. That's like the more
no, I had no idea that there'd be another aspect of I don't know what the word is, like recycling or remediating.
Yeah.
Yeah, I don't know how we do it.
That clicked. It was really great. It was like okay, great. Yeah. Let me actually just talk to Virginia. Oh, yeah. Hey, Virginia, can you hear me? Virginia, can you hear me? Nope. Okay.
Yeah, it's still, yeah. That's right, and I know I'm log in. There is actually. These are fine. That's what I would see, that's like stuff. Yeah, but it was like, yeah. So. Yeah. Was also like, yeah, so I say, basically, look who I'm with, I'm like, how can so much harder. It's like she was like, how are they? She asked me, she's like, oh, really? Well, I'm sure you're talking about the big ones. Yeah, yeah. See I mean, yeah, so I mean, Well, sometimes you know, really sharing. Not much. Not the expecting. You know, the afterwards, I'm like, oh, when you come out after dinner, it's not very. Like, you know, but I want other things. While we were like, oh, yeah, and you mentioned, because we might have, now, and then. Yeah, so it's like, people get invited to firms, other people, I was there, I was just saying. Oh, we're going to this is yeah, they're like, one of them, when I was out for you know. It's like, usually there's like you know, that's right. I see the way where every our parties, I think there's hating to like our parties. Yeah, everybody's. Some people say they saw maybe 1 or 2 swords, but I said it's collective usually like we're considering how I mean, person why you know the students. Yeah, I know about it. So actually that was a very long party or essentially me. I mean, one of my professors was like, yeah. He didn't just walk right in. No, like nobody's talking to him. He walked right in. Because they didn't ask like, your name, and they check. He just looked like he was there. Yeah, so that. And then, yes. So we only did only out of yeah, I'm 100. So my first message. So the program is giving us governance, education, and culture. We're theory. That actually And then later on, yeah, it is. Okay. Yeah. Sometimes, well, yeah. It still feels, it's not so much like a feel, oh, we're done. Right. Yeah. Yeah, they don't like to they yeah. Sure. That's what got me. That's like supposed to do. That's the same. So it's like that. So then that color, that's good in that color, that's good in that color. You have maybe I was trying to whisper this. Just or just a but the maker it's not bad. Let's just so but it's the first round. If you get something I love the idea. Yeah, actually that raise in that office like our rules. And then he was on his site, he's like, oh my do you consider he said no, you don't understand great time. That's like you know that's not even scratch. Now he's back in the body. Yeah, like he's definitely elevated. Yeah, I was saying this is so not this recent session here, but I agree. And I was like, man, I said now we get that's another colleague who we just sorry. Like often email no one ever I don't know what it is. It's very nasty.
Oh,
Yeah, because like it'll be the same, I'll make the same comment, it's like, you know. So like, same comment. But it shouldn't hit them, especially just like, and just sketchy, yeah, expressing. So the thing is, everybody is like, yeah, we need to. So it's like, that's what you're supposed to write. And then like, you don't even have, and you don't even have in plan a beautiful plan diagram. Like at least work with that. I mean, that's it. To give us a sense of scale, space, of program. And sometimes, like, okay, so I like all of these, and like, during these, and it's not very much, right? But it's still just like a concept. Without like, that I said, I'm looking for not what I want. I said, also let you know. You're not restricted. The only restriction is when you're restricted. But I said, like, it's pretty a lot of fun. But they actually like, you're like, you know, you programmatically just like make sure that at least you can see looking down the plan. We can condition, we don't have to have this structure, but we can actually. And that's what we're. Or they like, where's that plane? Is that plane that's gonna sell? You know, and it just, she didn't idea. It's just like, so I think here, I was so that particular year. No, it's not long. I'm part of I went project, you know, take all the area, my students work with the, I mean, so like textbooks that we talk about how like Washington D.C. and certain communities. So I do start off with actually researching to make. And as we progress, yeah, and as we progress, by the time you see our I don't know the diagram. And I said, that's the point of it. It shouldn't be, but be creative. We have a new site. They've already did a house, new site, and then do an investigation and apply everything that they previously did to that site, and then they have to justify it. So that's why I talk about it. And I said, look, the plan, you just have to just like literally just get of that and how that fits into the context of the. It's, you know, a lot of stuff you right years. I mean, I said, everybody just and people like, what is and I was like, oh, let's hear from inside. It's a graduate course. I said, well, if I'm supposed to teach your name, you're gonna have me. And we have students which I was yeah, so after I came with the break, I actually said, guys, they didn't come to open house. Yes. And I was my students. And they were like, yeah. And then also too, I think insurance. So it literally had like picture of them, their name, project. So then people know who's who. Because so I literally labeled like everything. And so I had and then one block and then the process works, and then they can see the final from the project. So you're kind of the progression of that, like, you know, because that's especially after the when you do process and it's not how that works.
We just actually got our accreditation this past week. Yeah, so it's like, I think that's kind of going to show that how people are, how they use so I needed to my own. Yeah, and then some say, yeah, so they decided, and something wrong with that, it's actually he was decided I actually like to his work, just really, brilliant. And he helped people just kind of one of the things I did since all the experience, like basically 5 cents and parents to be 3D, so they're 3D flag, they come and see images 3D. Then I have like a speaker, I have like traffic noise and stuff in the background. And I like yeah, one of the thing, yeah, and I had oil, yeah, and I had oil, so it was like the shit, so you can smell what was there. And then also like a snack station, yeah, so I wanted to create and I was like they were like shiny, and so that space was low. Yeah, because I didn't like and then like yes, it smells so good. Hey, so I really wanted to get it out there. But people like oh, they were really nice. So I like to figure out so that's yes.
I'm glad that I think like
It's probably. Like, it's the same. Oh my God.
Yeah. I watched like yeah. Yes. Yes, it's the main goal. It's also this energy vampire and I think that person like if you talk to like literally like yeah like the kind of people that I think like are trolled on the funny is like also actually I'm going to meet him pretty wrong too. I don't know what so tiny. Yeah, it looks like Holly Robbins. Yeah. Yeah. I didn't think that it was like longer to do all that. Oh, I guess. I mean, I'll make sure you.
Oh, it's the other one again. It's not now.
So.
Yeah.
You know, yeah, I can.
Yeah.
That makes you right. Yeah. Better. Like the background noise. Yeah, absolutely. Yeah, that's not.
She's on. She's on. Okay, so give you about 5 minutes to wrap up lunch, and we'll reconvene in the seats, please. Okay, folks, we're gonna head back to our seats and start the next session. Please, thank you so much.
Yeah, yeah, that's part, yeah. That's part of it. Yeah, when I do that, just I find out. Exactly. Yeah. Yeah, no, it's not like, yeah, no, I'm not gonna, I didn't enjoy the music, right? But you get, a little bit of sweat. You're like temperatures rising. True. Well, Baltimore. And then
Hi, Virginia, can you hear me?
Yes, yeah, I can hear you.
Yeah.
Sorry, say that again.
Can you hear me?
Yeah, I can hear you. Perfect. Thank you very much. And then we're gonna get the PA connected here just in a second.
Hey, Virginia, it's Phillip. Nice to see you.
Hi.
Hi. Hey, I'm really glad that we're doing this together.
Yes.
Virginia, I'll just read a short introduction to you, and then I'll pass it to you. Is that okay?
Yep.
Great. I can hear an echo in this machine. So let's just make sure that we've solved that before we go live, okay?
Yeah, thank you. So, Virginia, if you'll just do a couple of tests for me, just with your audio.
Yeah. You can hear me, yeah?
Yes, I can. Do you have someone in the background talking?
No.
That might
That's
be.
you.
That's probably us. Okay.
And
Yeah.
Just turn this on.
I can hear next over the person. So what I'm gonna do is I'm gonna turn off this. And then I'm gonna ask you just to go cancel this one. Yeah.
I'm still a class, like I have seen the slides, so professor, I get, I'm like, hold on. I'm not one of them.
Okay,
I'm not
we'll
one
do
of the professors, so
Virginia, can you hear us now?
Yep. Still hear you.
So we just got you muted. So we were just going to do a test. Right now, we're just dealing with an echo. So just please bear with us. Hang on. I'll let you know when to test, okay? Okay, I'm just going to mute this microphone for a second. And then Virginia, right now, can you please just speak and test?
Yeah, can you hear me now?
Yes, yes.
No echo?
That's great. Now I'm going to turn on the microphone again. Would you mind testing again?
Yeah, can you hear me now?
Yep, and it's working. This is going to be a beautiful experience. Thank you. All right, Virginia, I'm going to bring the session in now.
Okay, I'm gonna introduce you. Is that okay?
Thank you.
Okay, well, welcome back to the afternoon session. It's been a lovely morning, and I'm really grateful for Dora and all the navigating she did this morning. It was really wonderful to have that conversation. And this afternoon, we're pleased to have Phillip Beesley with us. Phillip Beesley. Thanks, Google. Phil Beesley is, I would say, a mentor and a friend, and also a world-renowned designer, architect, installation artist, and thinker. Just an all-around amazing person. He's been influential in as a mentor to many people, founding LASIG, the Living Architecture Systems Group, which is a collaborative, if I understand right. And he's worked with Iris Van Herpen, a fashion design staple, and in addition to that, he's done work, say, at Venice Biennale several times and other amazing venues. He actually has an installation here at Luddy, at the School of Informatics here on campus in Bloomington, and has many collaborators and people that he works with to create his amazing works of art. So we're really happy that he's sharing the session, and with that, I'll turn it over to him and a round of applause. Thank you.
Thank you so much, Spencer. Hi, colleagues. It's really an incredible honor and really a kind of delicious experience to be together at this compact and intensely important gathering. Every one of you has such an important voice, and it really does feel like we're building some material that has resilience and strength and gives tremendous hope. The session this afternoon is going to be in 4 parts. I'll very briefly introduce each of 3 speakers who will give a paper each. There'll be a chance for questions for each of them. Then I'm going to give a longer talk. I hope you'll indulge me. And then please, we'll have a final roundtable where we all gather together. I hope that'll be okay. And I think that we'll want to have a stretch break in there as well, maybe before I start speaking. So, Virginia, thank you for joining us on screen. Please wave to everyone. I'm just going to read your bio. I hope you don't mind. Virginia Ellen Melnick at the University of Buffalo, and now an assistant professor at Iowa State, right? I mean, that congratulations, is a computational architectural designer and researcher specializing in knitting, lightweight structures, and transformable architecture. She's pursuing a Ph.D. in architecture and design research, focusing on the integration of crafted knitted textile techniques with advanced computational methods to develop adaptive and responsive architectural systems. Her work explores in particular the interplay between soft and rigid structures and leveraging knits, elastic yarns, and transformable knit frameworks to create deployable structures that stretch, fold, and interact with both their environment and their users. Virginia's held academic positions at Virginia Tech, University of Michigan, Clemson, and the University of Buffalo. And I love the conclusion to her bio. She envisions a future where architecture adapts seamlessly to meet changing needs and conditions. Virginia.
Right. Thank you, everyone, for having me. And let me just share my screen here. Hopefully you can all now see my presentation. And I will try to keep time here as I have a lot to show, but I'm just showing one of my projects, which is working with a transformable wall system, or a proposal for that, since it's kind of still in an abstract exploratory phase, using knitted textile materials to create enclosure for scissor structures. So I am an assistant professor at Iowa State, and I'm here doing a lot of research on knitted materials, which, as you might know, have a different structure than woven materials. So on the left, you can see a piece of fabric that I wove on a loom, where you can see the clear warp and weft yarns. And on the right, you see a knitted material where the material is a bit more seamless and made with a looping structure. So knitted materials are made row by row, with a continuous yarn that loops back and forth through itself. And with this structure, it has more elastic properties because these loops allow the material to stretch and expand as the fibers can slide between loop to loop. There are also possibilities for these stitches to be done differently. So you can do a typical knit stitch like that previous diagram, but there's also tuck stitches where you can loop 2 stitches together, or doing a purl stitch, which when you get to knitting machines becomes a rear stitch, stitches that interlock, stitches that transfer left or right to create holes in the fabric or narrow or widen the fabric. So there's many ways to really make these textiles more specific and more unique than a woven material. I'm also really interested in the materials themselves. So this is working with different fibers and how different fibers react to one another. So still working with the horizontal striping, since the knit material is fabricated in these horizontal rows. Each few rows, I transition that material from one type of yarn to another. So in this case, maybe like acrylic to nylon or acrylic to hemp. There's even some wire down here, or elastic yarns, or working with kind of monofilaments like fishing line and other kind of rubber yarns to test what happens to these materials as they combine together. And what you see is that these different materials start to cause things like puckering and wrinkling, because the different materials cause different stitch sizes, different elasticity and stretch, where you can pull it one way and you don't see the white yarn, and then you pull it another way and this white yarn is exposed. So this kind of playfulness and transformation that the material can go through as it moves. And then, of course, as a digital designer, someone who was educated in the age of Grasshopper, I'm interested in how we can then simulate these materials and begin to play with them in the digital scape, so that we can simulate larger, more developed designs without having to continually prototype and make them all, but have a few samples that feed in the information into the digital sampling. So how this materials that I'm interested in relate to architecture and scissor structures is the fact that we have a difficulty with adaptive architecture and transformable architecture in creating a closure. So when you see this kind of geometry moving, there's a lot of different shapes that take place. This diamond is stretching and conforming to a variety of sizes that become a little bit difficult for more rigid materials to infill that gap. So we can create things that expand and contract easily with linear struts, but when we want to enclose and actually create surface, we could use a woven material or a panel, but they have restrictions and they won't expand and contract with all these different geometries that this shape is creating. So that's why working with knit materials can allow for that expansion and contraction as the material is allowed to move more freely, because itself is expanding and contracting due to its elastic properties within the knit structure. And then adding this combination of testing different materials together to create effects like here, where the clear yarn kind of curls up and creates almost pleats in the fabric. Or in this case, playing with different geometries so that certain colors could be exposed in new ways, where you don't see the gray and then it opens and you get these really unique pleats when it's closed. Or different stitch structure that has more openness and transparency and more enclosed, exposing again new colors as it moves into shape. So you can see how this geometry is able to follow that form. But of course, those are small tests. So I'm curious how we can then get bigger, more human scale, and push those boundaries into being something that could be a wall and in a space. So I built these larger frames, which are out of wood, simple scissor structure frame, and began to study how I could create panels to infill these larger frames. So with that, looking at the different panels, unlike the small studies where I could just use one large knit piece, due to the constraints of the knitting machine's size, I couldn't quite use one giant panel. It had to be broken down into smaller panels. So there were several iterations testing different arrangements, whether the panels would follow that diagonal grid arrangement, or whether it contradicts it, going kind of across it, or one large panel with smaller ones to kind of fill the sides in. So these variety of panel designs were just studied in Rhino to think about what different layouts could possibly be used for the design. And then, of course, checking at the bottom what within that diagram, one individual panel's movement has to be. So what are those extents of stretch from the squishiest to the tallest stretch shape, that diamond, and how what those dimensions are. And going back to the material testing as I prepared to make these panels, looking at the different striations. So from my early studies of all the different swatches of materials, I sort of narrowed down that this nylon covered elastic yarn that has a lycra core and a nylon coating, which allows it to slide through the knitting machine very easily compared to some of the earlier studies that were just a rubber yarn. Gets kind of messy and grippy in the machine. And these testing the strength of the material and how far it stretches. So being able to put that amount of tension on it and see what that elastic property is, how much it stretches from its relaxed state on the left to its expanded state, for how strong I could pull it apart. And I think you can see there, it says at like 5 pounds of weight, perhaps on that spring scale. I can't really read it. It's not on, but, and then testing the same for the nylon yarn. So investigating how much does that nylon yarn stretch on its own. And you can see that difference, that the nylon yarn doesn't stretch nearly as much. So even though the knit structure itself has elasticity to it, the elastic yarn adds even more to that elasticity. And so that property helps balance some of the issues of stretching, where the knit material typically stretches in that coarse side to side direction more than the up and down wale direction. So by adding that elastic yarn stripe, we're able to get a more equalized elasticity across the surface of the material. And here is kind of the testing of a sample of stripes. You can see the relaxed to the stretched. And of course, I'm not going to show you every test I did, since there's hundreds of them, samples and swatches of different stitch types, different size stripes, different types of yarn, mixing them together, overlaid. And through these tests, there's also tons of failure. So learning a bit about how to work with the machine, because I was using a manual knitting machine, which I'll show you in a minute, that every time I switch yarn, there's issues in that transference of the machine adjusting to the new material, which caused errors of yarns getting stuck and caught in the machine, and this kind of beautiful fraying as it got tangled up. But once tests were more successful, getting them into a singular frame and being able to understand that movement. And what becomes really beautiful about these is that when you're looking at that diagonal movement, is the stripes move from that horizontal shape and stretched into this skewing and curving as they relax into their comfortable state, as they meet those extremes from skinny to square diamonds. And of course, trying to still follow with the digital studies to simulate, to test that these forms are going to work when they're expanded across a larger surface, and testing that with grasshopper and kangaroo to see that performative movement of the material, so that I know when it's at a larger scale, what those movements will eventually look like. And with the grasshopper, I'm also able to develop patterning. So with these knitting machines that I'm working with, they're manual, but I also am trained to use digital CNC knitting machines, which read a sort of pixelized code, where each color is defined by a stitch type and a yarn type. And so you can begin to program this pixel diagram for each of the panels that you can send to the machine to do the different knit structures. And so here you see the 5 panels for one of the wall layers, which is this sort of long diagonal, 2 medium, and 1 small panel. And you can see that they're also not proportionally related to the actual piece, because when these very long pieces come out, or this end piece, which is just ultimately a square piece when it comes out. So these drawings are more of a code and not as just a final result or image of what you will get. The knitting that I do, partially because of access to advanced tools, knitting machines are expensive and difficult to use at times, but I have a pass-up dual bed knitting machine here. That's a manual knitting machine. It has a motor to it to just go back and forth, but most of the controls are done manually. You can see here me physically moving the carriage back and forth, bringing the yarn across this bed of needles. So on that bed of needles is creating each of the stitches for the knitting, and you can see how I bring it back and forth. And at the bottom, you can see that panel coming out underneath the knitting machine as each row is slowly created. And in this case, I can knit faster than this video is just demonstrating, but you can really see how your whole body becomes part of this. I have very strong forearms from doing all of this knitting. And of course, the final touches is still quite manual of doing the casting off. So you have to make sure that every stitch is locked in place and sewn to one another so that they don't drop and create runs in the fabric. So working between this digital and physical making is all part of the process that I'm interested in when working with materials, because the tactility of fabric and making textiles is quite important. And here's that first diagonal panel, and you can see how it moves on that scissor frame back and forth and stretches and skews to those various forms. And then I tried a second arrangement where this arrangement wasn't following the diagonals of the grid, but actually following the orthogonal of the world. So going vertical and horizontal. And what you see is because those middle pieces become pulled and skewed, that you get an even more kind of what people have called psychedelic movement in the fabric as it really squishes and expands in various ways compared to the more controlled diagonal form that follows the geometry. And of course, one layer of these panels wasn't enough to really create a wall, in the sense of the goal was to create a wall. And so I added 2 layers of panels together with offset scissor structures connected to create that space between them. And this was the resulting wall panel of the vertical and horizontal design. Displayed at Hanbury Architects in Richmond. I had an exhibition there as part of my fellowship at Virginia Tech, where these pieces were created. And here's that wall in action as it can deploy and expand and contract and collapse, creating kind of different fun forms. It's super light and you can move it around. And it creates a sort of enclosure that is light and airy, but still not completely solid. So, you know, adding visual division rather than necessarily a sound barrier or weather barrier. And here you can see that detail of the layering, the spacing between the 2 frames as the video stopped. And how like it's connected there with just little bolts and threaded rod. And then here's that first one, the diagonal panels with 2 layers, so blue in the front, red in the back, and how that detail of those different layers. You can see the kind of crisscrossing of the striations going in the different directions. And yeah, so these walls are sort of an exploration into something that could become architectural dividing walls to create forms that are more free-form and playful, can be maneuvered and manipulated by the users. I'm working with similar forms to create window screening and shading devices. So it really becomes something that is more of a lightweight architecture that allows us to change our environments. Thank you. And please follow me on social media or get in touch if you're interested in more of my work. I'm
Thanks for
happy
the
to take
technical
any questions.
presentation, Virginia. Please, folks have questions.
We'll probably find this out when I look at your social media, but do you sell any of the
So yes and no. So currently, right now, the reason I'm not at the conference is I have a gallery show opening at Mainframe Arts in Des Moines next week. So I have to go deliver these pieces and install them this afternoon, and they are for sale. So I do sell them. I haven't really sold many yet. When I left Virginia Tech, a few pieces were left with some of my students who were, you know, some of my favorite and helped me with fabricating them. So I left some of those for them. So, you know, they do kind of get out in the world and yeah.
Hey, Virginia, it's nice to see you, Jones. So I had a question for you that I hadn't thought about in seeing your work in the past. Have you, you know, the relationship between textiles and rigid linkages and paper folding, have you explored any of the same ideas with origami or origami-like techniques? And if you have, is the preference for textiles a love of yarn, of knitting, of textiles, or is there a practical reality difference in your mind?
Yeah, I mean, I haven't done a lot with origami. I know like the work of Joseph Choma, where he's working with a lot of origami and kigurumi, I don't know how to pronounce that, where he's hardening the textiles with resins, but he's using just fiberglass textiles. Knit itself, you can play with the stitches to create kind of creases and folds within it based on that stitch structure, which is quite interesting. And that's not something I've really played with much yet, aside from really focusing on just the different yarn types and how those can create folds. But yeah, I think that is a really interesting direction that could be possible, the more origami and direction. Thank you.
Right. Really great presentation. I really enjoyed every element of it. I have a couple quick questions. I'm curious if you've experimented with, because I really loved seeing the videos of you manipulating them, but have you incorporated like a standing element where two people could interact with them in one way or another, or sort of create this animation together?
Yeah, so actually, like these pieces, I have kind of just me moving with them. I have several other pieces that I have been working with actually the kinesiology department here at Iowa State and working with their dance students and movement and the body. And so we actually had choreographed a performance with them, looking at really like the proportions of the body, how the body moves, how these objects can move and how they respond to that movement. And we created several choreographed steps inspired by my pieces. So that is something that I have yet to publish. I'm still writing about it. I will be presenting on it for the first time likely in September, as we're still kind of editing some of the video recordings and putting a film together about it. But yeah, I think that's something that I'm really interested in is the body and movement, and how several people can come together to kind of create choreographed movement. And particularly as the pieces get larger, you need multiple people to move them. It becomes more difficult to be singular and pick them up and move them around. But that's also somewhat what I love about them too, is that you can just like one person be like, oh, it's so small, now it's so big. So that's something that is always, a balance between that choreography and the individual being able to really just play with it.
I'm wondering, have you ever considered using like 3D transformer frames, like Hoberman sphere kind of things, or making it art like a yurt wall so it could be more freestanding and spatialized?
Yeah, so I mean, I just presented here on one project. I have several projects that are different geometries, that are three-dimensional. I have like three hyperbolic structures that are kind of more cylindrical in form, and you can actually go inside them and move around. So there are different geometries that I'm continually pushing, particularly with the knit material. I think in this exploration, it was still very flat, and it was one of the earlier projects that I was doing. So pushing into that three-dimensionality really allows for that exploration into the geometry that other materials really can't make complex hyperbolic and non-manifold surfaces so easily as a knit material can. So it is definitely some of the next steps in the more advanced geometries that I'm playing with.
Hey, Virginia, this is Eric here. Great presentation. Actually, when you were talking about dance and movement, I was wondering in your research if you came across Levon movement analysis. So Rudolph Levon studied music and architecture and combined, fused the two together. And when I did my MArch, actually, I did an exploration of movement and how dance can create architectural spaces. So that's kind of food for thought if you wanted to just, maybe look at the Levon movement analysis. That could actually be something that, might be cool to explore in your research.
Yeah, I am very familiar with Levon, and actually one of my thesis students in the MArch program at Virginia Tech was doing an analysis of dance and architecture, and that some of that was how I got into looking at this type of movement. He was focusing on hip hop dance and creating his own Levon kind of analysis and language for hip hop types of movement. So it was a really fun thesis project to work with him on, and that led to me kind of meeting more dancers and starting these kind of collaborations. So yeah, Levon is a really great reference. Thank you so much.
Virginia, we'll do one more question from Juhan.
Hi, Virginia, my name is Chu. Again, it's really interesting and creative project. I congratulate you that combination of linked system and the text side. But you said it is adaptive system, so I'm really curious about how do you want to design the actuator, so you really make it an adaptive system. So something possibly in my mind is that maybe you can just simply add some linear actuator or frame system, but do you have any ideas about that? Your two composite systems, or one as an active, or textile as a passive, or tension, or integration, kind of mechanical composite system, or do you have any idea your next step to make it really as a kind of adaptive system?
Yeah, so I mean, I'm always continuing to explore these things. I think to some extent, though, my role is to be more experimental and playful with the material studies. I'm definitely more focused on just the knitting, and then hoping to collaborate with others that can get into some of those more technical aspects. And so I don't have kind of answers to what's the next necessarily, because I'm hoping that other people begin to pick them up and move them in other trajectories and make them more realistic. But definitely, I'm working now with also on another project at Iowa State here that is dealing with shading systems and creating kind of small scale shading devices for, you know, the windows of buildings that are maybe less kind of stationary like curtains or blinds, but are more dynamic and automated. So we're actually using Arduino and servo motors to create some of these movements and expansion and contraction of the scissor structures.
Thank you very much, Virginia. Let's give applause. Maybe I can just give one more comment too. Huge respect to you, Virginia, in the sense that personally, I operating a pass up myself, I know just what a formidable beast it can be, where a little thing combined produces extraordinary forces and also sometimes extraordinary frustration. So vast respect to you translating this into near scales. It's a pretty extraordinary body of work, and really important example to us all. Thank you very much.
Thank you.
So, colleagues, I'm going to bring in Daniel Barrio, who's online with us now, and please let me ask for Taylor and Molly to come up and join me, and we will have the next paper. Just to do a brief introduction while we're getting set up. Spencer, maybe could I ask for your hand just in bringing Daniel on screen as well. Taylor Douglas, Molly Davis, and Daniel Barrio are recent graduates of the MArch program at the University of Michigan. Taylor is currently a part-time research assistant at the University of Michigan, doing work with 3D printed clay, and a full-time architectural designer at an engineering firm, SEH. Molly is now living in Washington, D.C., where she's a designer at Studios Architecture and enjoys creating pottery in her spare time. And Daniel is a designer at WRNS Studio in NYC, where he's currently Zooming from. Hi, Daniel. They're presenting the paper Facade, Subtractive Robotic Fabrication for Bioreceptive Facade Assemblies, which is a prototypical facade system that uses a 6-axis robot to carve clay into ceramic baguettes, delicious, that can then be computationally arranged on a facade. I'm really looking forward to this. Welcome.
So, hi, I'm Taylor. This is Molly, and Daniel is in the computer. And as students at the University of Michigan, we took the class titled ARC 509, Fabricated Ceramic Assemblies, with Chris Humphrey as our instructor. So you saw his presentation earlier. You can see that maybe we'll be talking about clay. And this class was a semester long, and it was focused on clay and then robotic manipulation of that clay. And so for the first half of the semester, it was sort of week-long exercises where we were trying to get a first experience with clay and then a first experience with the robot.
I'm trying to make it. Oh, there we go.
Okay.
Sorry. I mean, he's there, but.
So in those 6 weeks, we created Facade, a prototypical facade system that leverages the malleability of clay and rough surface texture of fired ceramic through 3 distinct baguettes designed for varying degrees of water retention and moss growth, which you will see in detail throughout the presentation. So we sort of focus on clay, moss, and the robot. So at the start of the design, we were particularly interested in bioreceptivity, referencing projects that demonstrate the potential for moss growth. Moss regimes is the first project that we looked at, where it is focused on both ceramic and moss. The panel in the image here was left outside to weather for 2 years and did show moss growth. And it was also made by vacuum forming a panel and then plaster casting the negative of it and then hand packing clay into it. And so we think that the subtractive manufacturing process that we're introducing sort of mitigates any time and material excessive labor that could potentially have. And then the next project we referenced The role of geometry on a self-sustaining bioreceptive concrete panel for facade application was about concrete and not ceramic, but it was still influential to us in terms of the geometry that was used because it used the micro and macro geometries that you'll see us reference quite continuously throughout the presentation. This image here is what they've so lovingly referred to in their study as panel 2, and it had the most moss growth, largely because the shape of it allowed for water distribution across its surface. And then the last image is one that I took in the wild of Ohio, and I wanted to include it for 2 reasons. One, its sort of surface geometry is similar to the other studies, and so it demonstrates that moss can grow on ceramic, and so that was number 2, actually. It demonstrates that moss can grow on ceramic. So these are some of our early tests. Humans have been working with clay for thousands of years, but Molly, Daniel, and I have been working with clay at this point for a couple weeks. And so we wanted to just show this as sort of our progression as we designed this. The top right image, we think, is the stuff of Chris's nightmares. I'm sure he saw that after the first couple of weeks and was like, oh no, what have I done? But then you see we sort of start to understand how to control both the tool pathing operations and the force of the robot, and then produce some designs like the bottom right tile.
So we're gonna go into what our project is looking at. So it explores how moss can be harnessed as a living facade element. With a highly dense, intricately woven root structure, moss can be an effective thermal and acoustic insulator. Its structure allows it to absorb carbon dioxide and further purify air by trapping pollutants and dust particles. In dense urban areas, moss can become a valuable tool for improving air quality through its metabolic processes. And then this diagram shows how moss is able to attach to surfaces through rhizoids, which are those hair-like structures that anchor it. And most rhizoids are thigmotropic, meaning they respond to a touch stimulus, bending or coiling around the substrate. And when growing on a surface, moss is highly absorbent, able to provide passive cooling through evapotranspiration. Many species of moss are densely covered with those slightly branched hair-like structures, forming a wick that can externally hold and store that rainwater. And during rainfall, moss provides protection to the material below, reducing the amount of liquid penetration and preventing damage over time from freeze-thaw cycles, erosion, and other weathering effects. And then just a little bit about clay. This project does utilize clay's natural ability to be shaped, leaning into its precedent of highly customizable designs. Facade intervenes at the production stage of clay, introducing a method of shaping that can respond to the regional properties of clay without being restricted to the physical limitations of current forming methods. Subtractive robotic manufacturing replicates the sculpting and artistry of previous historical clay facades through the simplification of new technological tools and geometries for better speed and precision. So then this is just where our visual inspiration came from. The baguette design takes inspiration from the natural environment to inform how to strategically generate moss zones. So moss growth is typically found in deep shaded grooves of tree trunks and bark, or the rough varied surface of rocks and boulders. Utilizing this design logic, the baguettes that we created are carefully designed to replicate these organic patterns. In both their geometric forms and intricate grooves, facades baguettes mimic the pooling of water and adequate shading necessary for ideal growth environments.
So moving into some of kind of our research culminating into some design applications. This culminated in facade being developed into a system that uses 3 baguette types that look to compose a range of possibilities on any given facade, really utilizing a simple system of compounding toolpaths. So given the degree of moss growth that is desired on a surface, we added on extra robotic toolpaths to add increased texturing and surfacing for varying degrees of moss attachment. So as a result, we developed this system of only 3 different tile or baguette types, where we have A, B, and C tiles, where A are the more industry standard comparative to your typical baguette die extrusions. And B become transitional tiles that begin to introduce some more complex robotically carved forms that create transitional moss growth zones. To C being the more highly customizable carved forms that are the primary moss growth zones. The three variations are designed kind of with the manufacturing process inherently tied to their degree of complexity. So, like I said, each baguette compounds a different or an additional robotic tool path to add increased surfacing and ability for water retention and moss growth. And so we begin to introduce ideas of how we're going to create varying degrees of moss growth across the facade using some of the initial research that we developed with the micro and macro texturing that was introduced earlier. So that the baguettes operate on that logic of geometric surfacing, where macro geometries can begin to establish deeper valleys that control primary zones for water retention and moss attachment, while the micro geometries can create surface texturing needed for more effective pooling and specifically the clinging of the moss to the natural texture and rough surface of fired clay without glaze. So we also developed a strategy of glazing that works in tandem with those micro and macro surfacing to apply glaze only where we wanted to ensure that the deep valleys are unglazed, and that allows for the moss rhizoids to attach to the more conducive surfacing that we're creating with the sculpting of both these macro and micro geometries.
So the baguette components were fabricated using a KUKA KR 6900 six-axis robotic arm with a custom end effector. And so we were really looking at how we could potentially use the 6 axes of the robot. And as part of that exercise, Chris had us do something called analog robot, where you just try to really be the robot with your hand and then the traditional tools that you use in clay. And we did this to the point where we decided that for Halloween, we would be the robot, quite literally. So we end up developing a couple different iterations of the components. We had different tools that we used, and we landed on 3 tools: a scallop tool, which is the first one, the scooping tool, which is the second one, and the needle tool. And they come into play in our baguettes at different moments. So layering on the operations, as Daniel was mentioning, to get more complex. So the scallop tool is the main geometry. The scooping tool is for those deeper ridges for moss to hide out in, and then the etching is for the attachment. And so then here's an image showing the scooping tool in action, and with we ended up on the robot making 3 tiles that were intended to be component A, component B, component C.
Yeah, so just going a little bit into those compounded operations like we've talked about. Component A, again, is just really kind of a simple straight run wire cut that replicates a little bit more of the traditional die extrusions seen in a lot of terracotta baguette production. It's meant to be the most cost-effective kind of industry standard baguette that gives us the ribbed surface that blends into a little bit more of the complex geometries that we start to develop, while also allowing for a lot of the facade to be constructed with a more cost-effective production method. This surface receives a full cover of glaze for a smooth glossy finish, which intentionally promotes no moss growth so that we can more closely detail where we want to define those moss growth zones. So tile B then goes into 2 operations, where the first, again, is similarly a wire cut that starts to blend a little bit of that standard extrusion, and then blends into more of a doubly surfaced or doubly curved surface that it creates a transition zone into baguette C, but at the same time is starting to introduce some of those valleys and ridges where we want to define transitional moss growth zones. So that swarf toolpath really kind of on half of the tile creates a zone where the needle can then go in to engrave on the second toolpath. Some of those deeper valleys where you can see on the drawing on the in the middle, that moss can begin to cling to, and we apply glaze, a surface where we want to prevent glaze from attaching to, so that we can have more moss growth zones. And then finally, tile C compounds 3 operations, similar to tile B. Starts with a wire cut, but this one's a full swarth surface where it's the most bioreceptive, or where we're defining the kind of moss baguette. It requires the most processing, is intended to be used kind of more sparingly on the facade, where optimal moss growth is desired. So the scallop tool is initially used to design or to carve the primary geometry. And then secondly, in our scoop method, we use the ribbon tool that was designed to create the macro texturing, where we can carve in some of those deeper valleys that are aligned with more of the grooves that were established by the initial wire cut. And then lastly, in the engrave, where portions of that clay is being engraved to create, again, that texturing that is required for most effective water pooling and moss attachment.
This is just 3 videos that we have showing the swarfing operation for the 3 different components. So in order, component A being just a straight cut, component B being half of the swarf, and component C being a full swarf. And we had to speed up component C because it took the longest. So to keep the videos consistent, which is sort of in line with what we were talking about how component C requires the most manipulation. And then these were the 3 tiles after they were done. They've sort of been drying for over a year now, and we are still hoping to see the final results.
In terms of the glazing strategy, just a little bit of background. Ceramic glazes are commonly applied to earthenware to render the surface impermeable to liquids, thereby sealing and providing a glossy, polished finish. This glossy finish is beneficial for protecting the ceramic components from weathering, but the smooth quality of the silica in the glaze is a deterrent of moss attachment. This led to the use of more glaze in components A and B than in component C, the moss baguette. And we use wax resist, which is a barrier that prevents glaze from adhering to the deeper valleys and engravings on the baguettes. As a result, the valleys have a rougher, less refined texture that is more conducive to moss attachment, which you can see in our diagram. And then for our preliminary color studies, we originally tested 2 different glazes for our components, texture swampy and texture mossy. The tile glazes were tested in their ability to both emphasize ridges and to complement the moss growth. Texture swampy was a spectrum glaze that was selected for its dark earthen tones that create a backdrop for the moss similar to a forest environment. The ability of the glaze to shift during the firing process produces that layered green and brown hues that harmonize with the geometric contours of the components, likening the visual appearance of the baguettes with the natural environment. And those are some test tiles we did with moss. And then kind of for our next steps, this is one of our baguettes that is the type C, and that was the first images after the bisque fire, which takes all of the moisture out of it. And then second is with that wax resist in the blue applied and a glaze. And following the initial testing and visualizations, subsequent experimentation prompted a shift in the graphic approach towards a lighter toned glaze, which is the soft white, which is better suited for reflecting light. In warmer climates, the dark hues of the texture swampy would absorb excessive heat, potentially leading to the moss wilting and drying out, while the grooves in the baguette are designed to facilitate the moss to nestle. They really don't provide sufficient shade, making the moss susceptible to heat stress. In colder climates, however, the darker facade would retain enough warmth from the sun to allow the moss to sustain itself, even working as a warmer microclimate layer that alongside the baguettes would help insulate the building envelope. And ultimately, we found that the performance of the baguettes can be enhanced by simply adjusting the orientation on a building facade, as southern-facing surfaces receive direct sunlight and northern-facing surfaces are exposed to gentler, diffuse light. The strategy also negates the need to alter the color of the glaze. And the flexibility of the glazing ensures that the baguettes can function effectively across diverse environmental conditions, promoting sustainable moss growth while preserving aesthetic and functional qualities of the ceramic surface. So right now our piece is in the kiln and we have yet to see what it'll look like.
So the ceramic baguettes are 4 inches by 24 inches, and they are clay extrusions in a system. They'd be clay extrusions ranged vertically with 4 inches of airspace between each row. They're held in place by an aluminum track and clip system. And then based off of patterns in nature, the vertical orientation promotes moss growth by allowing for more water retention and opportunities down the surface of the tile. So we think that this system, we'd sort of introduce at the shaping of the clay. So we'd have those extruded baguettes, and then we'd add our sort of surface texturing to them.
Yeah, and then lastly, just our full-on our kind of design arrangement. We developed a relatively simple grasshopper script that can respond to localized climate conditions. As we've developed these tiles that are a range of 3 different degrees of moss growth from A and B to C. We developed a script that could respond to localized shading conditions and rainfall conditions. So, I think this works in tandem both with the degree of moss growth that we want on the facade, but also as some of the initial studies that we've started to develop that Molly was mentioning with glazing strategy on the amount of sunshine and shading that a surface receives based on its localized conditions. So buildings or trees kind of casting shadow on a facade. So the script we developed can start to respond to some of those conditions and assign growth zones. And so in addition, the script kind of establishes transition zones as well, ultimately assigning values from 0 being no growth zones to 1 transition zones and 2 being moss growth zones. So that starts to develop a way that we can really respond to the conditions based on a site with these A, B, and C tiles.
And then this is our last slide. This is just a render we created last fall of what it would look like potentially on a rainy day on the surface of the University of Michigan Art Museum in Ann Arbor. And yeah, this is our last slide. And again, this was a 6-week class we took, and we had a lot of fun and we learned a lot. Yeah, does anyone have any questions?
Since how we practically also a beautiful preserved and just rendering, but I can really imagine that that's a real building, and then envision that would be a beautiful building that could actual better building facade. I'm just curious about this surface. Is there any way that can relate with a kind of moss growth pattern, for example? I don't know. I don't know anything about moss, but so for now, I mean, you can take advantage of, I don't know, the density of moss or kind of like how they grow. Then actually you can kind of initiate the geometry or the puncture or the pattern made kind of, you can design the biological difference of moss growth. Then actually not just, actually that here, the shape itself is to dominate the pattern of architecture facade, but in a way, by changing the surface shape, and the surface shape actually then differently grow the moss, their densities or patterns, or then actually you can actually control the outlook of moss by doing so. You can do more kind of deeper side of, I don't know, the kind of like nature artifacts, kind of composite structure. Have you ever studied about the moss growth and how does it work with the geometry of your system?
I think the moss growth, from what we've found, it branches out as it grows. So when we were deciding on the geometry, I don't think we really, and maybe that's something I think in like the application of the script, we could have it be more branching. But the moss, we're not sure is entirely as controllable as the water retention is. And so that's why we're sort of having that almost trickling geometry in order to control the moss zones that way.
I think also the glazing does help control where the moss growth is, but
for example, so your students actually you intentionally design it vertical way. So this kind of path to go. I kind of thought that you could have a horizontal weaving that actually may have more water on it. By therefore, that closely growing was make more kind of like and offer some more nutrients or water for growing more longer time or bigger months.
That makes sense. That's a good comment, actually, yeah, about having it horizontal so the water can kind of be in that. And even too, in that second study that we were talking about, the first one, they just left it outside, but the second one, they grew it horizontally before they then tipped the vertical panels upright.
I would also say, just based on kind of that comment that I've heard, I would love to study these almost as like a louver system where we're treating these on like south-facing facades and how they might both shade themselves, but also be more conducive to like actual pooling of water, like as them being horizontal. Yeah, I think just another level that I think we could look into.
So another question would be, I think that the digital variables right now, it feels like they were mostly wet subtraction of clay. But I wonder whether additive processes, both in the clay and the glaze, and even in the positive biomaterial for moss, could also be considered in the process. And even within the clay itself, one thing that is afforded by handwork, but it's certainly afforded by machine work, is whether you're working with clay through deformation, wet subtraction, or dry subtraction. And so for me, this is actually like it's a footnote for a 6-week course that's the beginning of a larger question. And that all of those variables want to be optimized and find truly most productive as well.
Thank you.
I have a really lovely honor to introduce our dear host and colleague and friend, Spencer. Spencer has made this fundamentally possible with his very, very direct material support as well as his vision. Our Spencer Steenblick is an assistant professor at the Eskenazi School of Art and Architecture and Design and a registered architecture in New York. He's built and taught and published and exhibited and curated globally. His work negotiates vernacular and advanced digital processes through an equitable, interdisciplinary, sustainable, naturally inspired approach, creating urban intricacy and inspiring interactive spaces. His practice, Phi Architecture, include clients such as Google, YE Space, Venture Anyway, BYU, and the Fictionist Band. I want to know more about the Fictionist Band. And it focuses on designing across scales. He holds a master's from Southern California Institute of Architecture. I first met Spencer at an extraordinary event on architecture and neuroscience at Pratt. And we immediately found ourselves in just deep conversation. This is an individual who has truly extraordinary depth and range and generosity. And I can't wait to hear your talk. Thank you.
Okay, well, Phillip, thank you so much for the very generous introduction. And it's been a pleasure to host everyone here today, this week. Thank you so much for coming from all around the world. It's been a real honor and a privilege to be able to gather all of these people together in one place and to be able to talk about something that I feel like is so fundamentally important. This research began in a very playful place, designing a children's toy. And so the title of our paper this time is called Exploring Structural Joint Systems Using Dimensional Lumber for Lightweight Structures. The research began with inspirations. And so here's some of those inspirations. We have Conrad Weichmann, who's kind of the godfather of the systems that we have become so familiar with in the space frame. And then we have, of course, Frey Otto and Buckminster Fuller and Snelson in his tensegrity work. And then, of course, more close to me is the work of Alexis Roche from SciArc. And when I was there, he presented this work in a conversation with Eric Owen Moss. And that was actually fundamental to my own sensibilities. And some of this work is actually responding in an inverse way, or trying to respond to that in a way that moves away from what he was focused on. He was creating these joints that were inherently dynamic, so that you could have a lot of range of motion in terms of what was possible with the joint itself. But it required that the joint was then inherently weak due to that flexibility. So I'm looking for a sweet spot in terms of joint design. And specifically, I'm categorizing these into two different types of joints. Standardized joints, which is the kind of 20th century industrialization model, which you see, say, in a Pei building, right, where he's got this, like in Javits Center in New York, where it's just this kind of sea of continuation of space frame systems. And then on the other side, we see something more like the 21st century model of mass customization of joint systems, where you have every joint is unique, every strut length is unique, and each one is either welded or has a unique hardware configuration, which even with digital fabrication methods drives the cost up and the time for fabrication up quite extensively. And so we're looking for that diamond sweet spot in the middle, right, where we can capture many of the benefits of the standardized joint, while at the same time allowing for as much formal flexibility as possible. So we quickly took a molecular turn, as I like to describe it, thinking about molecular geometries. So here you can see some of the main configurations of carbon. And so we selected carbon for its important attributes, flexibility. It's a non-orthogonal geometric form, meaning that the main system through it, the main geometric configuration of carbon has kind of an odd angle, 109.47 degrees in one direction, and then 70, etc. And so that's an important thing, because it means that being non-standard, it's not orthogonal and therefore not intuitive for our minds to kind of conceive of. And therefore, that's, I believe, one of the reasons why it hasn't been extensively exploited. And so you can see we have like graphene and graphite there on the top. We have diamond patterns there also on the top. And then we have these ball configurations, which are quite interesting. And then carbon nanotube, and then amorphous carbon on the bottom left. And the thing is that you find carbon everywhere. It's ubiquitous. It's hard to get away from carbon. And the reason why is because it is so diverse and versatile, and at the same time has strength properties, which makes it really wonderful. So here we can see some of the early joints and the configuration that carbon normally comes in. It's a tetrahedral form, so meaning four sides in a triangular prism formation. And we were able to develop some fairly interesting configurations and installations with this system early on, but we quickly decided that we could amplify its capability by extending the strut all the way through, extending the joint all the way through and allowing for a duplication or an inverse. They call it a tribrachidium form, and so we made it a double tribrachidium form, increasing it from 4 strut potentials to 8 strut potentials. I'm kind of cruising through this because this is all background research. So here you can see some of those the main iterations, and you can see on the top row we took that molecular turn early on. In the middle row, we're dealing with how to deal with that tetrahedral form, and we move away from that tetrahedral form with this flat pack joint, the first of the metal flat pack joints we designed, due to the apparent flaws in in allowing for some of the strut connections to be shorter than others. And so we moved towards this composite design, which is dealing with a 3D printed aluminum exoskeleton with a standardized industrial tube aluminum on the inside for rigidity. And then you have the struts that kind of sit inside of those. So it's this multi-layered composite approach using the same material, but different fabrication methods to accomplish that. And we found that we had a threefold increase in structural stability with a decrease in material usage from like a standardized design methodology moving towards the exoskeleton design sensibility. We have our friends at Purdue to thank for the analysis work on that. So thank you for Dr. Tovar. And so here you can see that diamond configuration. It's essentially what we'll talk about in a second as 3 chair configurations. And a chair in chemistry is a very specific 6-sided figure, which creates the lattice, which becomes graphene, right? And so let me see, sorry. Yeah, so we really wanted to push the potentials of this system. And so here you can see a tensegrity configuration where you have the 3 individual panels that are holding each other in tension and compression simultaneously. A lot of potential here with our joint mechanisms that we haven't really been able to explore at the larger scale yet, but we're really interested in taking it there. In addition to that, you can see here some of the latest installations. This was in Oaxaca, Mexico, last fall, where we're again using only that small scale, but we're able to kind of have a real range of diversity of forms with this one standardized joint. It's very, very, very exciting. And on the left, on the far right, you can see the stainless steel 3D printed joint combined with wood, and I think that's a really nice pairing. The wood is a micro bamboo strut, and then we have in the middle we're using fiberglass. So it's been fun to kind of play with a range of materials with these in the struts and in the joints themselves. Another thing that was really important to us was thinking about cladding, and so we did some early studies. Here's another installation in China at Zhe Art Museum. It's an outdoor installation where we did a collaboration with a sound and lighting designer or sound and lighting artist to do some projection mapping. But the thing that was so important about this structure was that it was kind of the quintessential structure in terms of both weight and strength, where if you were to add any more material or take any material away, and it would be either superfluous or it would completely collapse. And to me, that was a really important moment, because then from there, I can kind of understand how to add those margins of error, right, that you need in traditional construction methods. And this was just a really beautiful, just sensitive structure, right? It was beautiful, and it worked in nature. Like it was fully functional in its environment. So we've done installations here. This one is interesting because we're starting to think about insulative properties of cladding materials, which is really important. So this is a coated aluminum coated material that they often use for space applications. And then also we're thinking about ETFE and the potentials of that. So we've been starting to work with the design of the details for ETFE cladding, and you can see here's other opportunities for locomotion. This is a solar following sun solar panel, and then here you can see other forms of locomotion available within this strut configuration, where we're using a linear actuator, as Johan had mentioned, to create these kind of different forms, which I think has a lot of potential. We haven't fully explored these things, but we've at least tapped into the potentials of them. We took a pause with this project, with the Carbon Natural project, because we felt like it was really important to scale up and to try things at a larger scale. But we needed to be able to kind of ramp up to that. So we took a pause and started doing a collaboration with another local artist here in Columbus, Indiana, Jonathan Neshi. And he had a number of interests in different types of joint designs for different applications. And it was an opportunity for us to try the bigger scale without pursuing it within our Carbon Natural project. So this one's a fluted joint where we're really expressing the structural the structural lines that are happening of the force line vectors. Beautiful joint, we felt like, and it was an interesting one because it was really focused on the balance between aesthetic and performance. I think most of our work is that way, but this one was more focused on maybe aesthetic in that way. And just going to actually pass the mic now to my two colleagues, Jonathan Hill and Ali Reza. And these two gentlemen have been really instrumental in pushing this research further. We're calling these the key joints, and Jonathan's going to talk about these. This is a continuation of the Jonathan Neshi project. Am I going to talk about these, or you got it?
No,
you got it. Okay, great.
Thank you. So I would say that this collaboration with this project is honestly our progression to our research, which is the xyloid. Through this form and this key lock system, we were able to explore more or less an organic form that reduced the material that was, coming from the previous carbon natural joints, as well as explore with additive manufacturing a sense of efficiency in creating these joints. Though we moved to more or less with additive manufacturing, but also changing our focus more or less to a flat pack system at this 2D form that is then extruded, one, because of the benefits with the benefits of efficiency and time, but also to allow for quicker iterations. You can see here towards the bottom, there's this tooth, and this tooth then slides into this form that then locks in up here in order for that connection to occur. These teeth are then pressure fitted into an EMT conduit. And as you can see here is where it's then put together. Through this process, we were able to focus on lots of different materials, things that we were able to take away and learn in order to progress our methodology. So on the left, you can see here where we started to plasma cut into an aluminum sheet that is 1/4 inch, as well as using the lost wax process. The problem with the lost wax process is that due to cost, we felt that it wasn't going towards more or less the accessibility goal that we had in mind, as well as we had technical difficulties due to the humidity within the building, and therefore we had lots of failures in these prints. And here you can see some of the iterations that we were exploring. But with this, there's the key ring that we were then exploring different scales, as you can see here, that was more or less larger or also more tighter. And that was creating deformities within the project when we were to put these two together and actually start to test these on site. And so here you can see where we're starting to pressure fit this into that EMT conduit, creating that deformity due to the tolerances. When we were testing these more or less on site, and we were able to explore, different potentials of sculptural form for these pavilions, but as well as with the flexibility of the key joint, we were able to move around the pipes and, in order to have those different sculptural forms. As we zoom in, we see how this compression connection is starting to happen, and these keys are starting to rely on each other. That's where the deformity started to come into place. As we can see, as what started to happen as we continue to test these, that the key ring started to bend and create those failures. So we started looking at different materials and different methods. And so we were looking more or less at a carbon printing, and it's a continuous carbon strand that runs through the key ring and through the entire system. And so we were able to collaborate with a local print company. And so we were able to get these in, but again, once this process, due to cost, was not accessible or able to get, at a fast process for us. Another project that we collaborated with Jonathan Neshi, we call this the click lock system. And this was a larger scale, a 3-inch aluminum pipe that then can be rotated and flexible in order to then create different sculptural forms as well. These nodes were one-offs, and that's one of the things that we were having trouble with due to cost and trying to create these lost wax process and having to, in order to have different nodes. And so the way that this works is that this click lock system here, which is flat pack as well for that efficiency, will then enter into this node and take an inspiration from a zip tie, will then create that tension connection, but as well as being pressure fitted into the pipe as you see here. And so we went through multiple iterations and how this system is going to work. We even thought about where the initial connection is more or less a separate component, and then having another one where that connection is created, but also having something that is more linear. And so here on the left, we're working at a smaller scale for the additive manufacturing process that is then inserted into this voided cylinder form, but then upscaling this piece more or less to the one-to-one component that we had, but then translating that to that aluminum plasma cut process. On the left here, you can see where that node is then connected to that click lock system and then is inserted into that pressure fit aluminum pipe. And this project then took that halt because we realized that the efficiency of this, the cost, and also we more or less wanted to focus on more sustainable applications for this process.
So yeah, based on the things that Jonathan mentioned and the problem and challenges that we have with the previous configurations, we decided to move to another kind of material. And as you see here, we have this joint with the ordinary plywood. It's the first iteration of making these joints and structure in this way. And so we had some problems and we tried to fix it time to time after each iteration that we made. So here you can see our first iteration and how the joints worked with the struts. And so we had plenty of problems here. One of them was the proportion was kind of somehow odd. I mean, the scale of the struts compared to the scale of the joints was somehow out of the scale. And we realized that as we have most of the tension and pressure and all of the loads on the joints, we realized that we have a heavy structure with somehow weak joints. So we decided to make other iterations to see how we can deal with this problem. Here you can see the exploded diagrams of that. This one is the first iteration. So we realized that we need some locking mechanism as well as changing the proportions. So this is a locking mechanism that comes in and somehow make the joint more stable. That you can see all of them in the gallery as well after presentation. And here is the joints that we made, and this one kind of worked for us. We still had some other problems that we had to deal with, but this joint was the things that make a structure for us, and we could play with the structure, and we could see what is the actual how a structure work in the actual world for us. And here is the way that it connected to the struts, and you can see how easily it can connect to the struts, and it makes lots of potential for us. It makes the whole process really easy, and it was some of the main goals to make the structure that people can easily make it and assemble it. And these are the things. So this one, as Spencer mentioned about the chair configuration in the carbon molecular inspired structure and joints, we tried to make three carbon molecular chair next together in actual work to see how we should deal with the problems that we have in the structure. Here you can see, so as you see here, we have the first iteration that had lots of failure points, but we have other strut sizing and scaling. In this one, we had 1x2 the struts connected to the joints, and then 1x4 the struts connected to the joints. And we kind of felt really confident about all of those scales, and we could just continue to make this structure. This is one of the analyzers that we had after our first iteration in the structure. So we realized that actually somehow it was a bit difficult before making the physical structure to see how we can understand what part is under tension, what part is under pressure, what part is under tension and pressure simultaneously. But after we make the physical structure here in this building, we realize that there is some joints that under tension, some of them under pressure, under both ways as well. So this analyzer really helped us to see how we can deal with the other iterations and how we can continue to make the iterations to make the structure more stable. But after all of these, we had another problem. The other problem that we had, the other technical problem that we had is this one. Actually, the structure is supposed to be like the things that we have in the gray color, but the things that we observed at that time was something a bit different. And we saw that there is some failure, that structure doesn't work that is so in the way that it's supposed to be. And we named that problem, that challenge butterfly effect, that you can see how it kind of broke some legs of the structure. And this part, although it was a really challenging problem for us, but we learned lots of things through this process. And fortunately, we could fix that by add some other things that I will show you in the slide. So here is the other iteration that we are making right now. We tested somehow, but not complete yet. And in this part, we tried to add some reinforcement components to the joint, because we realized that this deforming happened because of the lack of tensional element, probably. And also in the other iteration that we tried to maintain the whole material in just wood, not using the other things, we tried to kind of make the failure part a bit thicker to see if we can if we can control that problem with this thickness. So we are still in the process, and it is going on. And I don't know, in future we'll see what will happen in all of these things. And here you can see, here and also in the gallery as well, you can see the last iteration that we made to fix the butterfly effect. And also, we have this goal as well to continue to make all of these joints all of these wooden joints in other configuration more than the chair. And so this one is a Larimer configuration that Spencer proposed in one of the exhibitions that he had. And as you see, one of the kind of opportunity that we have with these kind of joints is that it's kind of organic. It knows how to generate itself. By itself, it proposes other forms because, you know, it has all of these 8 legs that they can connect together. And even in the chemistry, we can see all of these forms as well. But this joint is as I said, proposing other forms. And one of the other forms that we are trying to make and test is this one, which is Larimer configuration. And also here you can see the common carbon molecular forms that we have in the nature, and scientists trying to analyze that. That is chair, half chair, boat, and other stuff that we are trying to use all of them and see how we can deal with them, the structure. That I think Jonathan will talk about it, about the case study that we are working on right now and how we are using these things to see what will happen.
So we have a quick case study that we're going to show you. This is actually for Exhibit Columbus, which is happening this summer. And so we've been tasked with helping the high school design team to develop their proposal. So last fall, I was working in the high schools 2 days a week, helping them develop proposals. And then we took the work that we did with them and then developed that into this proposal. And so here you can see kind of a scale model of that proposal. So we're calling it valence, thinking about the valence bonds of chemistry, and thinking about that in as many ways as possible. You know, a multiple definitions of the same term. So we're doing it here at the Republic Building. As you drive by, you'll be able to see it on 2nd Street. It's going to be something that becomes somewhat of a billboard, an architectural billboard for Columbus, Indiana. It's kind of an LA concept, I guess, a little bit, now that I think about it. But so you can think about all of these different precedents that I brought to the high school students, thinking about the use of material and accessibility of material, as well as form. We really loved these wood block blankets, which are pretty amazing. You'll have to look those up if you haven't seen those before. Very organic and dynamic forms. And so we had quite a few precedents we were interested in. Of course, Levis Woods and some of my mentors. This is a project from Exhibit Columbus from Euler Wu Collaborative here, and who's a professor of mine. They did a lot of really wonderful work with this project. Some of my colleagues worked on this Euler Wu project, which is the Muhammad Ali sculpture memorial. And the thing that's interesting about it is that that it is icon, but it is also tectonic, and the combination of the tectonic and the icon is actually quite interesting. And the tectonic is in some ways more important than the icon, or maybe is louder than the icon. And there's something that we liked about that, or like the idea of the icon being subdued by the structure. And then of course this idea of moving from wall to ground treatment and canopy. Those are things we were all thinking about, or this transition, and thinking about ways in which you can program that transition. And then of course this idea of the wood slat and creating the warmth, and also creating surface, an implied surface as well. Those were all things we were thinking about. This was kind of a fundamental sketch that I would share with the high school students as we were moving through the process and thinking about program, thinking about elements of play, thinking about all those things, all very important. And then we got to do some full scale testing with the high school students, which is just amazing, really, really fun to have them be able to play with the material and get their hands dirty. So we went through a number of these iterations, and I'll let Jonathan finish. We're almost done.
So using what was originally the Exhibit Columbus logo, we took a piece of that. We abstracted it in order to create this composition that you can see here at the top left. We had wood slats that created the canopy system that then connected to the wall. And we were going to apply colors to those using that composition. We ended up moving more or less towards these cables in order to, because of the heaviness of the struts. And as you can see here, this is some more of the models here, and more or less their positioning and how they can create almost like this event space or the stage, as well as the seating for the people oncoming. And then these are more or less some of the views where this starts to act as that billboard, trying to invite people to these three pavilions as they talk to each other, allowing people to have conversation. We are also using a tube that runs underneath these pavilions in order for to add a sense of play for the public and the community. And then this can be seen here from the sidewalk in front of the Republic here, and start to really activate this space. But again, a sense of play for the community. And so we explored multiple iterations as far as how we're going to orient these three pavilions together. We explored arranging them just linearly along the Republic, but we felt like there was some sort of disconnection in that arrangement. And so we wanted this to be more or less, really evoking a conversation within these components. And then this is zoomed in. So these are one of the views here. And so I will say, why is this important? So the progression towards the xylo, it's important because we were able to have takeaways from that, from the flat pack system that was then used for the wood joint named xylo, as well as moving towards a wood system that can easily be CNC cut, as well as create that accessibility, off the shelf material with dimensional rubber, and then as well as sustainability and ease of construction. Thank you.
Thanks so much, colleagues. Questions?
I love joints. It's amazing work you guys are doing. I love the iterations, especially with like the complexity of the laser cut joints and kind of getting to a point where you're like, okay, let's back up and try again. But I'm curious to know, have you gone through and looked at a lot of questions going back to like the space frame, like the data center, those sorts of things? Like we've been experimenting with joints for a really long time. If so, what are some of those joints you've looked at that have been really inspirational?
I answered that question at the beginning of the presentation. We talked about Conrad Weichman and then also Fry Otto and like Snelson and Fuller, and then also a more contemporary example of Alexis Roche. So we looked at a lot of different joints, and you can you can look, there are many joints that have been designed and they're continuing to be designed. And I think that it's important to be able to think about things from a first principle standpoint. And that's where we really wanted to be. And we're different because of our molecular underpinnings, which has led to the patent that we're working on currently. And so that's where we're at with that.
Thank you for the presentation. That was great. I'm curious, and this is kind of for all of you guys, but the way that you framed it, starting from what I imagine was a few years ago, like, do you guys see this as sort of a culmination, or is this, and maybe talking about the patent a little more, like answer this as well, but is this installation sort of a culmination, or is this kind of the beginning into a new sort of technology that you guys are envisioning?
So I would say that there is lots of potential that we all can feel that about all of the potential that these joints and this structure will have. And so this exhibition is somehow one case study for us to see. I would say it is for the wooden joints and wooden structure and sustainable structure. It is our first 1x1 scale structure that we're gonna make, and we want to see how it deals with all of the problems that it probably have. But definitely there is lots of things that I think Spencer has lots of idea about how to push this out of the boundaries of the not just structure, how it can be, I don't know, community things or even something else. And also as we were talking about, we want to make it somehow the process of the making the structure somehow easy. And we want to push this and see how we can make it really accessible for everyone. That probably in the future it's some other project.
Just to add to that, I think that stick framing construction has been the standard in the United States for too long, and I think it's important that we move past it in a way that allows for non-rectilinear forms and being able to utilize the exact same materials that are that, but in ways that are non-standard forms. I think is an important thing, even if it is playful and not necessarily practical yet. I think that we're inching towards that in some sort of way. One of the ideas we've thought about is scaling up one more time and using TJIs, which are the floor joists that are often used in houses, and thinking about it at an even larger scale. At some point, the scale becomes unwieldy, and there needs to be a sweet spot in terms of scale of joint and node versus scale of structure. And you have to find the programmatic and other considerations that work best at those different scales. That's important.
It's kind of a common theme I've been talking about today, and I'm saying it's really nice to see casting, aggregation, compositing, these different methods of making the intersection. I can think of two more that I don't think that I saw, but I saw lots, so I'm missing my thought of it. One is actually, instead of using pre-engineered wood for joining, actually engineering your own wood. So what would it be like to take 3 layers of wood and laminate them together? Less block reduction. Maybe no need for CNC in a jam. One example. The other one would be to imagine forming, even if it's plywood. So again, trying to joint is being reused over and over again. So it affords after the prototype, they don't have a problem. It's the joint itself. Right? But I really like seeing 2x4s in that way.
Thanks. I really like thinking about this work almost like Malovich, who did the white on white stuff, and so that's where I'm at right now. It's like we haven't introduced bending, we haven't introduced a secondary configuration of carbon, because there are 3 configurations of carbon. So, and which includes a rectilinear one. So once you start to kind of branch into the combination of the metals, which is a rectilinear form in chemistry, and the non-rectilinear other carbon form, it kind of blows up in terms of potential. And so we're really just kind of like trying to be as simplistically rigorous as possible right now, but it still explodes, and we have a hard time like focusing a little bit.
In leadership
amazing presentation, and I cannot wait to see the final sunlight in the summer. I just have a minor suggestion for Jonathan's detailed study. So it looks like it is based on a friction-based locking system. But if you take a look at I'm not sure Spencer made about it, but in Japan, there are a lot of high-level wood joint system are so clever design. One is actually Sashimono. Sashimono is actually everything but smoothly connected. But once it is locked, then it's a three-dimensional locking system. So there's no such a thing like friction or hard friction inside. Everything is go so smoothly, but you have a very clever locking system. Something one element Shinyan, one element Shika. So when it is flat, it's called Tsugi, or when it is bended, it's called Shiguchi. So just take a look at it a little bit. Just invest in your 5 minutes and you can learn a lot of creative design. And then for Spencer, I don't know if this one will help you or maybe to you in another research help. And there's that's me. There's another really interesting research going on called graphene. I don't know whether graphene is two-dimensional structure or carbon fiber structure. I don't know why, but graphene is like 10 times stronger than the carbon fiber structure. It is accidentally developed that one scientist using Scotch tape to peel off the carbon fiber structure. And it's really kind of hot area in physics. So you may want to do another theoretical level and utilizing graphene structure, something else. So I wish that it will be helpful.
Yeah, so the molecular chair configuration is a graphene configuration, actually, then actually the use of graphene is not quite there yet in terms of scale. They're still able to only do it at quite small scales, but yeah. Thank you.
Yeah, I think that's an interesting comment, and I'll definitely take a look at that. I think one of the main things that I was just focusing on when exploring all these different materials and these different scales is more or less just something that is clearly just efficient, something that is just so quick that we can move fast and create multiple iterations, but at the same time allow it to just be really easily assembled. And so I think I definitely will take a look at that. So just thank you.
Is it purely friction, or my understanding is these like angles or like these little hooks, like it's not a friction joint per se, or is it?
Partially is, so that with the different materials we were exploring, a bunch of different tolerances, from the aluminum to wood to just the additive manufacturing process. And so we had to adjust those tolerances. And so it is friction, but at the same time, we did add that tooth that you saw earlier in the additive manufacturing process to really just create more or less a better performance and stability for that joint that's connected.
Okay, I'm sorry I came in a little bit late. We're in the workshop, but I think for me, there's like this question about what seems like people working on the first joint, which is sort of more of a dynamic joint that could adapt to any situation. If you just create, say, an organic shell and type it, and you have all of these dynamic sort of joints at various angles coming together, you would be able to treatment those. But the system you're developing is based on molecular structures and is constrained around particular angles, or does it allow for maximum flexibility? And so can you speak a little bit about the constraints that you're putting on these, whether or not it wants to have sort of like infinite adjustability in terms of angles, or are we constrained into this molecular? And if you are constrained, why are you doing it?
Yeah, so we talked a little about this. It's based on carbon molecular geometries. So that's what we're right here. So this scale like that. We haven't really explored the potential for dynamism within the wood joint yet. Something where we want to try. But yeah, so there is potential at the smaller scales for dynamic interactions in the system that we haven't been able to test out much.
Seems like you have the ability to rotate in one direction.
Yeah, it's struct rotation. And then it's highly economic configuration. I don't have the slide in here, but basically carbon can combine in 3, 4, 5, 6, 7, 8, 10 joint connections for one single connection. And so depending on whether you can set up a 4-sided joint combination, which creates kind of a diamond. That one's quite popular, the one I showed on the video. The one they're actuated. The 3 is static. The 5 is has a tension dynamic. The 6 is not. It's one of the strongest ones known to man. 7, it goes up, and each one has its different configuration.
Yeah.
You're good.
Wonder if I can just make one quick comment before we take a break, which is one of the extraordinary qualities of a compact, intensely concentrated quality of this is that it serves as a kind of important for the future. And I think that we can see that in very practical ways when we see a prediction of the framing of public space in the coming months and years in this work, which is what makes the publication of it all the more significant as well. And we know that that's done as well. We're very, very grateful. Way structured, so beautifully documented, and that sense of us participating together in that. I was very struck by how the work both allows a kind of a differentiated, almost wild immersion in some orientations, and then very, very specific colonization, approaching crystalline in others. And that kind of spectrum in this particular system seems to have an extraordinary qualities of wilderness and public space, rather than the kind of rather dreadful polarization between wilderness or ordered city that we've seen in our classical traditions. It's incredible concepts. They were very, very generous. It's very, very generous. That's what we should have done.
That's what the works. The rest of my life after my first grade.
So it's a pleasure to be able to host Phillip Beesley here. I hosted him at Pratt, and then I've heard him speak at many other venues. But it's really great to have him here locally here at IU, especially with the fact that he has sculpture as well as Money Center, and so he's already a friend of IU. It's wonderful. Every time I hear him, I feel like I need to be taking notes extensively. And still, 60% of it goes over my head. So hopefully, you're all in good company in that regard. But anyway, so I hope to be inspired by the work, and I think that his work embodies a lot of the sensibilities and inquiry that's been expressed throughout the conference, and something that we all can aspire towards. So without any further ado, please welcome Phillip Beesley.
Thank you so much, Spencer. Toward the design of metastable architecture. I'm going to try to share an old word for space and a new word, replacing perhaps the word for power. Some alternatives I think we need. And I'm going to try to use that to break one of the fundamental laws that underlies this. One of the laws that defines the stasis, the immutable, eternal idea that has defined architecture. So this will be in 5 parts. I'm going to be speaking for a little less than an hour. I hope that's okay if I take that long. I'll go over some very, very basic terms to start rather rapidly. And then I'm going to do skipping through a survey of work over the past 30 years or so to speak about an evolution. And I'll try to use those 2 things to set up some meditations on physics that we take for granted, and physics perhaps that we don't have to take for granted, that can enable us. And rather popular term, material agency, which has been something that's underlying so many of these extraordinary presentations, the sense that we not only manipulate, but we can also be steered by and be embodied by. And I'll try to capture something of a rather precarious hinge I'm rather clumsily calling anagenate. In other words, agency, but the hinge with the A in front of it. It means that something is taken as well as pushes, as well as shares in a precarious state. Because otherwise there's a kind of a determinism and a rather dreadful sense of being controlled in a Darwinian sense of the word. And I hope that that will be helpful as a way of taking a rather closer look at 3 projects, including some material that I haven't shared before in a project, ARIA, that has just been built now. Space, boundary, power. I wonder whether you have an emotional relationship to those words today, now. I wonder whether your feelings have changed in this past decade or 2 decades. When I hear the word space, it's almost impossible to unhear the word domain. When I hear the word boundary, it's almost impossible not to acknowledge that embedded in that word, such a very simple word, my edges, your edges, that there is claim. When I heard the word, I think in a clear-eyed way, it makes sense to acknowledge that the word embedded today carries dominance. May I make this talk an attempt to offer some alternate terms, not naive enough to replace them in a binary sense, but certainly to complement. A much older word for space, a word that even Einstein used, is ether. Literally, in his work, in balancing, at the turn of the century, 100 years ago, 125 years ago, he used the word ether, a medieval sense, that space is not empty and void, but rather full of presence. When I hear the word boundary and claim, may I also feel my own membrane, our skins, a sense of vulnerability, of sensibility, of culpability, of responsibility, of sensitivity, a living thing. When I hear the word power, may I also think of potential. And the terms that I'm using then offer some rather fundamental paradigms that suggest that architecture, which Dora has so beautifully renewed in her comments, might also be a discipline in which it's time to say living, not as a claim, not even as a metaphor, although metaphors are completely enabling, but as an effective, appropriate, and necessary way to understand that in making architecture, we body forth the world, and the world embodies us, and that responsibility must be a continuing, vital quality. The terms of reference, therefore, for taking care of life, the stewardship of life, I would suggest now we are ready to take on and fold into the practice of architecture, quite explicitly, quite literally. We're at the dawn of being able to engineer living systems, living dynamics, quite explicitly within architecture. The arc of the West and the East altogether over thousands of years has been aspiring to this quality. And it's with us. It's time. When I stand with you, I immediately, when I use that word, living, I reflect on who I am as a fundamental unit, culpable, responsible unit who's trying to make a contribution. And I reflect on what I've been taught about how to craft architecture. The space around us, perhaps a space that carries an optimum, even a perfection, the maximum optimal use of materials, the balance, the kind of optima of equilibrium held up as the source of peace, the necessary ambit around the polis, our sanctuary, as if when we make architecture, it is the herbs, the sanctuary, the inner sanctum, the place. That is what we are finding and doing and sharing. And yet, when I speak that way, that I am an individual and that my architecture is an envelope and a shell which is optimized and responsible, then I can't say that I actually feel those things or know those things. Who am I? And what am I? What is my experience? What is my consciousness? What are the tactile sensations and the myriad of phenomena that are flowing through me that say that I am this upright columnar figure who is bounded and who can make this optimal shell, which is architecture? I confess a kind of delicious vertigo sometimes when I say those things. There's the sense that I am a myriad mongrel of different bubbling, partial consciousnesses. And I can also confess a kind of a grotesque, dizzy nausea in the sense of irresponsibility, sense of in a dream that delight can happen and also nightmares can happen. This then is quite honestly a precarious state that I find myself in. And I wonder whether any of you find yourselves in that too, when we try to take responsibility as professionals in our discipline, and when we start with our own sense of integrity, and we use that to template out our system of values, to colonize and to empower and to shape the built environment. So this sense of integrity is important, therefore. I feel an obligation to somehow locate myself and to work honestly. And yet I feel so very uncertain. I will say that amongst that deeply precarious range of vertigos, from being dizzy to being hopeful, that a chorus glimmering does emerge. The sense that we can share, the sense that what we do articulates and emplaces, that it coheres, that it harmonizes, that it includes, that it works. And I hope that this talk will serve to offer some rather practical strategies for achieving that rather hesitant optimism at this rather particular time. I'm going to skip through just a few projects. I've been speaking, invoking a kind of wilderness. This is a rather old project that perhaps embodies that sense. A very recent one that I'm going to be sharing a little bit more, called Aria, is we're looking up at a very large canopy about the size of our gathering. We made rather carefully out of it in individual parts. I'll speak about the fabrication of it as well. And here's just a bit of a taste of how it works. with a sense that a touch and intimacy is at the heart of this work, very deliberately making components precarious and oscillating and sensitive. They're touch sensitive, they carry sensations as well. So that's a taste of current work, and I'll try to give some terminology for that as we go along with some craft. But what I'm going to do right now is I'm just going to skip through a range of projects without explaining them too much, just to give a sense of building up of a vocabulary of this architecture, starting about 25 or 30 years ago with a sensibility that was very much oriented to the exterior, to landscape, to healing, to making geotextiles, to renewing the earth in rather simple ways. And then moving through the wilderness that I just invoked into a state of a rather optimistic kind of symphony. About 15 years ago, this is the Venice Biennale project for Canada, which is at the very beginning of the terminology. Well, it was a few years after using the terminology digital tectonics, and after having practiced for about a decade using digital fabrication, after having worked with manual craft and architecture in the preceding decades. And so this was a particular point when things started to cohere and started to qualify themselves as making kind of a public symphonic work. And in the subsequent years then, for example, in Korea, this started to move into a rather deliberate way of making tectonics, stretched columnar forms, groves, rooms, striations in which the same figures in their open work nature could be studied full of computational systems using distributed microcontrollers and seeking a kind of an emergent chorusing quality of a deeply, deeply responsive architectural system. And sometimes those would roll back on themselves and make cellular nests. And those in turn started to have some bursting, rather intensely kind of chorusing qualities. And those have turned a bit more recently into really quite strong cellular structures that can take on shell-like systems as well. And so where the rhetoric in earlier days was really very much against the shell and seeking an immersion and taking for granted the wall and the cave and seeing those more as caverns and as interfering boundaries, like as if it was my parents that I could take for granted, seeking the wilderness instead. Now I'm much, much more hesitant to take anything for granted. And so making a cave, making something where I try to make myself feel safe, as well as making it open and embracing the surroundings, is very, very much of a kind of a dual, more than binary operation, trying to achieve a spectrum of enclosures and embraces. For the Venice project, a second Venice project, which happened during COVID, it was a rather cruel situation because we've been working for a couple of years that deeply, deeply enabled physical fulfilled work with a lot of help in the Arsenale. And then I found myself forbidden to travel by my well-meaning institution. Deeply resented that, but I cooperated. And so we learned to make a digital twin of the work and then transposed it completely into a displaced form where I never saw it in the flesh. But what we did instead was we created a film cradle, which would then project it in an immersive form in the floor. And I'll share a short version of that later on in this talk. It's a rather emotional work, so I'll give some more optimistic work first. That then translated after COVID lifted into some new chorusing work, which really was quite embodied and quite intensely saturated. A lovely project, Meander, which filled an event space in Cambridge, Ontario, and some other projects in France, where you can see a kind of a growing confidence in a kind of a saturation, an intensity, and a fertility which approaches eutrophy, which approaches a kind of a flatlining, but which does not get stuck in it. And the way it has avoided that kind of swamp-like condition is by working with very, very deep investment in harmonic scalar systems so that you can have individual points of concentration which will then pop across to the next one rather than simply entangling themselves and stalling. So that they're very, very lively and they can scale quite effectively through multiple intimacies. These are jewelry scale that we're looking at right now. This is an installation in the San Jose airport. And then moving even in a more intimate state into a series of performances such as the Super Bloom project, which was really celebrating a deep community in Toronto. Or perhaps some things which you may have seen in global media, such as a long collaboration now with a dear friend, Iris van Herpen. Here's just a little taste of that work. This rather flowing organza hexagonal honeycomb work, which is deeply layered, and or for example this which is a minutely controlled laser cut polyester, where by having opposing slits and then by displacing those in 2 dimensions and then by stretching it, you get a really lovely kind of effect of 3-dimensional rolling. This was originally a kind of inspiration by Fortuny, the Venetian designer, and so it was really an exploration of pleating and then voided 3-dimensional pleating. But then it turned into a curvilinear system as well, where we've tended to stay. And you can see some of the effects of that when it works in interaction with a moving body. I really am very, very fond of the kind of gently oscillating, rolling expansion of an individual physiology when we walk like this. I've been rather happy about how that fabric has had several cycles too, and it's been worn by some people that you might recognize in an extraordinary celebration. It's very, very interesting then to work with tectonics that continue to be used and shared in this way. I hope that you can see some of the intentions behind these fabric structures as a kind of a radically personal architecture of expounding an individual body, inhabiting a possibility space, and moving in the same kind of intimate way that we might feel when we are in bed, perhaps, or swaddled, or the way us as children, as tiny babies, would have been wrapped and almost coterminous with the bodies of our mothers. Those kind of sensations are ones that I do hope some of these fabrics offer. I think, as you can tell, the fundamental building block of many of these works is a very specific kind of intimate, rather gentle, open touch in which our own sensations and the way the vibrating, oscillating, rather precarious body of the fabrics reach back is a kind of a coupling. And that requires a rather gentle kind of scale of material performance so that we can relax and let it in and also push it out. And so that does speak of a kind of a vulnerability as well as a kind of possibility. So perhaps that taste of a few projects then helps to explain how this kind of diagram then is a kind of a manifesto, and the kind of possibilities then of building this and chorusing and making a kind of collective architecture. Let me speak about a law. The law's embedded, as Dora was speaking just a little while ago, Hamlet, in Shakespeare, in the soliloquy of where, at the end of the day, in the Elizabethan, in a new discovery, death is inevitable. The things are ordered, and the law is that eventually they will fall. if we have a columnar structure, as the extraordinary thinker Joseph Richter, just passed last year, spoke in dancing, that dance is only for a time. And then the earth and gravity takes over, it shatters and dismembers and becomes soil, and equilibrium takes over, and stillness takes over in death. And when I say that, I'm reciting the second law of thermodynamics, which speaks about how heat always flows into cold, and that in the closed system of the entirety of the universe, that absolute equilibrium and absolute differentiation, everything that we are as consciousness and as life and as figure and as crystal, will turn into dust. Am I speaking the truth? I certainly was speaking the truth. I think we've been taught that. I think it's almost a moral obligation to recognize that this is true, that we will die. But is it true that the universe, the entirety of everything, is empty and silent and inert and ultimately cold? When I was a child, I was raised as a very proud atheist. And I quoted exactly what I've just said as a kind of a proud allegiance to existentialism. This is reality. I watched Ingmar Bergman movies, and I savored the empty space in between the interminable drips of water. And I think a kind of joy, pride in the emptiness of space, in the finitude of each planet. And what I was really taught was the radical vacuum of space in between those figures. And when I speak that way, I'm speaking of a kind of ethical enablement of Isaac Newton, when he spoke about how things can act like billiard balls, and each thing has an equal and opposite reaction. And in order to have that kind of revelation of meaning, of how the mechanics of the world works, we need to have a kind of a baseline of emptiness, so that then the clarity of the individual figures can start to work. And it's a beautiful enabling humanist quality, surely, to clear out the ground of sentiment and belief and institutional bias, and instead simply see the void as a kind of courage. I think that there's a very long tradition, certainly in the way we taught architecture, to treat this as a kind of necessity, the moral necessity of trying to make the absolute minimum use of materials, the most elegant, clear shell. Kind of a brittleness is a beautiful crystalline truth. Elegance. Think of Apple design, for example. That long tradition. Apple, the Ulm school before, many strains in the Bauhaus even, although the Bauhaus is rather more complex question. But the long of our arc of humanism, speaking of this kind of boundedness, and yet when we do it, when we make that shell, what do we make? Something excellent for those who are inside it. The optimal use of that territory, the greatest sanctuary. And what are the consequences of working that way? What does it do? How does it work as an architecture? The kind of binary relationships that it creates, you're either with us or you're with the terrorists, is something that surely we must at least question. Surely. Surely we can do more. Let me try to justify why physics says that much more than that is possible, so that this talk is not merely a homily, but rather hopeless protest against the laws of nature and the inevitable. I quoted the second law of thermodynamics and the sense that dust will increase when we have a closed system, that from order, disorder results. This is a truth. And yet, some really extraordinary new physics has been happening in the last 50 years. I particularly admire Ilya Prigogine, who got the Nobel Prize in 1977, who observed that that law is true for a closed system, but not for the practical universe, which is an open system in which starlight and sunlight rains in, and that energy keeps on passing through. And in that kind of universe, that is the universe of a practically open system, not a fictional, transcendentally closed system, standing waves constantly emerge, the waves of the ocean, of swells, of clouds, and things emerge, and they simply do not fall apart. Instead, they last and they cohere. Remarkably durable, extraordinary, tenacious forms. Think of the forms of the dunes, not the sense that they move. Yes, they ripple, but they are standing waves, like weeds, like the toughest of things, rather than the kind of fragile, temporary, forlorn construction, which is destined to go. It does not go at all. It coheres. It is a durability. And more recently, in the last 20 years, some really extraordinary new physics has emerged. Gavin Crookes, 20 years ago, Jeremy England, working today, a young physicist in Boston, who's discovered and established some mathematics that establishes that living systems are like standing waves, but they also create entropy and create disorder, but precisely in a kind of a homeostasis then, which continually refreshes and renews and creates not simply a generation of the interminable templating, which is degenerate, but a continual diversity in which life and consciousness is the inevitable kind of result of the forces of nature, of physics, not by some kind of transcendental act, but somehow inevitable. The reassurance, I think, that this very real new physics offers suggests that it is not some kind of liberal indulgence to defend humanism and art and care that needs to collapse when the chips are down, but rather it is what is the truth. We can rely on it. We can encourage it. By encouraging it, it renews and creates life. Now, I'm speaking way ahead of my depth when I speak soon. But I hope that you can share with me just a sense of a signpost that a new architecture, therefore, is justified and is effective, as opposed to it being a temporary hope which is embattled and which will fail against much, much larger, truthful forces. They are not the truth. When we look beyond the previous images of the telescope that I was sharing at the James Webb, we see some extraordinary new material in that previously empty space. Dust, clouds, filamentary materials. When we average all of that together and model it, what do we see? I love this image. The large Bolshoi simulation, which is all known radio transmissions. It was made just a few years ago. Much better versions of it are available today. What do we see in it? The sense of these granular filamentary networks that make cells that scale again and again and again and that unfold. It's almost impossible not to have a sense of an empathetic response, as if this is very, very similar to our own tissues, our own dendritic matter. This kind of empathy then, that so naturally comes when we see this imagery, I think is a very important kind of way of relating to the consequences of architecture, the crafting of space. And perhaps this underlies one of the reasons why I think it's time to use some new language for space rather than the language of emptiness and void and binary relationships. It's possible to model the relationships that are happening within this kind of version of space. This is just ParaView. This is an open source software. You can download it. And in this space, what we're looking at is called quasi-geostrophic turbulence. That is strophic turning, like the turning of the ocean, coiling, geostrophic, the shifting plates and the makeup of the surface of the earth, quasi, undulating, hiccuping, and continually upwelling and ceasing as local cold, local order, local heat shifts and is absorbed and is continually, rather peacefully exchanged in this churn, creating diversity, creating life. So let me just make a little more comment about the physics before I go on to projects. I spoke about the optimum of geometry, like a sphere. And I think we can see that a sphere has a very significant place to play in architecture, in the sense that it is the maximum possible enclosed territory and the minimum possible exposing surface. So therefore, it's a theoretical optimal architecture, we could say. But it's a very particular kind of architecture, which is optimal for those that are inside it, or for something that needs to retain heat. It's terrible. If you want to lose, you need to cool down, or if you seek interaction. This is somewhat relieved if we look not simply at the figure, leaving the void outside as empty, but if we also look at the milieu. And so if we look at the surrounding space, the milieu, as well as the figure, then we can see most certainly the beginning of extraordinary kinds of exchanges that are lively. And if we look a little bit closer, then we can also see rebounds and exchanges. And even if we're only stuck in a binary sense of relationships, then we can at least see a conversation between the figure and a milieu, which is a tremendous encouragement. And yet we are still, I fear, stuck in binary relationships when we look only at lateral conversations this way. Somewhat relieving that is the alternate optimum. That is to say, instead of focusing on minimal use of materials, rather carefully looking at the maximum possible interaction with the world with the same given volume. And so reticulation, efflorescence, stillation becomes something that is not somehow morally decrepit in the sense of excess or grotesque, but rather is effective and generous and utterly self-fulfilling too, if our agenda is to harvest influence, or perhaps to gather contact with the surrounding world. An architectural language of reticulation, I think, in our envelope making is a very important new craft that needs to be sought, because the humanist tradition has somehow unwittingly forced us into this reductive, platonic, curious shell making sense, which is rendered us brittle unwittingly. So let me make an argument then for, at least in a binary sense, to work both with centralization and also reticulation in craft. And again, we can readily see teachers for it, because we don't need to look simply at a water droplet. We can also look at the other mode of a snowflake. And what happens in the case of that naturally occurring form? I mean, what a lovely sense of the material being drawn and seeking and offering a maximum possible kind of vulnerability and exchange, being pulled into its relationships with its surroundings. Utterly diverse, and yet somehow radiantly coherent. I'm dwelling on this material in order to really try to anchor an argument for the sense that it is not simply a liberal excess which we have to cast aside in order to find vitality and durability. Rather, by looking in a rather whole spectrum of form making, we can find resilience. And it depends on the situation too. I mean, sometimes I was really angry at my parents and I needed to be the person, that defied them. And at other times, I really needed to pull it together and I need to have an unapologetic sanctuary and a kind of a closure and a place of peace where I'm not asked to justify myself or be open or even be generous. Not at all, but rather I can close myself. This kind of oscillation is something that I think we are very poorly equipped to speak about. And I think it's really urgent to develop languages that allow in homeostasis for a deep range of ambivalence in these states, rather than the transcendental sense of you must share or you must be strong and great, as if those are the two choices. What an absurd set of choices those are. So I'll simply offer two, in the sense that precarity then, being precarious, rather than a weakness or a state of danger or an irresponsibility that you need immediately to freeze and clear up as a good responsible architecture, could in fact be a state that we seek and that we very deliberately orchestrate, enabled by the physics that we have supporting us. And similarly, metastability rather than stability. Metastability meaning that I'm oscillating, that I'm constantly working back and forth, that I'm compliant, is a state of extraordinary coherence. It's a state that nature uses constantly. Perhaps we need to look rather closely to notice it because we've been taught to only favor the time when they are absolutely stable and upright. But I think that very quickly our instincts are there. And I think that if we practice it, this could be a very significant new tectonic. Certainly the kind of architectonics that we saw in this beautiful last presentation, where the tensegrity structures oscillate and constantly adjust and move and shed forces as well as accept and oppose. Okay, I'm going to move then to some enabling craft. I've tried to set out some terms, and I hope it's okay if I dwell like this. An example of how I've been working with precarity myself is to make individual components which are engineered so that they are never stable, so that the materials are pulled out to the maximum point of stability. So that at that point, they are maximally vulnerable to any possible influence. And so they quiver and they oscillate and they resound and they become lively. And I'm going to give just one more example from history. I hope you don't mind if I'm giving this rather elaborate background to establish terms of it. So as you can tell, I'm a bit hesitant about it because this is perhaps language that I think is worth exploring and adjusting. And so rather than just positioning this only as a new craft, I want to suggest that actually it is there and it's available in what we find if we look for it. One rather extraordinary discovery is that it exists in a medieval consciousness as a kind of meditation on things that are important. And when, as an amateur art historian, looking at this kind of enunciation from the Christian tradition, this is Bartolomeo Caporali in Perugia, not too far from Florence. I was taught to value this kind of work as being releasing oneself from the rather flat, rigid, awkward geometries of medieval work into the glory of the Renaissance where things were naturalistic and perspective was discovered. And it was really important to discover it. And so therefore we can see the value, for example, this perspectival frame in the background of the floor and also the columniation. And yet something very curious is happening on the right-hand lower side in this. Now this is a really important scene. It's a depiction of the gestation of God. And so this is the beginning of the world as well in this mythology. And yet we see in some cases absolutely commanding figuration, beautiful, beautiful control of lines. And there's no question that this person, this painter is in control. And to anchor that, let's just savor the kind of beautiful carved command. I'm underlining this in order to emphasize the expertise. And then I want to go here and here. And the sense of what is going on in this corner of painting. This is a really important thing. There's cities that are investing in an altarpiece like this. It's a major, major investment. And yet what do we see? We see paint splashing and dripping. What we're seeing is a really extraordinary meditation in which, rather than human control being valued, the meditation is that some things that we are depicting are out of our control. And we need to construct means to be taken and for things to flow and for the materials to speak and for those concrete actions to offer a possibility. And that is really kind of an extraordinary sense, because a rather traditional sense of creed in the Christian Bible is that Lucifer lives down there, and uncontrolled body is something that is evil, and every fiber in our existence is devoted to control and to making the sanctuary, to gaining consciousness, and to taking responsibility for things. So the sense that this is falling to dust is a risk, and yet the confidence that the material is speaking, somehow chorusing, and that the splashing disorder is somehow a revelation of possibility is, I think, a really lovely quality. Now, rather curiously, this tradition in this period from 1400 to 1500 has not been written about, except very, very rarely. But I think it just speaks to the need for another look at turns of history that might offer a much, much subtler quality of finding possibility, building the possibility of theorizing articles. Now, I'm just going to show a couple more images from this same tradition. This is Fra Angelico, perhaps in artists that's more familiar than Caporelli. And in the Christian mythology, touch me not happens in the third day after the Christian God has been crucified and has risen from the tomb and appears to Mary Magdalene, the consort in the garden. And it's a very curious treatment of all of the flowers that are underlying the feet, because we can see that there's a little spot on the hand of the god, stigmata, that's the wound from the crucifixion. And then the flowers are all bearing that same wound and are crying and weeping and bearing an extraordinary kind of material empathy. And even more extraordinary is the way each of those touches of blood, of suffering, are figured, because each one is delivered not in the sense of control, offering a symbol. This is the most important thing, so I've got to be the most careful. But rather, I don't touch it. I allow it to fall. It's a blotch. And for that somehow to be an act of unspeakable reverence, rather than the ugliest carelessness, the grotesque is something that's rather miraculous. It's very striking anyway. I hope that this has a bit of at least a bit of resonance with the discussion of material agency, the Raku discussion, for example, that was raised earlier. I'm just going to show very quickly a couple more just to anchor the sense that this is not just an accident, but actually there is rather definitely something going on here. And I would love company to write about it because I haven't found it done very coherently. There's one art historian, George P.D. Huberman, who's spoken only a bit about it, but not on the paintings that I've encountered in my own life. But here you can see just a few more, which is a revelation, and here we are some more. This is 1455. It's just extraordinary to see it. Now, what I will speculate is that there's a long tradition, which is not the same as this attempt to make things controlled and pure, that might be helpful. And it's the tradition of the Epicureans and the atomists. Lucretius, the famous, the Roman, speaks about this. When he meditates, Lucretius, writing in the kind of, and he speaks about little motes of dust flying in the breeze and in the sunlight and darkening hither and yon and somehow unaccountably swerving and being taken in an act of extraordinary, almost random turbulence as being a meditation on the horizon of light, that there is something in the material itself which quickens and which allows itself to become vital. And there's been a rather lot written about the swerve about 30 years ago, which is very, very, I think, enabling. Deleuze and Guattari rather famously have spoken about this. But what I want to underline, whether or not we're attracted to that philosophy, is that it's possible to have a kind of coherence which allows us to render this in numerical forms and work with that sense of precarity, rather than it being only a kind of a lovely sentiment or an image. Because this is a talk about action, at least I'm trying to point that way. So my amateur sense of the mathematics of that is the minimum angle of derivation. I say that, imagine a straight line tangent, straight vectors meeting the edge of a curve, and imagine the infinitesimally small point at which that line is meeting. We know what a tangent is. We're rigged to understand that. Our consciousness works with this kind of topology. Naturally, it doesn't come out from outside of ourselves. We embody that kind of relationship. And yet, what is that angle as it touches? It is infinitely small. It is infinity less zero. It's that small. It's just the punctum. And the name for that angle is the clinamen, which is a beautiful sense in which difference is the angle itself. And it's not just arbitrary difference or coarse difference or big diversity. It's infinitely small. And I wonder whether it's possible for us to practice it even. And if you look at me rather carefully and look at me in my eyes right now, and that little shift, or the glimmer, or the push, or the quickening, is it something that you see rather readily? When I look at you, I see it. I think we're rigged in our sinuses, in our optic nerves, in our taste, in our touch, have an exquisite sensitivity to just those molecularly small differences. And I think that we can have confidence, therefore, that rather than sensitivity being something that is only good for when we're really, really, really together and when we invest a lot, I think that we can see that that is our craft that we very, very naturally can practice, which produces, I think, a rather different sensibility for sensitivity and the viability of that kind of craft. Now, I'm going to go a little bit more quickly, and I realize I'm dwelling on a few thoughts, but I hope it's okay to continue. These are just a few little exercises for developing that precarity. I want to go through some rather available precarious craft. Here's my dear friend Iris wearing one of the first of the glitch fabrics as it's developing, where that same oscillation is being harvested and emerging as we pull it, and a bit more fabric making using Zoom in order to see those lively qualities being unleashed. In this case, floating over a 3D printed locked bed of tulle, and so there's a rather precarious kind of balance between the unstable ground scaffolding and the pendular elements that are on top of it, rendering this kind of material, and already enjoyed the kind of effect that this has. Rendered into drawing, this becomes a very available craft of drawing rather carefully and trying to control machining kerfs and vaporization and the ability of the material to hold itself, so that then you can find rather empirically the individual limit states of material. And then I'll just quickly skip through building up that kind of vocabulary into an enabling tectonic by using chiral series, by making individual components that can tessellate, by being rather careful about the harmonic convergence of those so that things can scale and cohere together, by working orthogonally in section and plan in absolutely traditional ways, not to reduce, but rather to enable through clarity, so that then a greater complexity and a greater nuance can be achieved, so that individual elements then can be combined very, very deliberately. And that then translated into the wisdom of materials themselves, which then get laser cut or machined or stretched out and derived into these hyperbolic forms, which tend to be rather optimal shapes, and then combined again into sometimes crystalline series, but sometimes aperiodic or quasi-periodic series. When I say quasi-periodic, I mean that they have recurring local orders, but then there are many, many shifts and derivations, which means that there's cross-linking as well. It gives a tremendously resilient, kind of hard to tear, hard to ultimately destroy that kind of organization to them. So this is a pursuit of a kind of a rather tough resilience, a weed-like mongrel kind of resilience. Then that's developed more in cycles in digital space, and turning and curling back on itself into many essays that tend to be ones in which curling into circles and waffles unrolls as well, and the moment of a membrane then becoming its own enclosed figure becomes something that's something of a revelation. And those kind of combinations then of dispersion as well as accumulation turn then in 3 dimensions into a rather deliberate sense of generating quite a resilient, profuse, rather fertile sense of a quasi-architecture, of a beginning primal architecture. We're looking at little models because these are models that are developed for children, but they're also developed for rather resilient public spaces as well that are quite tough and intense, like this expanded scaffolding. It's accompanied by quite a lot of investment in software as well, in order to have the enabling tools for being able to work with it and to animate it. There's some new software that's being released this year called Ether, which is spatial behavior software, where the milieu is being orchestrated so that there's individual influence engines that behave a little bit like the weather, passing through very, very large landscape-like forces, as well as being able to program each individual piece. And this I'm rather excited about the way this is going to emerge. It'll be very interesting to see whether it can be shared. Really, really hopeful that it will be. This then is accompanied by some form language softwares as well, in which the kind of stuttering enablement, in which primed libraries of components, like the ones I was sharing with you, are ready to hop into existence. And so that produces the kind of rather lively stuttering kind of dynamics that you can see in these manipulations. Here's another version of that, which then is not simply elastic nor compressive, but it's a constant oscillation between those sometimes opposing forces to produce really very pleasurable kind of quality. Now, I'm just skipping through some enabling crafts, and I want to point to one more, which is more oriented to perception and pareidolia. Pareidolia is where you see things in clouds and sort of hallucinate the ducky or the pony, and you can't really unsee it once that path has been seen. It's kind of a delicious sense of discovering pathfinding, and it relates very much to the kind of uncanny valley in which you think you're seeing something and you're drawn to it, and potentially you're disgusted by it, but you're fascinated by it. Rather curious part of human consciousness. Here's a little rig where you can see an object which is carefully modeled, and then a data projector contains a digital twin of that same object, and then casts a source of light, creating a real shadow, but very carefully calibrated with that is a generative, constantly changing digital twin, a hallucination of itself. And in that space, then the multiple pluripotencies of the individual components are taken through their possibility spaces, and then they're allowed to offer themselves. And so it's a rather lovely reconciliation in which you can't really tell the difference between the real shadow and the digital shadow. And so therefore, a sense of the curious kind of qualities, the mixed feelings that are related to dreaming seem to be unlocked. I'm really rather hopeful about this being a form that could be shared and worked at much larger scale. I'll just show a little bit more of it, but you can see the physical experience here. This is a show that's touring right now with Sculpting the Senses with Iris van Herpen, and the digital space, which is rigged there. And I'll just show a couple of images where we put this up last year for the very first time in Tilburg before it went to Paris and onward, where you can see the space in between this dress and the surrounding sculpture, which is a really dynamically charged space where the data is projected. And here you can see it boiling, and the dress also is boiling. So that's a combination of two kinds of shadow, which are calibrated so that you can't tell the difference between them. Here's just a little bit more on that. I don't have much language to describe this because this is something that we're playing with, and we're trying to understand the implications, but it seems rather promising. Okay, I'm going to now just skip rather briefly. I hope it'll be brief through 3 projects, and then I'm going to wrap up. This is an older project, right at the beginning, one of the very first, when we started playing with laser cutters 25 years ago, and then contemporary project area, and then the film that I described earlier. And this skips through some of the enabling crafts and the physics that I've been describing. Orpheus filter, which was erected in London, started with the quasi-periodic organization. This is using the Penrose system of tessellation, which is a division of 10 ways. It's a 10-way division of a single point, and then there's combinations of multiples of that division into 10. There's a narrow tile of 1 and 4 times 36 degrees, and then there's another rhombus, which is 2 and 3 times 36 degrees, and that produces the particular kind of stuttering quality of this material. So those are some of the drawings, local combinations of clothing in the elements, but then embedding each of those cells with a kind of an embedded hunger by doing a fissure cutting in which the material, the polyester, incurves and makes something like a leaky heart valve, which pulls material through it and closes when air passes through the other way. And so these individual pores have a lurking quality which then are a little bit beastly because each one collects organic material in needles and nests behind it, and that turns into a rather hungry soil. So just to share a little taste of an early intuition about an attitude of material, which would be very, very gentle, but which would also have some consequences. In the second project, Aria, which is just fresh. This is the first time I've shared these images. It's located in Delft, and it's made of the form language which has been worked on and shared in past years. It's designed as a gathering space, and each of the elements then is designed to be deeply participatory. They're digital twins of each of the components, and they're organized so that they can make architectural chandeliers and canopies and columns. And they were then assembled by large groups of participation. They're rigged with microprocessors, microcontrollers, in which some of the material is conductive, aluminum flashed polyester, and it's rigged for capacitance, for touch, which carries a field. And so you can stroke it and then it will pass on signals from part to part to part. And then because the lights are in part internal, they cast shadows. And then you have the deep kind of projection of a tissue of impulses surrounding the work as well. So I'll just skip through these where you can see the individual fabrics. Generally a triangulated fabric structure, and some of images of the making of it, and some of the interaction that happens. And a rather happy sense of the material being one that receives you, and then rather playfully cascades and ripples and moves backwards and forwards. Some of the software, which is used as a way of rendering it articulate. And then finally, the component system, which is translated into STEAM systems, that is STEM, science, technology, engineering, math, and art, STEAM, as a way of making this a very playful construction play set for children. And that was just shared with me last week. And I rather enjoy the sense that this work then might be contributing to a foundation, at least in Delft, perhaps in other curriculum, where metastability and openness and gentleness and sensitivity and precarity might offer and resonate and demonstrate a kind of a viability rather than a vulnerability or an irresponsibility, because it's pretty tough. And it works pretty well. I'm going to end with just one more project, and this is going to be a rather quiet one. I'll stop talking. This is Cradle. And Cradle, as I mentioned at the beginning of the talk, was made during COVID, a time that we have not recovered from yet. Time that changed us. And it was rather hopeful work because it aspired to be a gathering space. And it included a very, very generous pool where all the hopes personally of years of work were poured into a game engine and a collective work and a digital twin in which we orchestrated a vision of a world rather than the previous project, which was going to be building it quite literally. It is a work that involves a scan of a child, the director's own child, Tilly, who becomes a kind of a hope for a future, but also goes through death. It's it's a vision that you'll see which involves deserts and some profound insecurity, as well as some very great hope. And I hope that hope will underline the other dimensions that you may see in it as well. I hope you don't mind if we just look at them. A couple of images so that you'll recognize Tilly enmeshed. I'm going to sum up. I've spoken rather darkly about an old law, the law that was spoken by Shakespeare and so many others, and about the reality of a certain kind of physics that underlies it, that guides us, that has guided us into the making of a brittle, eternal, transcendental architecture. And I've spoken rather optimistically as an amateur about the evidence that life is viable, is inevitable. I've spoken rather proudly about the atheism which preceded me and which I inhabited, and about the truth of a tissue that surrounds us. I've spoken about shells and optima and the lessons of nature. I've tried to show some practical craft, enabling, and the enactment of a few projects offering a chorus-like optimism for the making of an architecture. I've tried to speak about an ambivalence and a spectrum of manipulations of the centrifugal, of the centripetal, of efflorescence. And in the exercise of those kinds of relationships, it becomes possible to create shells and boundaries and architectures that place us, that can be lateral and that can include and overlap. It becomes possible to envision an architecture which reaches and which folds in and through, enfolding multiple species and multiple dimensions in emplacement. It becomes possible to work with vertical axes as well as horizontal, existential axes as well as the social. And perhaps then that can offer some redeeming qualities to the deeply, deeply vulnerable sense of the loss of our own agency, which I feel, and perhaps you feel at times. And so let me just conclude then with one more speculation. I'm sorry, I can't resist. And this is the very last. Because when I was first with you at the beginning of yesterday, I was very nonplussed about the kind of the turns of phrase and the turns of mind, especially that you offered. I was amazed by them, and I was trying to speculate about what would make it possible to have such revelations. How do we avoid getting stuck? How can we not be brittle when we are subject to such extraordinary forces and strains as our reality? And recently, I'll simply share the possibility that there is one practice, which is a name, a slightly more contemporary name, perhaps similar to the meditation that I was pointing to in Caporali or Fra Angelico, perhaps akin to the license that Dora offered us as well, or perhaps the Queen's recording method, which creates the chorus and which is a beautiful auto-tuning method. Pataphysics, I won't give the history of Jarry who coined the term, but pa is Sanskrit for the foot or the head. The Padma Chakra, for example, is associated with the Buddha that emanates out of the top of the fontanelle, but it still has the same kind of root as well. And so this speaks about a kind of a very elemental physics, and it happens to have an open apostrophe on one side. So then it begs the question of where is the other quote from in the gathering? What is pataphysics? Well, physics is what is. And metaphysics, we know what metaphysics is. Metaphysics is what is. And so you know where this is going to go. Pataphysics is what is. The province then of something other than the binary state of either the body or the mind, either the unprincipled, unvarnished action or the transcendental ideas, the metaphysics that accompanies it, those kind of binary states in which we constantly oscillate into a dreadful, almost unspeakably sad partisanship. To be offered another state, and I think that Jari was offering something extraordinarily valuable as a pre-surrealist when he coined this conception. He offered the province of the fool, of irony, of revelation, of something which lies not simply on top of, but also underneath. And it's that simple habit, that turn of mind, of to look again, might demonstrate this is an available practice. So I've shared a number of terms. I hope some of them might be useful. And I've tried to demonstrate my own optimism in this material craft, which we share with the discipline of architecture. I hope that's a contribution. Longer than 50 minutes, I'm sorry. Please.
A question that I often ask myself, and it makes me feel very, very small. So I'd like to know about your thought. Well, you talk about stability, and your works show that your project seems not to be only developed in 3 dimensions over the time, and like we all manage the drawings with sections, so bidimensional, but we live in 3 dimensions, and your works, the way you use sometimes shades without using object, you project the shades. So, and also you talked about the ambivalence of what's a boundary or not somehow. So, in your opinion, how many dimensions do your project have? You can also say.
Goodness me, how many dimensions? Is it okay if I give two answers? The first is how we practice as architects and what is helpful. And I think that the 3-dimensional space, let's say, okay, that thing, and then how it extends to be a second dimension, where it's come from, where it goes, and then what is the plane of the different variations that occupies a whole field, that what is it like for that thing or that conception then to create a world. Let's say that those are 3 dimensions of space. Fair enough. That's not the same thing as a Cartesian XYZ, but it's related. It's more of a procedural way of understanding 3 dimensions. The thing and its local history, and then what are its consequences in the world. I think that's a fairly reliable answer, and I think that as an architect, meaning perhaps like you, beginning to also experience time in that, not just space, but rather growth and possibility. And so I think that would be a 4th dimension. Only 4. Only 4. And
Well, I'm trying to be honest about, about what my consciousness, what your consciousness does. I mean, that's a lot. That's a whole lot already. But certainly there are conversations between that and another, between me and you. And that means that there are multiple worlds. I mean, locally, as living consciousness and possibilities of participation. Like the first four really were quite local to me and my possibility. So let's say 5 for sure. Okay, that's pretty good. Okay, 5, yeah. And then there are certainly not just you and me with where we have started, but there are other starting places that just could have happened. Yeah. Not just. Yeah. And my life was an immigrant, and I came over in a boat, and if that boat would turn, or the storm would happen, or someone would get more cruelty. Depend on happiness, but I'd rather have a child. But if someone had been nasty, then this would mean that I have a rather different future. So it's not just me, you, and me, and others, but actually there are different possible starts and different histories. So that would be 6 for sure. Okay. That would be 6.
You where you are, and you will be.
Yeah, it's beautiful. And then I think that we can add then the possibility of some different physics, because I'm just speaking about my interpretation of what is happening in that response 6. And in the talk, I'm saying, wait a minute, that's wrong physics. The second law is actually a lie. It's not true. That's good only for the myth of a closed universe, and the universe isn't closed at all. It's open. Things can run through it. So that means that most certainly there's going to be at least a possibility of some fundamental paradigm shifts that are different terms of reference. So I think that is at least rather hesitantly, in an open-minded way, try to look at variation as whether or not we appreciate Blackwell's multiple models and the OMA method of looking at variation there. Most certainly we do try to look at different paradigms. And that's for sure it's separate. Okay? So I'm pretty confident that would be a good cluster. Now, there's some ways of adding a couple more to that, in which we say, well, actually, that's all egocentric. Every bit of what I've said, or it's a Western centrism, and I'm in dialogue with an indigenous elder right now. It's a really lovely experience, and my elder just is involved with settler. He represents a people that was here in North America before my time, and that's only started with humans. So it's, let alone my mother, my dog or Orlando was passed away now. It's my life, and we deeply emotional creature, and it was with me and taught me so much, and that so the sense of terms of reference and truth and dimensions coming from outside are ones that we don't need to really construct in our minds, that we can be pulled into them and supported. Just with bits of empathy, we can even be very selfish about it and just say, I need you, come on, give it to me. Please love me. So that's 8. And then I'm all speaking of construction about the limits of random imagination. And most surely there are going to be other constructions that simply, I mean, the Revelations conference has been beautiful stories that come from such different places, which simply are offerings of new conceptions. And so, at least in human construction, in imagination, we have rather not obvious to us. Well, okay, just have a fresh start. That's just Then, at least, let us conceive that all of that, because we're stretching now, right? At least we can acknowledge
that all of this is based on human sentience and the particular rigging, which means that there's going to be some other possibilities which generate the making of the world, the reality of our motives. And so that one's a very, very distant tenth. Does that work? Okay.
As many as you want.
Now, I've not tried to directly quote string theory, which agrees to 10 dimensions. I've tried to put it in a rather more emotional and local way. And so the version of what I've offered you is a bit different than the way it's organized in traditional string theory. But it does have a resonance schema.
Yeah.
So you can see I'm insecure now, I'm shy, so I have to rely on a different authority to say, hey, that's a reasonable answer, right?
I just wanted to know your opinion. I guess that no one here can have an answer. Okay.
But I think we would be well to work on the fourth dimension. I think that's huge on the.
Okay,
Of course.
Sorry, there are too many thoughts right now. I have to try to put it together as simply as possible. But really appreciate this whole world project. And also, I don't think it's a project, rather it's I really appreciate that show your universe. So I kind of extend from our last dialogue about simulacra about the data. So I mean, yesterday, actually, I presented my presentation that everything started from my imagination, and then it's all it's a process of making it real. So actually, so I'm just curious that so to me, I mean that my new project was simply my simulacra, but someone else's simulation. It's not realized. And then when I present it to someone else, I just kind of made a simulation of what I believe it's a simulation. But as soon as I present my simulation, and as soon as they believe that it's realizable, then they gave me the project, and then I make it real. So my simulacra becomes simulation, and becomes simulacra. And then this iteration means that it started from a seed project. And as kind of bacteria grows larger and larger, this iteration of simulacra from simulation, simulacra, but my imaginative world become a real world. But at the beginning of it, actually, it's real to me. So it's originally it was real, but when it is come to outside, it becomes simulation. But it became simulacra for common simulacra because we must believe that and actually. Project. So one question that I want to little bit unveil that from you is that kind of coming from the dimension of 10. So kind of like I kind of believe that the sketch, your concept, your simulacra become simulation, then actually somebody become a project, and then should become simulacra to all of us to share that. And then after that, I'm kind of curious that how does your so kind of everybody wants to know how everybody wants to know if there's amazing project, want to know the origin. So kind of my question is how your simulacra was initiated, and then so I want kind of unveil or unflatten between your sketches and concept in your project. And we kind of want to know what is the relationship between these two. To me, it's a 10-dimensional distance to me. So kind of like hope to hear what was in the middle and how do you proceed to this amazing project. This very very questions like wrong or
there's a really awful debate in Western history between Plato and Aristotle, where between ideas to action and action to ideas.
the element Plato and the younger Aristotle, which is, I think, a really awful way to proceed. Because even though there's a very, very deep consequence to taking sides, I think that we can decide what our world needs as professionals. This is a discipline that we have committed to. I say we, I say I see this really taken vow. It's good art. I identify with being an architect. The circumstance of what is needed at this particular time is various. It's a very, very important question, and it can come down fundamentally to the question of whether we have too many transcendental ideas, and so we need some action, or whether, on the other hand, we have too much circumstance of just being stuck in stuff that we need some principles to sort the sheep from the goats. And both of those are very, very worthy decisions and very important ones, and yet the ability to do harm by choosing one or the other in a binary state is grave. And if we feel, I'm making this more of a collective response, I'm trying to make it personal as well. If we feel that we must decide in order to uphold our own responsibility, that if the choice that's presented to us is binary, then I think that it's also reasonable to say it must be false, because I have come to believe that things are never ever. If I think it's binary, it's a matter of either or, I am deluded, or at least whether or not I see it that way, I will do harm. I'm guaranteed to do harm if I act. It's a choice, because that choice is based on exclusion, which means I will kill as well as fulfill. I will cut. That's the act. And so I think practicing trinary relations or monist relations, monism being rather lovely philosophy that sees things harmonizing, that sees that we are one, or things are somehow shared, monism, or trinary, which is to say, okay, well, here are a couple of factors, but there must be another thing inflecting it, tilting it somehow, no matter how tiny, how infinitesimally tiny a disposition is, what tipped me into one way or the other in the first place. So that is an ingredient. And I think that human beings are exquisitely rigged. The combination, the indication of the way our sinuses are rigged to work with molecules, even atoms, perhaps. And we know that the synapses in our sentient structure is transactional and material at the level of quantum. Simply atoms, not simply molecules, but actually quantums. The energy exchanges. I say I don't mean forget it. I'm just trying to speak about the sense that there can be a language of ambivalence in which ambivalence is not a weakness, but rather is a representation of ambivalence, meaning that you understand the valence of the milieu as well as the individual situation, which means it's a state of sufficient holistic complexity to be able to start to work responsibly. So I would suggest that ambivalence is a source of wisdom rather than weakness. Now I'm trying to describe a field, and you've asked me an impossible question, which is, where did I begin? And where might we begin? And I began with
a quite happy childhood after a war-torn, unspeakably difficult family history in Europe. And I began by playing, and before that, I began as an infant, and before that, I was coterminous with my mother, and we were one. And that continuum is a really precious state to that really deserves being cared for, I think. And the sense that rather than having a kind of triangle pyramid of responsibility where we acquire self-actualization and become individual and learn how to be responsible about causing hurt and harm and acquiring agency as quickly as possible, I think delaying that release and the emergence of individual consciousness and maybe savoring the sense of the collective where we're riddled, imbricated somehow intraconscious rather than interconscious. Inter means between, intra means something where you are the thing itself, the operations are happening inside. I think that those states are ones to be savored. Now I'm speaking aspirationally rather than honestly. I'm speaking about what I hope my origins are, which is to remember my childhood rather than how I think again. I think that what happens in terms of the beginning of the sketches for this work are that it starts with craft and involvement and the cadence of folding or drawing or working with orthography or working in very, very explicit ways. And the building up of recursive acts is one that in which things can start to cohere, and then certain cadences happen and we start to stutter and we emerge and rhythm happens and then harmonies happen. And so I think it begins with craft, fundamental craft.
That's great. Thank you very much.
All right.
Yeah. Thank you so much, Phillip. I wish you could continue. I know there's plenty more interest in summary dialogue, and I wish we had more time. Unfortunately, we have to get to the architecture floor soon. Otherwise, he's going to bail on us and we won't have a tour at all. And we do need to spend some time with the workshop because they've spent a lot of time and energy and effort putting together their beautiful projects. We were planning to do it in the gallery. Unfortunately, just due to time, we're just going to keep on into this last final panel discussion and just have a few minutes for everyone to kind of check in and talk about how the workshops went and their successes and their failures and the highlights of the things. So I think we'll probably just go down and give everyone 1 to 2 minutes to just kind of give a wrap up about how the workshop went, and then we'll have time for 1 or 2 questions. Please take some time on your way to the tour to look in the gallery. Feel free to come back afterwards and spend time in the gallery as well. I'm going to put the QR code for the AMT2025 WhatsApp group so everyone can connect in there, share future events that you're involved in. I know several people have mentioned events that they're engaged in that they'd like to make other people aware of. This is the kind of things that a community can do for each other. So without any further ado, we'll start with Lucas Brown and the project.
First, I just want to recognize my students. If you would all please stand, wave. I have a couple students here. They've worked extremely hard over the last, since January really, but put in a tremendous amount of time over the last couple of days. We kind of we just jumped into this conference so that we had some dedicated time to work on the bus shelter project. You go into the gallery, you'll see the work that they've done. It was a really great few days. The focus was on the bench, which is basically a module that we're using to create a system for bus shelters throughout Columbus. So I know we're tight on time. I encourage you to go in there, take a look at the work. I'm very proud of you guys, and I thank you very much. And Carolina put a lot of time and energy into putting posters together for this exhibition so that we could see the work, so thank you. I'm gonna go ahead and stop.
Thank you first for the opportunity to having this workshop here. In this workshop about the bamboo structure, we I had in mind that how as a bamboo creator and composition designer can work with some natural material without industrial standard. So we use digital application system languaging and augmented reality in this workshop to fabricate VS Code elements, operate of the VS Code elements and assemble it in just a day here. And here you can see the final identity here. This populate. Yeah, and I really appreciate this opportunity, and I hope that we can develop these kind of using computational design and digital technologies, emerging technologies, in using natural material, something that has it's without any extra energy based on standardizing it or highly modifying it for this. Thank you.
I want to have you because and provide all of the tools that you need and then provide the reality or place to be here and experience with business for many people and also knowing one person that can help us to grow with our research. So the workshop that I was trying to present was to show you the workflow that you have to understand the place that you have to know your material, you have to know your device that you're working with. And by considering this knowledge, to start to design in a new way. So creating that workflow and understanding the way that you can do that with new material, any new material. So you can look at the building with any natural material that you have. And you can get the advantage of using computational design for having more sustainable design and sustainable very producing object. So I work with Hiroko in this design, and we together produce three different methods of using tools with one design. And if you go to the gallery and see how one design can be affected with the tools that you only by changing up the color can be having different meaning in the light and the texture itself.
These are really, really beautiful examples. You make sure you go see those torch specimens.
Design is the same, but only by changing the light and tool we can change very well that object. And yes, thank you for that. This opportunity.
I don't think I had any workshop participants all from, but I'm gonna use this time to make a presentation. So my company is on its 6th or 7th iteration with full house printers, printing with in situ earth materials. And I believe we just finished the first wall and the first economically printed house of earth in the world. That's what I've been doing all week. That site's in Bloomington. You guys are welcome to visit. If you want to come to that space, just let me know. We're breaking ground on our next house and just got a photo today of all the laser cut components for our next 3 machines. So we'll have generation 7 printers running on code compliance, permitted structures, printing in situ earth on material right next to the house. And those are the first 2 in Bloomington, working on Dallas as well.
So I'm sitting in for Nikki Vandenberg. Due to time constraints, she couldn't be with us. But some of the materials for or some of the properties for her company. She is actually, a co-CEO of Niagara Hemp, who's, where she's dedicated to advancing the hemp industry in the United States and using it for like in construction method. And so it's a relatively, as you can see, the properties here, fire resistant, sustainability, highly insulative, and then other really beneficial properties. Yeah. So I'm just going to make this really quick. And I can't do it justice like she could, but just kind of showing some of the properties and how these hemp panels can be used as just an insulation material. And so currently she was getting a house that constructed that are 12-inch walls. And the good thing about this is that her house is going to be built in California, where ultimately fires are always happening. And using this process of the built method, the house can be built in a matter of like a week. And so these panels are constructed in the Netherlands, and then they're shipped here at the moment. So she's working on getting that to where it's more accessible in the United States. And just showing you some materials. And so these are those modules that are then shipped in order to produce the house. And so the maximum lengths of these are 19.8 feet high and then 9.8 feet wide. And they can be constructed in any shape or form as long as they're in those limitations. And so, thank you.
I just can't underscore how much we're grateful for the workshop participants coming from far and wide and just putting a lot of dedicated time. The intent was for this to be intensive, and so we're grateful for everyone's participation in the workshops during this time. We have one or two questions that we can field before we go to the tour of downtown.
Or you just mill around the gallery real quick. Yeah, let's just.
Should we just release the gallery? Okay, great.
If anybody has any questions on the hemp panels, I can get you in direct contact with Nikki. She'd be more than happy to answer any questions.